Hello everyone, welcome to Android Development for Beginners Complete Bootcamp. I have organized this course as a 7-day bootcamp, but if you want, you can follow the entire course at once within 1 or 2 days. If you check the YouTube description below this video, you will see all the subtopics belong to each day with links to the relevant position of the video, downloadable code samples, and additional references. Well, my name is Anushka. I have been working as a software engineer and instructor since 2008. I organized this course to teach you Android development fundamentals step by step with easy to understand code samples. All the topics of this course connected to each other. Please follow the entire course from start to end. During the day 1 of the course, I will show you all the steps of installing Android Studio, and after that we will build your first Android app. You will learn about main components of an Android app. You will learn how to use emulator to run and test the applications you create. I will teach you about activities and their XML layout files, constraint layout, how to use view components such as buttons and text views, how to navigate from one activity to another, toast messages, and how to work with strings. Day 2 of this course is dedicated to teach you Kotlin language fundamentals. I have used Kotlin for this course instead of Java because Android development with Java is an outdated topic now. Google will soon stop supporting Android Java libraries. Over 90% of the professional Android developers now use Kotlin instead of Java. If you don't know Kotlin, it will be very difficult to find a job as an Android developer. But don't worry, I will teach you all the Kotlin you need to start Android development during the second day of this course. I will use this Kotlin Playground online tool to teach you the basics of Kotlin. You will learn about object-oriented Kotlin programming using Android Studio. We will also discuss about Android activity lifecycle during the day 2. We will start the day 3 of the course by learning about shared preferences. After that, using shared preferences knowledge and using all the Android development skills you gained during day 1 and day 2, we will create this BMI Calculator app. You will learn a lot about Android user interface designing and mathematical calculations during the day 3. During the day 3, you will also learn how to use audio and video files. We will create 2 applications to learn how to use audio and video files in Android applications. During the 4th day of the course, you are going to learn about ViewModel and LiveData, RecyclerView, and Kotlin Coroutintes. To learn them effectively, we will build many different demo applications. Day 5 is very important. During the first section, you will learn to use Room library for SQLite database operations, and you will build a complete CRUD application using Room. You will apply everything you learned during first 4 days of the course to complete this project. During the second part of the day, I will teach you about ViewBinding. Day 6 of the course has more advanced intermediate level Android development lessons. During the first part of the day 6, you will learn about Android services and build this StopWatch application. Then you will learn how to communicate with REST APIs and how to get data from web servers and how to send data to web servers using Retrofit library. You will also learn about Android notifications during the day 6. Day 7 of this course is all about Fragments. I will start the day by providing an introduction about Fragments. After that, I will teach you how to use Jetpack Navigation Components library to create navigation graphs and manage navigation between fragments. During this course, I will give you coding challenges and references to improve your skills and to increase your memory. When I say please pause the video and do your exercise, be a good student and pause the video. When I ask you to read a reference web page, please follow the instructions and do so. All the references I have provided are free references. You don't have to pay anything. If you check the description down below, you will see there are starter projects and final projects. Please download the starter project and start coding with me. You may use the final projects to compare your code with mine. Alright, so now it's good time to start learning Android development. Well, I have a gift for you. It is an ebook on latest Android interview questions. I'm giving it for 100% free. Using the link below in the YouTube description, you can download it now. I have been working as a developer since 2008, have participated to many interviews as an interviewer as well as an interviewee. So, if you are willing to get a job as an Android developer, or if you are looking for a promotion from your current job, you should not miss this ebook. I'm giving it 100% free as a gift to you. Thank you for being my student. So, use the link below and claim your gift. Hello everyone. First of all, we are going to install Android Studio. Android Studio is the essential tool we need to develop Android applications. Android Studio is the official integrated development environment or IDE for Google's Android operating system. It provides all the editors, plugins, emulators, and all other tools we need to build Android applications for all the devices. So, what are the system requirements for Android Studio? If you are using a PC with Windows operating system, you will need to have 64-bit Windows 8 or 10, second generation Intel Core or newer processor, or AMD CPU with support for Windows Hypervisor, 8GB RAM, 8GB of available disk space, and 1280 by 800 minimum screen resolution. Similarly, if you are using a Mac, you will need Mac OS 10.14 or higher, ARM-based chips, or second generation Intel Core or newer with support for Hypervisor framework, 8GB RAM, 8GB of available disk space, and 1280 by 800 minimum screen resolution. 95% of the computers have all those requirements these days. If your RAM is not 8GB, you can easily upgrade it. It is much better if you can increase the RAM to 16GB. Android Studio and its emulator works faster with the 16GB RAM. Few years ago, we had to install Java Development Kit before installing Android Studio. But now, it is not required. Newer Android Studio versions, after the version 2.2, comes with the embedded OpenJDK. Android Studio has its own embedded Java Development Kit. Therefore, it is much easier to install Android Studio now. So, firstly, I am going to show you how to install Android Studio in a Windows PC. After that, I will show you how to install Android Studio in a MacBook. So, if you are using a Mac, it's okay to skip this part and watch the next part. Similarly, if you are using Windows, it's okay to skip macOS part. So, let's do a Google search, download Android Studio, then click on this link from the Google's official developer.android.com site. What you see here might change in few days, but most important thing is remember to download Android Studio from the developer.android.com's link. Here we have the download link. Click on that. We need to agree to the terms and conditions. Then click on Download Android Studio for Windows button. Then you can see here in this bottom right corner, Android Studio has started downloading. It will take some time, around 5 to 10 minutes, depending on the speed of your internet connection. So here we have completely downloaded Android Studio Windows.exe file. Let's click on it. Click on Next. Then here we have Choose Components window. If you haven't selected this Android virtual device, select it now. Click on Next. Then here we have the installation location. I'm not going to change it. Click on Next. Then choose Start Menu folder. If you want to have a different name than Android Studio for the Start menu, you can give it here. Then click on the Install button. You can see Android Studio is installing. Installation completed. Let's click on Next button. Then select Start Android Studio and click on Finish button. Here I am keeping this selected. Here Google asking if we are okay with data sharing. I am okay to send usage statistics to Google. It will help them to make Android Studio better and better in future versions. So I am selecting Send Usage Statistics to Google button. Here we have a message saying Kotlin plugin update available. It's always good to keep Kotlin up to date. So click on Update. You can see downloading plugin updates notification. This might take a little bit extra time. Now, Android Studio wants us to restart it to apply changes in plugins. Click on Restart. Android Studio is restarting. We got Setup Wizard window again. Let's click on Next. Choose the type of setup you want for Android Studio. Select Standard and click on Next. Then here we have Select UI theme window. I would like to code with darker theme, so I am going to keep this Darkula theme selected. But if you like lighter background, you should select the lighter theme. Then click on Next. Now here we have the current setting. If you want to change any of them, now it is the time. You can click on this previous button, change them and come back. I'm okay with these settings, so click on Finish button. You can see Android Studio is downloading components from the Google's repositories and install them for us. This will take a little bit more time. Finally, now we have Welcome to Android Studio window. Let's click on New Project. Here, in the left-hand side bar of the window, you can see 4 categories: Phone and Tablet, Wear OS, Android TV, and Automotives. Android Studio provides a set of templates can be used for each of them, so don't have to create projects from the scratch. And this saves a lot of time and the pain of different configurations. For now, select the empty activity, then click on the Next button. Just keep the name as My Application. You can give any name you like. This is the package name, com.example.myapplication. We can give any package name we like, but it should take this same format. And this is the save location. Again, you can provide any location you would like to save this project. Language is Kotlin. You can choose language from here. In this course, we are going to use Kotlin, which is the language of modern Android development. all the new advanced features available only in Kotlin. Google still supports Java, but they will end supporting Java soon. Minimum SDK is API 21. From this menu, you can choose the API version. So, your app will run approximately 94.1% of devices. That means this app would run on devices which has 21 or higher API. If you choose a lower API version, then app would run on more percentage of available devices. Similarly, if you choose a higher API level, app will run on relatively less percentage of devices. Let's keep it as API 21. Then click on Finish button. So this is our new project. Wait until Android Studio get properly created the project. You can see it from here, from this progress bar. Project is still building. You need to provide uninterrupted internet connection here, because Android Studio has to download required libraries from online repositories. This is the first project of this Android Studio, so it has to download a lot of components from the internet. But next time, since Android Studio has already downloaded components, it will take much less time than this. Finally, Android Studio has built the project template. What's new in Arctic Fox? Arctic Fox is the name of the current Android Studio version. You may take time and read this, but I'm going to click here and minimize it. So, this is a Kotlin file, main activity.kt, this file, and this is its XML layout file, activity_main.xml, which creates the layout of the screen. Click on that. You can see the screen layout with text views which display Hello World. This XML file has 3 modes. Code mode, which shows the XML code only. Split mode, which shows both XML code and the screen. And then the design mode. Let's try to run this project with an emulator. This green color arrow head is the run button. We got a message saying no target device found. That is true, because we haven't installed any emulator yet. Virtual devices or emulators allow us to test our applications. You can see this shows no devices. Let's click on that. From the menu, select AVD Manager. This Your Virtual Device window supposed to show the list of all the emulators we have. We don't have any virtual device yet, so let's click on this Create Virtual Device button to create a new one. We have TV, phone, Wear OS, tablet, and automotives. For now, we will create a phone. Let's create this Pixel 4 emulator. Then click on Next. Seems like we have a problem. HAXM is not installed. HAXM stands for Hardware Accelerated Extension Manager, which is essential for launching emulators. So let's click on Install HAXM link. Click Next. HAXM has installed successfully. Click on Finish. This window still shows the HAXM not installed message. So let's close and reopen it. Now it's okay. I'm going to create this emulator with API level 30. Download this one accept the license agreement and click on the next button. Let's wait until Android Studio download it. Downloading is completed now. Click on Finish button. You can see here. So that means we have successfully downloaded the components. Click on Next. Click on Finish. Good. Now we have a virtual device. So let's choose this one and run the app again. For the first time, it will take a little bit extra time. But after that, when we are launching emulator next time, it will not take that much time. So this is our first app. You can see the text view with the Android Hello World message at the center. Actually, we didn't do anything. We just ran the template. Soon, we will do some modifications to this app. Now, I am going to show you how to install Android Studio on a MacBook. If you are using Windows, since I have already shown how to install Android Studio on Windows, you may skip this Mac OS part. So, let's do a Google search, download Android Studio, then click on this link from the Google's official developer.android.com site. Here we have the download link for the Android Studio. Click on that. We need to agree to the terms and conditions. After that, click on Download Android Studio for Mac button. We have a notification. Do you want to allow downloads on developer.android.com? Click on Allow. You can see in this top right corner, Android Studio has started downloading. It will take some time, around 5 to 10 minutes, depending on the speed of the internet connection. Alright, so here we have completely downloaded Android Studio DMG file. Let's click on it or launch the Android Studio DMG file. Next, we need to drag and drop Android Studio into the Applications folder. Then we need to open the Applications folder and launch the Android Studio. Here we have another notification. Android Studio is an app downloaded from the internet. Are you sure you want to open it? Yes. Click on the Open button. Here we have Import Android Studio Settings window. Let's keep Do Not Import Settings option selected and click OK. You can see Android Studio is opening. Here Google asking if we are OK with data sharing. I am OK to send usage statistics to Google. It will help them to make Android Studio better and better in future versions. So I am selecting Send Usage Statistics to Google button. Then we got Android Studio Setup Wizard window. Click on Next. Here we have a message saying Kotlin plugin update available. It's always good to keep Kotlin up to date. So click on Update. You can see downloading plugin updates notification. this might take a little bit extra time. Now, Android Studio wants us to restart it to apply changes in plugins. Let's select Not Now option. We will restart Android Studio later. And here you can choose the type of setup you want for Android Studio. Select Standard and click on Next. Then here we have Select UI Theme window. I would like to go with darker theme, so I am selecting Darkula theme. But if you like lighter backgrounds, you should keep lighter theme selected. Then click on Next. Now, here we have the current settings. Those are the settings we just chose. If you want to change any of them, now it is the time. You can click on this previous button, change them, and come back. I am okay with these settings. Click on Finish button. You can see Android Studio is downloading components from the Google's repositories and install them for us. This will take a little bit more time. Then here we have a notification saying HAXM installation wants to make changes. This HAXM stands for Hardware Accelerated Execution Manager, which is essential for launching emulators. So I am going to provide my password and click OK button. Here we have another notification. System extension blocked. This is a security concern. macOS wants us to confirm that these new softwares we are installing do not harmful to the system. So let's click on Open Security Preferences button. Here we have Security and Privacy window. Let's click on the Lock to make changes. Here we have another message. System Preferences is trying to unlock System and Privacy Preferences. Touch ID or enter password to allow this. I'm going to use Touch ID option on my MacBook. Alright. Then click on Allow button. Here we have another notification. A restart is required before new system extensions can be used. Okay, let's click on Restart. So system has restarted. Now you can see the Android Studio icon on the dock. Let's click on that to open Android Studio. Finally, now we have Welcome to Android Studio window. Let's click on New Project. Here in the left hand sidebar of the window, you can see categories. Android Studio provides a set of templates can be used for each category. So we don't have to create projects from the scratch. And this saves a lot of time and pain of different configurations. For now, we are going to use phone and tablet category. From the templates, select the empty activity, then click on the Next button. Now we have new project window where we set name and other basic properties of the project. Let's keep the name as my application. You can give any name you like. This is the package name, com.example.myapplication. We can give any package name we like, but it should take the same format. And this is the save location. Again, you can provide any location you would like to save this project. Language is Kotlin. You can choose language from here. In this course, we are going to use Kotlin, which is the language of modern Android development. All the new advanced features available only in Kotlin. Google still supports Java, but soon they will end supporting Java. Minimum SDK is API 21. From this menu, you can choose the API version. See, your app will run on approximately 94.1% of devices. That means this app would run on devices which has API 21 or above. If you choose a lower API version, then app would run on more percentage of available devices. Like if you choose API level 16, app will run on 99.8% of devices. Similarly, if you choose a higher API level, app will run on relatively less percentage of devices. See, let's keep this as API 21. Then click on Finish button. So, this is our new project. Wait until Android Studio completely create the project. You can see it from here, from this progress bar. Project is still building. You need to provide uninterrupted internet connection here, because Android Studio has to download required libraries from online repositories. This is the first project of this Android Studio, so it has to download a lot of components from the internet. But next time, since Android Studio has already downloaded components, it will take much less time than this. Here we have another notification in the bottom right corner. Studio performance could be improved. Let's click on Actions. Select Use Recommended and restart from the menu. Alright, finally, Android Studio has built the project template. Here we have the tip of the day window. Every time we open the Android Studio, it shows a tip. That is good. So, by reading those tips, you can learn about shortcuts and other new features of Android Studio. For now, let's just close it. Now, let's try to run this project with an emulator. This green color arrowhead is the run button. Android Studio has already installed an emulator for us. You can see it here as Pixel 3a API 30x86. If you want more emulators, you can download them from the AVD Manager. Let's click here and select the AVD Manager from the menu. To create more emulators, click on this Create Virtual Devices button. We have TV, phone, Wear OS, tablet and automotive. It is better to have more than one emulators for testing. We must test our apps for at least 5-6 devices with different variations before upload them to the Play Store. To create a new emulator, select the name like this and click on Next button. Since we have an emulator, I am not going to create a new one right now. Let's close these windows. Now, click on the green arrow button to run our first app. Since we are launching this for the first time, it will take a little bit extra time. But after that, when we are launching emulator next time, it will not take that much time. So, this is our first app. You can see the text view with the Hello World message at the center. Actually, we didn't do anything. We didn't do any coding. We just ran the template. So, now it is time to start learning about each and every code component of this app. Now we have installed Android Studio and created our first Android project. So, first of all, I am going to tell you more about folder structure of an Android project. By the time you complete this course, you will be able to learn about all these things with experience. But for now, as a start, let's very quickly go through the folder structure of an Android project. So, let's start from the manifest folder. This manifest folder contains Android manifest.xml file. Okay, let's click on it to open it. This is very important. Every Android app has an Android manifest.xml file. This file contains information that a device needs in order to run the app. This XML file acts as an intermediator between Android OS and our application. When a user taps on app's icon, Android operating system firstly reaches to Android manifest.xml file. Then, using the information available in the Android manifest.xml file, system decides what to do next, decides what activity to open first. As example, here you can see we have an intent filter. This intent says this is the launch activity. Using this information, Android operating system decides to launch this main activity first. Manifest file contains details about all the activities. For the demonstration, I will create another activity. When we create another activity, Android Studio will automatically add another tag set for that new activity inside this Android manifest.xml file. So this is how we create a new activity. Select app, new, then from this menu select activity. Here I am selecting empty activity. I am naming this activity as second activity. Second activity. This is the layout name, activity second. We will talk about that very soon. This is the package name. So I am clicking on finish button now. You can see we have another activity here, second activity. And these are the XML and Kotlin files of the second activity. Now, if you check the manifest file, you can see we have a new set of tags added for the second activity inside the manifest file. Now, if you cut this intent filter and paste it inside this second activity, then that second activity will be the launch activity. So that activity will launch first. I'm not going to do that now. You can do it as a homework exercise. And this manifest file also contains the package details of the application, com.example.myapplication. This is the package. Package of the all Kotlin classes belong to this project. Also, if we are adding any permissions, like as example, if we are writing codes to deal with the REST API, we need to provide permission to use internet connection. So at that time, we will add internet permission inside this manifest file. You can add different permissions inside this manifest file. You will learn that later. Okay, now I'm closing Android manifest.xml file. Next, we have Java folder. This Java folder contains all the source code files we create during the development of the app. As an example, we just created a new activity named second activity. So the Kotlin file second activity.kt created inside the Java folder. Java folder has 3 subfolders, subdirectories. This directory to store source code files. These 2 directories, test and Android test directories, are there to store test files. We use this test directory to create test cases, normal unit test cases, classes related to normal unit testing. We use this Android test directory to create classes related to instrumented testing. That means testing involved with the device. We are not going to use them during this beginner level course, but we will use this directory all the time. Next we have another Java folder, but this folder contains generated classes. All the time, Android Studio will generate a lot of classes for us to make our life easier. Whenever we use supporting libraries like Room, Retrofit to save our time, to make our work easier, they generate a lot of files for us. Those generated files will be stored inside this generated Java folder. You may have this question. We are using Kotlin programming language. Why this folder named Java? Because Kotlin language has created on top of Java language, on top of Java libraries. Kotlin is like more advanced, more modern version of Java. So that's why they haven't changed the folder name to Kotlin. Okay. Next we have res folder. This res folder contains all non-code resources. This folder does not contain Kotlin files, but all the other related resource files of the app, such as XML layout files, string resources, and bitmap images. This folder has also divided into 4 subfolders named drawable, layout, mip, map, and values. This drawable subfolder inside the res folder contains all the different types of images we used for the development of the application. Every time we add a new image file, we add it into the drawable folder. Here we already have 2 XML files. If you click on them, you will see they are in XML format. These are default icons. But we can also add JPG files, PNG files, all the image files into this drawable folder. Then we have layout folder. Layout folder contains all the XML layout files. For this main activity.kt file, this Kotlin class, we have a corresponding layout named activity main. This is the activity main layout. So that layout file is stored inside layout folder, the activity we just created. Second activity.kt. This second activity Kotlin class has its own activity_second layout file. So this activity second layout file is also stored inside this layout folder. What do these XML layout files do? These layout files create the view, the screen, which contains all the buttons, text views, drop-down menus, everything. You will learn that very soon. So what do these Kotlin files do? These are view controllers, like activity_main.xml is the view screen. Main_activity.kt is the controller file of that view. We write codes which controls that view inside this Kotlin class. Similarly, activity_second.xml file is the view. Second activity.kt Kotlin file is the view controller. So these are Kotlin classes. Second activity is a Kotlin class. Main activity is a Kotlin class. They both have extended app compact activity class. Their parent class is app compact activity. With practice, you will master these things. Now, after that, we have mip map folder. This folder also contains images, but this folder contains different icon files used in the app. And you can see there are different sizes: HDPI, MDPI, XHDPI, XS, HDPI, XXX, HDPI, NEDPI. These are the different sizes of the fonts. Like in the market, there are different sizes. If you go to a shop to buy a phone, there are different screen sizes. So we cannot use one icon for all the fonts. For larger fonts, we need to use large icons. So if we add new icon, we need to add them in different sizes. Then we have values folder. Let's close these icon files. This values folder contains XML files to hold different default values of the project. Like if you open the colors.xml file, you will see these are the defined colors. So whenever we use this color inside the app, we don't have to type this hexadecimal value. Instead, we can refer to it using this name. And this is strings.xml file. We have only one defined string here. But you will see when we are creating applications, we define all the strings inside this strings.xml file. So whenever we need to change those strings in future, we don't have to read all the codes and change all the places. Instead, all we need to do is open the strings.xml file and change it. And also, these string values are reusable. As example, let's say for the save button, we create a string here, like string name, save button, save the image. Okay, save the image would be the text on the save button. We might use that text in 3 different places of the app. So we don't have to type that in 3 places. Instead, we will just refer to the name of the string. And whenever we want to change that in future, all we need to do is open the strings.xml file and change it. Inside the values folder, we have another subfolder named themes. These files contain details about the theme of the project. For this project's theme, these are the sets of primary and secondary colors. If you want, you can change them here. And if you are going to use a customized theme, you will also put that new themes XML files inside this themes folder. Let's close these files. Next we have Gradle scripts. These are very important. Gradle is a automated build system. So because of the Gradle, we don't have to manually do different configurations. We don't have to download different libraries and put them to a different folder and write our own configurations. Gradle automatically do all those things. So these are the different files Gradle uses to define those build configurations of our application. These 2 Gradle files. This one, this project one, we call this project level Gradle file. This one called app level Gradle file. These 2 files are the Gradle files we use most of the time. Especially this app level Gradle file. Whenever we add a new plugin to the project, we need to define it here. As example, if we add Kotlin capped plugin, we type id Kotlin capped here. And every time we are using another library, we need to add those dependencies here and sync the Gradle. As an example, let's say if we want to use Room supporting library in this project, we'll open the web browser, we'll search Room dependencies, and from here, see, these are the dependencies. We will copy these dependencies and paste them inside this dependencies block of the app level Gradle file and sync the Gradle. You will see that in many times during this course. I am not going to make this very boring by providing all the details at the beginning. There are a lot of other areas in Android Studio which I haven't covered, but you will learn them in time. By the time you complete this course, you will learn most of them. As an example, we will build a complete application using Room database. During that lesson, you will learn how to use Database Inspector. When we are using log values, I will teach you how to use logcat, right? You will learn all the components of Android Studio with time. So now let's do something a little bit more interesting. Okay, I'm going to close these two files we newly created. I'm going to click on this activity.main.xml file. So this is the default screen we have. Here, from these tabs, you can change this to code mode. Then you will only see the XML code. Split mode, you can see both code and design, and the design mode. Let's go to code mode. Please open your Android Studio and do what I'm doing. Pause the lesson time and practice. Don't just watch the lesson, then you will not get anything. You will forget everything within several minutes. Please practice with me. That is the only way to master anything. Practice makes perfect, right? Okay, so this is the XML file. You can see we have Android X constraint layout. This is the layout type we have here, constraint layout. There are other layouts. We have linear layout, we have box layout, but the one we have here is, default one is constraint layout. Then we have XML namespaces. These are default codes. You don't have to remember these things, right? Every time you create a new activity, Android Studio generates these things. But this one is important. This is the text view. This one. This is the text view. Hello world. Right? All the properties of that text view is, I'm going to drag this one. Okay. Layout width. Width of the text view is wrap content. That means it takes the width of the content, width of the phrase, hello world. Then layout height, again wrap content. This height of the content of the text view. Text is hello world. These are the constraints belong to the constraint layout. These constraints, they generate automatically. You do not remember them. As example, if I take this to here, right? See, they automatically generated. You don't have to worry about that. Now, shall we change the text? Let's change this as hello from Android. You can see the text changed. Let's also change the font size of the text. Now, there are two ways to do this. If you are an expert, you can just type the XML code. But that's unnecessary waste of time. Because long time ago, like in 2010, Android Studio did not provide this much facilities. So we had to type them manually. But now Android Studio provides all the facilities, so we should not waste our time doing manual work. Let's click on design mode. Now you can see here. See these different attributes. You can use them, right? If you want other view components, you can just drag and drop them to this screen. We will do that later. Now we need to increase the font size of this text view. So select the text view, click on that. You can see constraint layout. We have one view component inside the constraint layout. Text view. Select it here. You can select it from here or from here. Then we haven't given an ID. If you want, you can give an ID to this one. I'm going to give the ID as text view. So I am typing TV hello. You can provide any ID you like. See, you can even set constraints from there. Do your own experiments. Play with them. Master the subject by playing with them. Here is the text. There are a lot of properties. You can do a lot of things with these text views. We want size. Here we have text size. So I am changing this to 34 sp. You can see text size increased. Okay, shall we also change the text style? Okay, I'm going to select bold. Okay, now bold became true. Alright. Shall you also change the text color? Let's click on this one. Can you remember these colors? They were inside those values folder, colors.xml file. Right. Okay, let's select this color. See, they were from this values folder we just discussed, colors.xml. See, you can add more colors if you like. Just find the hexadecimal code and add it. Then they will display there, right? Okay. We can even add padding, can do a lot of things. Okay, shall we just run the app for now? How can you run the app? There are different ways to do this. Easiest way is click on this green color arrowhead. This is the run button. There are other ways. You can use the top menu. Here you can see run. Then select run app. That's another way. Right? There are different ways to do it. Well, let's do the right thing. Quickest thing. And here we have selected the emulator. We have only one emulator. So I selected the emulator. If you have connected a physical Android device, Android phone, to your laptop, then name of that device would also be displayed here in this menu. But I haven't connected a physical device. I prefer emulators more because you can have any number of emulators for testing. So emulator has already selected here. So then I am clicking on the green color run button. So let's run the app. It will take a little bit time. We need to wait. App is launching. You can see this is our modified text message. Now, I hope you also changed the text on the text view and ran the app. If you haven't done that, please do it right now. Don't just watch the lesson. You will not get anything by just watching. Please do your coding. Please practice with me. Okay? At the beginning, these things may seem a little bit difficult, little bit unfamiliar to you, because your brain has very small amount of links for Android development. But when you are practicing, your brain will create a lot of links, and with time, within 2-3 days, Android development will be very easier for you, right? That's how we learn anything, right? So please practice. Practice as much as possible. Don't just limit it to things I do. Start doing your own experiments, right? That's the way. That's how you can become an expert in Android development. Alright. Now, this app is running in the emulator. So how can we stop it? By clicking on this red color button. Stop app. Alright, app is stopped. If you open the emulator, you will see that there is no app there, right? Okay, now I'm going to teach you something. Switch to code mode. Can you see this thing? When we switch to code mode, Android Studio has highlighted this one. Here we have a bulb sign, right? So this is a tip. Android Studio is trying to help us. Click on that. Android Studio telling us to extract existing resource. Writing text content inside the XML code like this is not considered as a good coding practice. Why? Because developing a professional level app is not a one-time thing. After we launched the initial version of the app, we need to continuously add new features to it and change existing features of it. Also, an app can be developed by many different developers. If we hardcode text like this, we might need to write same text in many different places. Then it will be very difficult to find and update them in future. And it will be very difficult to provide multi-language support. So we need to keep them in a separate location in this strings.xml file. In strings.xml file. It is very easy. You don't have to open the strings.xml file and type them manually. Android Studio will do that for us. All we need to do is click on this bulb icon and click on extract string resource. Resource name. Okay, you can give any name you like. And this is the resource value. This is the text value, right? And by default, Android Studio don't know the name, so Android Studio automatically set the same words with simple letters connecting with underscores. If you want to give a different name, let's give it as hello message. Then click on OK button. Now you can see here text change to string / hello message. Let's open strings.xml file. You can see now we have a new tag, string name, hello message, hello from Android. So that's how we add string resources. Alright. Let's move to design mode again. Next, we are going to make this app a little bit dynamic. Let's add some user interaction. Let's allow user to type the name and click on a submit button, and then the app will display a welcome message with the entered name of the user. So now I'm going to add another view component to this screen. This time let's add a text input field. We call edit text for the text input field widget in Android. To find and edit text to drag to the layout design, let's click on text. Now in the right hand side you can see we have a bunch of different types of text input fields and other text related components. We already used text view. This plain text is the one we are going to use now. When we are creating login form layouts, we can use these two for normal and number only passwords. So the text we typed will not be displayed. Instead, we will see black color dots. Then we have email, phone, postal address, multi-line text, time, date, and many more. Using these specific text input fields, we can very easily implement validations. Writing codes for validations will be easier if you use these special text input fields in your layouts. But for now, let's just drag and drop a plain text. Let's place this in the center. Now, these four are to add constraints. We have two vertical constraints and two horizontal constraints. To define a view's position in constraint layout, we must add at least one horizontal and one vertical constraint for the view. Let's check this text view we previously worked. These are the constraints of the text view. I'm going to switch this to split mode so we will be able to see both design and the XML. You can see these are the XML properties and values created for the constraints of the text view. But if we check the XML of our new edit text, you will see that it doesn't have those properties and values yet. So now I am going to add one constraint towards the bottom. Just drag it towards the bottom using mouse pointer. You can see a new property has generated in the XML. Then I am adding another constraint toward the right border. Then another one to the top and another one to the left. Now we can position this view as we want on the screen using these constraints. All we need to do is dragging it using the mouse pointer. Like this. You can see values of constraints layout properties in XML are changing. See, this is very easy. You can place it anywhere you like. I'm going to place it below the text view like this. Let's switch to design mode now. In the text view, we set the text size as 34 sp. So, I am going to set the text size of the edit text to a closer value to that. We are going to use attributes. If it is not visible in your Android Studio, you can just make it visible by clicking here like this. Then select the edit text. So now these are the attributes of our selected edit text. They have given a longer ID. You can keep it if you want. I would like to change it to a shorter ID. TV name. Refactor. Then scroll down to find the text size. Here are text properties. Let's change the text size into 24 SP. We don't want to keep this text value here. Let me run the app and show you the reason. Let's run the app on emulator. You can see this text input field already have a value. If the user try to type a new value, it will be typed after the initial value. Then user will have to remove it first and then type. That is not a user-friendly practice. So let's remove the text value and add a hint instead. Remove this value. Then find the hint. Let's say type your name as the hint value. You can see the hint. Let's run the app again. Now, when we start typing, hint will disappear. See. Then I am going to add another button to this design. Okay, I want you to try this first. This is a coding challenge. Drag a button from the palette and then drop it below the edit text. Have you done that? Okay, then set the constraints. It's very easy, right? Just use the mouse pointer. Set the constraints to the parent view. Do not set them to other views. Have you done that? Right. Then, if you want, give an ID to the button. You can keep the default ID given by the Android Studio, or you can provide any ID you like. Go to attributes, type an ID. Hope you all did that. Then scroll down, find the text attribute and set the displaying text as submit. Then make the text bold. And also change the text size to 24 SP. Alright. I hope you all did the exercise successfully. That's great. Now you have learned some Android development. Aren't you? You are an Android developer now. Congratulations. So, for those who couldn't complete the exercise, let me very quickly show how to do it now. Let's go to buttons. Drag a button. Then set constraints. I am changing the ID as btn submit, btn for button. Refactor. Then set the text as submit. Let's scroll down to find other properties. Set this style as bold. Then I am changing the font size to 24 SP. So that's how we do it. Now let's run the app and see how this looks in our virtual device. Next, I'm going to introduce you an amazing, very useful, especially very much time-saving feature in Android Studio named layout validation. You know, when we are developing professional level applications, we must test them for different devices with different screen sizes. This feature allows us to observe how our UI looks in different user interfaces. Click here to open UI validation window. Then scroll down. See, Pixel 3, Pixel 3 XL, Pixel 3a. This is the size of our emulator. Pixel 3a XL, Pixel 2. They have provided many different screen sizes. This is how our layout will look on different screen sizes. If you see any mismatch, you can change it and check again. With constraint layout, making changes is very easy. Just use the mouse pointer. Here, they have provided a lot of other options. You can also select Wear OS devices. Let's zoom them from the bottom right corner. Our app seems not looking good for Wear OS, even though it's just a demo app. If you want, you can do some adjustments. We can also test for different project locators, that means for different languages. We are not using multiple languages in this project, so it will not show any different screens, only the default one. Here, Android Studio has provided facility to create our own custom layouts. And here we have validations for different color binds. Next, validations for different font sizes. Testing is a big subject. I'm not going to spend much time on it in this beginner level course. So let's go back to our project. Next, for the first time in this course, we are going to write some Kotlin codes. I don't know Kotlin. I have only learned a little bit of Java. This man is crazy. He's going to use Kotlin without teaching the basics. I know. Some of you may have started thinking like that, but don't worry. Kotlin language is just an easier edition of Java. Kotlin is actually much easier than Java. Anyone can learn all the Kotlin required for Android development while developing applications. At the beginning, it will seem a little bit unfamiliar, but after some coding, you will be okay. But don't worry, I have included a separate section for Kotlin language fundamentals in this course. After this first section, our second section of the course is going to be Kotlin language fundamentals. So, you will learn all the Kotlin required for basic Android development very soon. So, let's start. This is the main activity. Main activity is the layout controller class of the activity main XML layout we just designed. That XML file has connected to the class through this setContentView function. In Android, onCreate function is called when the activity is first created. This function is where we should do all the normal setup codes like creating views and binding data. And what is this super.onCreate saved instance state function call? This provides us a bundle containing the activity's previously frozen state, if there was one. We'll learn how to use that later. Now, we have 3 view components in our XML layout file. We have text view with the ID TV hello and edit text with the ID TV name and a button with the ID BTN submit. So, before you use those views, first of all, we need to create those views inside the onCreate function. Primary way of doing that is using the findViewById function call. Well, greeting text view, val is the Kotlin keyword for read-only values. Greeting text view is just the name I gave for the view we are using to create. You can literally give any name you like. Here we have used camel notation in Kotlin and in Java. When we are combining more than one words for a name, we use camel notation. We start the first word with a simple letter. We keep the first letter of all other words capital. Equals find view by ID. Here we need to give the type of the view. Then here we need to provide the ID of the text view. What is the ID of the text view? Switch to ActivityMain.xml. This is the text view. ID is TV hello. So r.id.tv hello. Next, I am going to write codes to get the edit text. Well, let's name this as input field equals find view by ID. ID is TV name, this one. Now, here is a coding challenge for you. Please pause the video now and write codes to get the remaining view. We have a button remaining. Congratulations, I hope you all completed the exercise successfully. For those who couldn't complete it, don't worry, I'm doing it now. Well, let's say submit button equals find view by ID button r.id.btn submit. Here Android Studio tells us to import the widget. Click on import. Here Android Studio has imported it. Android Studio has imported other two widgets earlier. You can see the import statements. Next, we are going to implement the on-click listener of the button. This is how we do it. Submit button dot set on-click listener. Now, whenever user clicks on the button, code we write inside this click listener block will be executed. This is where we are going to write codes to get the typed name and display it as a welcome message. Well, entered name equals. Now we need to get the text value user typed on the edit text. We have already written codes to get the edit text using find view by ID. We named that view object as input field. So input field dot text. This text property gives the content on the edit text as an editable object. To display it in a text view, to use it as a string, we need to convert that editable to a string format. So dot to string. Next, we will create a message using that. Well, message equals. In Android development, in Java, in Kotlin, to create a string object we use double quotes. Let's add double quotes. Then welcome. We are going to use the entered name variable we created above. In Kotlin language, when we are using a variable inside a string, we need to type it with a $sign. $sign entered name. Okay, you know, these things are very much new to you. So you will feel like a little bit confused. That's because you are writing your very first Android app. It's normal to feel like that. But don't worry. Trust me. Trust the process. I have already taught Android development to thousands of students. I have organized this course in a way you all can step by step learn Android development fundamentals within a very short period of time. Just trust the process and keep coding. By the end of this course, not only you will remember these things very well, but also you will learn more advanced code patterns than this. These code parts will be much easier to you. Alright, now we have a message ready. Let's write codes to display it on the text view. We are going to use the text view we defined above. Text view.text equals message. We set the message string we created as the value of the text property. So now it is good time to run the app and see how this works. To see the result of your first Android coding, let's click on Run button. So far everything is okay. Type your name here. I'm going to type my name. You should type your name. My name is Anushka. Now click on the submit button. Yes, very good. Our first app is working as we intended. Congratulations. Let's try with different names. Yes, very good. Now, I'm going to teach you about refactoring. In larger real-world professional level Android development projects, there can be more than hundreds of classes. Same ID, same variable can be used in many different phases. And time to time, due to many different reasons, we might need to change the name of a ID or a variable. If that happens, we should not do it manually. If we do so, it will be very difficult, time-consuming, error-prone task. Instead, we use the refactoring facility provided by Android Studio. Android Studio will automatically find all the places we have used that variable or ID and rename them all. To teach this, I intentionally added a not matching ID. Did anyone recognize it? Here, I have the ID TV hello because this is the text view. And I have given the ID btn submit because this is a button btn. But here, what I have given is TV name. This is not a text view. This is an edit text. So this should change as ET name. We can give any ID name we like. Code is working. But it's better to use meaningful names. That is the best practice. So let's refactor this. In the main activity, we have used TV name. I want to rename ID resource TV name and its usages to ET name. Refactor. Let's check the main activity. See, this value has also changed. Android Studio has changed that automatically. So that's how refactoring works in Android Studio. So now let's try to improve this project more. You might have already noticed we just typed a name and clicked on the submit button and a greeting message is being displayed with the typed name as we intended. But typed name is still there. It is better if we can clear the edit text. That is very easy. This input field is the variable we defined to represent the edit text. All we need to do is invoke in the clear function of its text property. Let me show you how to do that. Input text field dot text dot clear. Let's run the app again and check how this works. Yes, edit text is clearing as we intended. Next, we will add a data validation part to this code. Let's run the app again. If we click on this without typing the username like this, app will display welcome without a name. That's okay, but it's better if we can tell user to type the name before click on the submit button. So, to do that, we are going to write an if-else statement. We call them conditional statements in software engineering. If entered name is equal to this is the equal to operator, two equal signs. This operator is used to compare the reference of two variables or objects. Empty string. We represent an empty string by empty double quotes. We will write codes to display a toast message inside this block. Else, we will display the greeting message. So, we need to keep this code part inside the else block. Then, a toast message. Toast dot make text. This make text function has three parameters: context, message, and the duration. For the context, we can provide either application context or activity context. This is how we give application context. And this is how we give activity context. This at main activity. Both of them works. What is the difference between application context and the activity context? They are both instances of context class, but the application context is tied to the lifecycle of entire application, while the activity context is tied to the lifecycle of an activity. Therefore, they have access to different information about the application environment. But for this simple application, it doesn't make any difference. Next, for the message, let's type please enter your name. Then, for the duration, we have two options: length short or length long. If we choose length long, the message will display for a little bit extra time. Let's select length short, then invoke show function. If we arrange the function like this, it will be more readable. This is not compulsory. This is just a best practice. These are the values we provide for the parameters of the make text function. We call them arguments. Values provided for parameters are called arguments. A parameter is the variable listed inside the parentheses in the function definition. An argument is the value that is sent to the function when it is called. Alright, now it's time to run the app and see how this works. Let's click on the submit button without typing a name. Very good. Toast message is being displayed as we intended. Next, let's type a name and click on the submit button. Good. A greeting message is being displayed as we expected. Now, let's click on the submit button again without entering a name. This time, the toast message is being displayed as expected, but we have a problem here. The previous welcome message is still displaying. We need to fix that. How to do that? Here, before the toast message, let's write a code line to make the text on text view empty. Now run the app again and repeat the test. Click on the submit button without typing a name. Toast message is being displayed as we intended. Then type a name and click on the submit button. Greeting displayed as we expected. Now let's click on the submit button again without entering a name. Good. The toast message is being displayed as expected and no greeting message on the text view. So this is how we develop apps. We need to run the app again and again on emulators, test for different test cases, fix the errors and run the app again to test the app again. Alright, next we are going to add a second button to this screen. Goal of that button will be viewing offers. Let's assume that this app has some offers for the users. We will display the text View offers on that button. When the user clicks on that button, system will navigate to the second screen. Second screen is the one we created earlier. These second activity.kt and the activity_second.xml files. Activity_second.xml is the view or screen. Second activity.kt is the view controller of it. Now, switch to activity_main.xml file, then drag and drop another button to the bottom right corner. Let's set constraints. Let's keep the button here. Select the button. Click on attributes. Then give an ID to this button. btn offers. Refactor. Next, I am going to change the font size to 24 sp. Android Studio always provides more than one ways to do a task. Earlier, we scrolled down to find attributes we need. This time, let's just use search facility. Search size. Then change text size to 24 sp. Next, we are going to change the text on the button. Search text. Change this to view offers. Now, before do more works, let's just run the app and check how this looks. Good, as we expected. Next, I am going to make this button invisible. Why would I do that? Actually, we are going to dynamically make it visible after the user submit the name. So, search visibility. Make it invisible. You can see button is not displayed now. Now, if you check the XML code, you will see newly added attributes. Switch to code mode. This is the button. ID is btn offers. Value of the text attribute has set as view offers. value of the visibility attribute has set as invisible. Next, we are going to write Kotlin codes to make the button visible at the right time. So, let's switch back to main activity.kt file. First of all, we need to get the button view using find view by ID. Well offers button equals find view by ID button r.id btn offers Next, inside the submit buttons on click listener, we need to write the codes to make it visible here. If the user entered the name and clicks on the submit button only, we should visible the offers button. Offers button dot visibility equals visible. We need to import the view class. This one. Then for this condition, we should write codes to make the button invisible again. Offers button dot visibility equals invisible. Let's run the app on emulator and see how this works. Okay, let's type a name. At the moment, button is not visible. Click on the submit button. Greeting message displayed and the button became visible. Let's keep the text input field empty and click on the submit button. A toast message displayed and offers button became invisible. So, our app is working as we intended. Next, we are going to write codes to open the second activity when the user clicks on the offers button. To do that, we need to implement the on-click listener of the offers button. Offers button dot set on-click listener. To navigate from one activity to another, we use an Android object named intent. Well, intent equals intent. Import this one. We need to provide two arguments here. Current context is this, and the activity we want to navigate to, the destination activity, is second activity. Here we need to add two colons, then class.java. Now here we have created an intent object. Then invoke the start activity function, passing that intent. Here, by providing values for its required parameters, we have created our own customized intent object. Intent is a class in Android libraries. We have created an object of it. There are many such classes in Android libraries for us to use when developing Android applications. In Android development, what we are actually doing is creating objects of already created classes in Android libraries and use them. Use them means invoke their function and get values from their properties. Most of the time, doing that is not enough. Google cannot create classes for all the possible scenarios. So, we have to also create our own classes, create objects of those classes and use their properties and functions. You will understand these things very well by the end of this course. So, to test our code, Let's click on the Run button. Type a name and click on the Submit button. View Offers button appeared. Then click on that button. Yes, as we expected, screen navigated to second activities view. So, this is how we navigate from one activity to another. We haven't set anything to display on the second activity yet, so it looks empty. Let's click on the back button and go back to the main view. Now, we are going to send the string value of the name user typed on the main activity's screen to the second activity. To do that, we are going to use putExtra function of the intent class. But before that, we have one problem to fix. You can see here we have defined a variable named entered name with Kotlin's well keyword. Then here we have taken the user's input from the edit text, converted it to string format and assigned it to entered name variable. The problem is this variable has declared inside the click listener block of the submit button. All other code parts inside the click listener block of submit button can access it. That means all the code inside these curly braces. But codes inside this offers buttons click listener block cannot have access to it. So we need to take the variable definition out of the click listener block. I am going to define it here as an empty string and assign the value taken from the edit text inside the submit button's click listener. This time we need to use var keyword instead of val keyword, because val is for immutable variables. We cannot assign a second value replacing the firstly assigned value to a val variable. But it is okay with var. So var entered name equals, let's add an empty string. That means only a pair of double quotes. Then here we need to assign the value for the variable declared above. Remove val, so it will not try to create a new variable. Entered name equals input field dot text dot toString. Alright, now we have access to the entered name. Here intent dot putExtra. We are going to use the putExtra function of the intent object. Then provide a name or ID to the value we are passing. Let's type user. Then the value, entered name. We will use the ID we just added to get the value in the second activity. Let's open the second activity now. Also open the activity2nd.xml file. I am dragging a text view to this layout. Set constraints. Let's give an ID to this as TV offer. Refactor. Change the text size to 20 sp. I am also going to add some margins to this one. let's set margin left as 10 dp. Similarly, margin right as 10 dp. You might have already noticed that we used SP unit for the text size but dp unit for the margin. There is a difference between them. SP stands for Scale Independent Fixer. It is scaled according to the font size preference of the user. dp stands for Density Independent Fixer, which is based on the physical density of the screen. 1 dp means 1 pixel on a 160 dpi screen. In simple terms, as a beginner level Android developer, just remember to use SP for text size and use dp for everything else, like margins, borders, paddings. I'm telling that again. Use SP for text size, use dp for everything else. Alright, let's also remove the text on the text view. Now, let's go back to second activity.kt. Then, we will get the username using the intent. Well, username equals intent.getString extra. Here, we need to use the ID we have given in the main activity. Then, let's get the text view. Well, text view equals find view by ID, text view r.id.tv offer. Next, we will create a message to display. This is how we use a variable inside a string in Kotlin. Use the variable with the $sign. You will get free access to all the content for 1 month. Finally, display the message on the text view. Text view text equals message. Alright, so now it is the good time to run our app on emulator and see how this works. Type a name, click on submit button, a greeting message displayed and the view offers button is visible. Let's click on it. Yes, navigated to second activity and displaying a message with the username we typed. Alex, you will get free access to all the content for 1 month. That is the message. Very good. Congratulations. Our app is working as we expected. It's time to celebrate. Yes. Alright. Congratulations. You just completed the day 1 of our 7-day bootcamp. Not only you have installed Android Studio, but also you have learned how to use Android Studio to create Android applications. You learned about main components of an Android app and how to use emulator to run and test the applications you create. Activities, their XML layout files, constraint layout, how to use view components such as buttons, and text views, how to navigate from one activity to another, toast messages, how to work with strings. You have learned a lot of new things in a very short period of time. So it's better if you can do your own exercises using the new knowledge you gained from the day 1 part of our course before move to day 2. Get your hands dirty with Android Studio. Create some simple apps. Do your own experiments. I would also recreate the same application several times. I have uploaded the code project we completed to the GitHub and added that link under the day 1 part of the YouTube description below. You may download it from there and compare your codes with mine if required. I have also added some good hand-picked references to the description, so you will be able to learn more by reading them. And if you haven't downloaded my free ebook yet, please download it now using the link below. If you are willing to get a job as an Android developer, or if you are looking for a promotion from your current job, you should not miss it. I am giving it 100% free as a gift. And please don't forget to like this tutorial and subscribe to my YouTube channel. If you can do so, it will be a big help to me. I will be uploading new Android and other development tutorials every week, so this channel will be very useful to you in future. During the day 2 of this course, we will learn about Kotlin language fundamentals. Hello everyone, welcome back. Today, first of all, you will master some basic Kotlin language concepts such as variables and functions. We will practice them using a free, very easy to use online tool provided by the founders of Kotlin language named Kotlin Playground. After that, just before the lesson get too much boring, we will come back to the Android Studio project we created during the day 1. You will learn about logs and most importantly, today I will teach you about Android Activity Lifecycle, which is very important, compulsory knowledge you must have as an Android developer. After that, we will go back to Kotlin language fundamentals again. Using the Android Studio, I will show you how to do object-oriented programming in Kotlin. You will learn about object-oriented Kotlin with easy-to-understand, simple code examples. So, that's our game plan for day 2. Now you have installed Android Studio in your computer and you have created your first Android project. But before continuing to other lessons of Android development, I think first of all, I must teach you the fundamentals of Kotlin programming language. If you have already learned Kotlin, you should skip this part and move to next section. To easily practice Kotlin basics, we will use this interactive online tool named Kotlin Playground. This is a 100% free online tool created by JetBrains for you to learn Kotlin efficiently. All we need to do is write our codes here and click on this run button. Code will run on their server and result will be shown below. Let's run the code. You can see the result is loading. When we click on the run button, the code we wrote will be sent to a third-party server controlled by JetBrains. Code will be compiled there and result will be shown below. What is meant by compiled? What is compilation? Compilation is a process that translates the program written in Kotlin into a bytecode format that the system can run. Since the compilation completed successfully, result appeared in the bottom. If there are any errors in the program, they will appear in the pane at the bottom. So, in this way, we can easily test our codes. So, we are going to write codes here, replacing this code and learn Kotlin. Please take this section seriously. Practice with me. Please do the exercises. If you do so, when we are developing Android apps from the next section onwards using Android Studio, you will feel very comfortable with Kotlin code. You will be able to understand the code very easily. What we have here is a simple program written in Kotlin programming language. So, what is a program? A program is a set of instructions we provide to a system to get a task done. In this program, we have provided instructions to print this hello world message. Different programming languages have their own set of reserved words. We call them keywords. You can see all the Kotlin keywords from this official Kotlin documentation. Consider this as your first exercise. Open your browser, go to this webpage, kotlinlang.org/docs. I have added this link to the resources. You can click it from there. Then from the left hand side menu, select language reference, then select keywords and operations. So these are the keywords in Kotlin. Just go through this page. Don't try to remember them now. You don't have to, because we'll remember them naturally, effortlessly. You don't have to try to remember them, because by the end of this course, with practice, you'll be able to remember most of them. Pause this video tutorial now and just read the page quickly to get an idea. Let's come back to the lesson. Now, switch back to Kotlin Playground. This word fun is a Kotlin keyword which we use to declare a function. So, every time we code a function in Kotlin, we always start it with fun. A function is a group of code that performs a specific task. We also call them methods. We usually code many functions, and those functions communicate with each other. Inside the function, we might write codes to get data from another function, or we might invoke another function after completing a task. You will see functions have names. This word main is the name of this function. Main function is the first function that is called when you run the program. Every core Kotlin program needs a function named main, because from there Kotlin start executing the program. Then we have parentheses. A function name should always be followed by two parentheses. When a function needs information from the outside, we put them inside these parentheses as parameters. When we define required data types, we call them parameters of the function. Values we pass to those function parameters are called arguments. We will talk more about parameters and arguments later. We have a pair of curly braces which surrounds the body of the function. Inside the body of the function, they have written the codes to execute the task. In this case, we have a code written to print a hello message. Have you noticed we have written the text we are supposed to display inside double quotes? When we write text inside double quotes like this, that text becomes a character string. We usually refer them as strings. In Kotlin, we have a separate class named string to represent them. We will learn more about strings later. This println is a function from the core libraries. We use it to print a text and move to the next line. Now, what is this? This is a comment. A comment is a programmer-readable statement in the code. Comments are usually ignored by the compilers. We add comments to make the source code easier to understand, to provide information to readers. This is a multi-line comment. We can add single-line comments easily using a double slash like this. Let's remove both of these comments for now. Next, to teach you Kotlin fundamentals, I am going to very quickly write a small text program named CalcBot. This will teach you a little bit about Kotlin functions, variables, strings, data types, and operators. This simple program does not cover everything about functions, variables, strings, data types, and operators. Instead, it will give you a good start for your Kotlin journey. I suggest you to do the same with me on your Kotlin Playground window. Try to pause the lesson time and code with me at the same time. We'll start with the println statement to display a string. First number is 12. I'm going to copy this statement and paste below to save time. Second number is 8. Addition of them is 20. 12 plus 8 is 20. Subtraction of them is 4. (12 minus 8 is 4. We have just hard-coded all the values for now. We will change it very soon. Now, let's run the program you can see the result. If you want, you can close the result pane like this. Now, if I change this println to print, it would not move to a new line. Let me show you. You can see here. But that's not what we want, so let's keep it as println. Now, let's try to add some modifications to our code. I am going to display some border like this. Then some topic. Calbot started. Then some blank space. Let's add a blank space to the top also. By providing an empty string as the argument of the println function, you can show an empty space. Now, for the ending part, let's just copy these 4 statements and paste below. Change this to ended. And let's cut and paste this one after the ended statement. Let's run the program. So this is the result. Next, let's assume we wanted to display a report of another calculation. We would just copy this code like this and paste below. Change the first number to 20. Keep the second number as 8. Now addition should be 28 and subtraction should be 12. Let's run the program again. You can see we have received the expected output. In this code, value of the first number was 12. Then it was changed to 20, but the value of second number has remained unchanged. These values are not dynamic, they are hard-coded values. But these values could be defined separately as variables. In Kotlin, we use 2 keywords to define variables: var and val. Var is for normal variables. We can add multiple values to a variable defined with var keyword. In Kotlin, we call them mutable variables. Val is for variables which can have only one value. It's just like final modifier in Java. We can only assign one value to a variable defined with val keyword. In Kotlin, we call them immutable variables. Now, let's go ahead and define variables for those 2 numbers. Var first number equals 12. Since we have assigned an integer value to this variable, Kotlin will automatically recognize the data type of this variable as int. We can declare the data type like this, but in this case, it is not necessary. The first number is the name of the variable. Variable names are usually nouns or noun phrases. Have you noticed that the second word inside the name starts with an uppercase letter? This style is called camel case. There is not a rule, but a coding convention followed by developers to make variable and function names much easier to read. Here I have used var keyword because in the code below we have assigned 2 values to this variable. But for the second number, since we are not going to change its value, we can define it with val keyword. Val second number equals 8. Next, I am going to replace hard-coded values with newly created variable names. When we are writing a variable name inside a string, to indicate it as a variable, we need to write it after the $sign. Otherwise, Kotlin will not recognize it as a variable. Kotlin will think that word is a part of the string. Let me show you how to do that. replace this 12 with first number, $first number. Then replace this 8 with second number. Before update the second part of the code, we need to change the value of first number to 20. This is how we do it. First number equals 20. Just use the variable name. Then replace the hard-coded values with variable names. Now, let's click on Run button and see the results. Good. Code is working as we expected. Instead of hard-coded values of addition and subtraction, we can write them as mathematical operations using addition and subtraction operators. We need to use curly braces for that. Curly braces, first number, addition operator, second number. Then here, curly braces, first number, subtraction operator, second number. Let's do the same for the second code part. If you run the app, you will be able to see the same result. In this code, we have repeated the same code parts again and again. We could create separate functions for this starter and ending parts and avoid repetition. Let's create a new function, fun. Let's name this as print string part. We are using camel case for the name, parentheses, function body. Let's copy this code part and paste it inside the function. Next, we will create another function for ending part. Fun, print ending part. Let's copy this code part for the new function. Now we can delete these starting and ending codes and call to newly created functions instead. That's how we call to functions from within another function. Let's run the code again. Code gives the same result, so the code is working as we intended. So that's how we use functions, and that's how we call to functions from within another function. That's how we invoke functions. All we need to do is type the function name with parentheses. Here, to display addition and subtraction of two sets of numbers, we have written two sets of codes. What would happen if we had 5 sets of numbers? We would have to write 5 sets of codes like this. But we can easily avoid that by creating a separate function for this code part. Since we have 2 numbers, we will add 2 parameters to that function. Fun. Let's name this as calculate. Then we will add first number and second number as parameters. Parentheses, function body. Inside the parentheses, we will add parameters, the things this function needs to get from the outside to execute its task. parameter name is first number. Data type is int. Then second number, int. Next, let's go back to main function and copy this entire code part and paste it inside the new function. Now, when executing, the value of the first number variable will be received from this first number parameter. The value of the second number variable will be received from this second number parameter. Now, we can remove these code parts from the main activity. And then, to get the same result, all we need to do is call or invoke calculate function passing two numbers as arguments. Calculate. Numbers are 12 and 8. Then 20 and 8. So, this is how we call to a function with parameters. 12, 8, 20 and 8 are arguments. Values we passed for parameters are called arguments. Let's click on the run button and see how this works. You can see our program has given the same result as before, as we expected. Now I am going to use another two numbers and see how it works. Run the program. Yes, program has given the expected result. So, this is how we use Kotlin functions. Instead of repeatedly typing same set of codes again and again, we have created functions for them and reuse them again and again. So, I just wanted to give you an idea about, an introduction about Kotlin functions, variables, strings, data types, and operations. Before learn more Kotlin, please pause the lesson now and write the same program at least 2 times. Try to do it without looking at my code. If you really won't look, it's okay, but try to do it without looking at my code. You need to make yourself comfortable with Kotlin code, syntax, and keywords like fun, different functions, how to call to a function, basic programming concepts. Practicing is the only way to achieve that. Like, I think you have heard, practice makes perfect. So let's practice, right? So please pause the lesson now and do the exercise. I hope you all have completed the exercise. Now, let's study more about Kotlin functions. I am going to very quickly delete these codes and create a new function. Functions does have a return type. Return type is always the data type of the value that function returns. For example, if the function returns an integer, return type will be int. If the function returns a text, return type will be string. If the function does not return anything, then the return type will be unit. Let me show you with a code example. Fun, get addition. This function has 2 parameters, 2 integers as num1 and num2. This function returns the sum of 2 numbers. Sum of 2 integers is also an integer. So, the return type has to be int. Now, if we invoke this function like this from the main function, this will definitely cause an error because we haven't passed the values. Let's just run the project to see the error message. See, no value passed for parameter num1, no value passed for parameter num2. Now let's pass two numbers and see. You can see this red color mark shows the error. Run the program again. This time we do not have any error message. Next, we will write codes to display a message using the returned value. We can get the returned value as a variable like this. I named it as total. You can give any name you like. Then println total is $mark total. Then click on the run button. This time we got an output. There is another more efficient way to get the same result. Instead of defining it as a separate variable and then use the value inside the string, we could use the returned value inside the string like this. Curly braces. Then cut this code part and paste it inside curly braces. Now we are going to invoke the function directly from the string. Delete this code part. Let's run the program again. You can see we are getting the same result. Now I am creating another function, fun show greeting. This function does not return anything. It just print welcome. Therefore, I am going to code the return type as unit, return type is unit. Then here is another similar function. In this function, I haven't mentioned the return type. As long as this function does not return anything, it's okay. If this function returns anything, Kotlin will show an error. But since this function just displaying a test message, since this function does not return anything, Kotlin will recognize the return type as unit. We don't have to type it as unit. Let's call to these two functions from the main function. I'm going to run the program now. Good. We got the intended result. Now, you might have been thinking this question. How do I decide when to add unit for the functions that do not return anything? The answer is, you don't have to. This is the formal way and this is the informal way. But both ways give the same result. If we remove unit return type from this function, it will still give the same result. See, they developed Kotlin language on top of Java language to make things much easier and efficient for the developers. In Kotlin, you will find many correct ways to do a single task. Especially, there are many shorthand methods. Let me show you another one. In this getAddition function, we take two numbers, add them and return. This function has only one code line in its body. Therefore, since we have a return type and since we have only one code line, Kotlin allows us to write this function in a shorthand way without coding a function body. In this case, writing the return value like this would be enough. See, the function gives the same result. Now, I am going to teach you about another scenario. I am deleting these codes except these two functions. there can be functions with the same name, same return type, but with different parameters. We call them overloaded functions. As an example, in this function, I am adding a string parameter for the name. And in this function, I will add two parameters, name of type string and count of type int. Let's also change the implementation. Use the name in this message, welcome, $name. Then for the next function, welcome, $name. Your index is $count. Now, if we invoke showGreeting function like this without providing any arguments, it will execute this noArgument function. Then, if we invoke this function providing a string argument, it will execute this function with a string argument. Let's see. Then, we add two arguments, name and the count, in the correct order like this. It will execute the third overloaded function. So, when we have overloaded functions, Kotlin decides which one to execute considering the argument values we provide. Then, what will happen if we provide non-related arguments? Let's provide a double value here. It will show an error message. Let's run the program. The floating point literal does not conform to the expected type string. Kotlin couldn't find a function which has a double value as a parameter, so it shows an error message. Next, to recap what we just learned, I have a quick coding challenge for you. Inside this main function, write codes to execute all three overloaded functions at once. Okay, now please pause the video and do the exercise. Alright, I hope you all have done the exercise. It's very straightforward. All we needed to do is write the function name and provide the arguments for the required parameters. No argument function call. Let's copy this one. Then add a name. Let's add the name and account for this one. Then click on the run button. Good. We are getting intended result. In Kotlin, a function can have an optional parameter with a default value. Let's add a city name parameter to this function. Then I am adding the default value as London. Also, change the message. Let's run the program and see how this works. You can see, welcome Rahul from London. The function has used the default value. Here we have provided only one value when invoking the function, but the function has used the default value for its execution. Now, let's provide a second string for the city, name, and test. Click on the run button. See, now it has taken the city name we provided. So, when a function has a parameter with a default value, it is optional to provide the value for it. If we provide the value for it, function will use our value. Otherwise, function will use the default parameter value. During a previous lesson, we discussed a little bit about Kotlin variables. We learned that Kotlin has two keywords to define a variable, var and val. Variables defined with var keyword are called mutable variables. We can assign more than one values to those mutable variables. Variables defined with val keyword are called immutable variables. We can only assign one value to a immutable variable. Let's start with mutable variables. var age. Now, we cannot keep this variable definition in this way. If we are going to initialize it later, we must define its data type. Otherwise, Kotlin will show an error. Let's run and see. This variable must either have a type annotation or be initialized. If we provide type of it as int, like this, Kotlin will not show any error. But if we try to use this variable, let's say inside a println function call, Kotlin will still show an error because we haven't initialized this variable. We haven't assigned a value to this variable. See, variable age must be initialized. So, let's provide a value to the variable before println function call and run the program again. As we expected, this time program ran successfully. So, what are the key points we learned from this exercise? First point is, when we are defining a variable, we must either define a type of it or we must initialize it. One way or another, Kotlin has to know the type of it in order to reserve a location in the random access memory. If we initialize it with the value, Kotlin can recognize the type of it considering the provided value. Then, the second point is, a variable must be initialized before we use it. We can just define a variable providing a type and keep it untouched. But we must provide a value to it before we use it. Remember that, because in my experience, that mistake is the reason for 60% of the programming errors. Now, since this is var, since this is a mutable variable, we can assign multiple values to this variable. Let's add several values and print. Click on the run button. Yes, you can see the result. Now, what will happen if we assign a double value to this? Word double is the name of the data type used in modern programming languages for decimal or floating point numbers. Here, when we are defining the variable for the first time, we gave it an int value. At that time, Kotlin recognized this variable's data type as int. Therefore, if we assign a double value now, it will show an error. Let's add a double value to this one and test. You can see, this time we have a much larger error message. The floating point literal does not conform to the expected type int. Let's change this back to an integral value. var is for mutable, in other words, reassignable variables. Val is for immutable variables. Val is like final variables in Java. A variable defined with val keyword can be initialized only single time. Let's change this var to val. Since we have written codes to assign different values to this variable below, this should show an error. Click on the run button. Yes, you can see, val cannot be reassigned. In Kotlin, we can create a basic read-only list using list of function. For the demonstration, here I am going to create a list of fruits. Val fruits colon list string String is the type of the list. List of. Here I am going to type names of 3 fruits. Banana. Since they are text values, string values, we need to use double quotes. Apple. Mango. We have defined the list of fruits using val keyword. So we will only initialize it once. That means we will only assign one list object to this during an execution. Fruits is the name we gave to the list. After the colon, we have used the name of list interface. This is an interface in the standard Kotlin libraries. Then this string is the type of the list. We were creating a list of names, a list of text values. So the data type became string. If we had created a list of integral values like 1, 2, 3, 4, 20, 30, 50, then this data type would have changed as int. Similarly, if we had created a list of decimal numbers, then this data type would have changed as double. List of is a standard library function from Kotlin. Here we have invoked the list of function providing the values of the list. That means providing the names of the fruits. So the list of function has returned them as a single list object of type string. If we want to find the size of the list, we can do that using the size property. Let's print the size. Name of the list is fruits, so it should be fruits.size. Let's click on the run button. Yes, you can see size has printed as 3. Do you remember how to print the size inside a string? We need to use a $mark and curly braces. Println size of the list is $mark curly braces fruits.size. Let's comment this one now. Next, I am going to show you how to get each item of the list one by one. We can use a for each loop for that. Name of the list dot for each curly braces. Now this will loop through each and every element of the list. We can give a name to the result of each iteration. What we have here is a list of fruit names. So let's name it as fruit, but we can give any name we like. Then an arrow. Let's print the fruit. Click on the run button. You can see these are the results. For each loop has iterated through each list item and printed them. You can give any name you like. Let's name it as I. Then this should also change to I. Click on the run button again. You can see the results. We got the same results. Then let's add a message with the result value. This is $I. Click on run button again. So this is how for each loop works. If I try to add another fruit to this list like this, it will show an error. Let me show you. So this is the error message. Why? Because Kotlin lists are read-only. In more technical terms, we call them immutable. But that is not a problem. If we want to add, edit or remove values from the list later, we could use mutable list instead of list. Let's change this to mutable list. Now we need to change this also as mutable list of. Don't forget to use simple M. Now this L should be capital. This is camel notation. We discussed it earlier. click on the run button. This time we are not getting any error. Now to see the size, let's copy this one and paste below. Also copy the for each loop and paste below. Let's click on the run button again. You can see this time size is 4. And here we have those list items. So now you have learned some fundamentals of Kotlin programming language with Kotlin Playground. Now we are going to move back to the Android Studio project we created during the day 1. If you don't have the project with you, don't worry. Check the YouTube description below. Under day 2, I have added the GitHub link to download the day 1 code project. You can download it, open it with your Android Studio and start following this next lesson. We are going to do a little research type work on Android activity lifecycle using logcat messages. Next, I am going to show you how to use this logcat. This logcat window in Android Studio displays system messages and the messages that we added to our app with the log class. It displays messages in real time and keeps a history so we can view all the messages. Log messages helps us to read and understand a code. This is very useful to observe what is really happening in the code and to find errors. Here you can see we have 6 different log types we can use to filter log messages. As an example, to log an error message, we would use log.e. To log some information, we would use log.i. Let me show you how to create a log message. Switch to main activity, log I. Here we used I because we are just showing some information. Here we have 2 parameters, tag and the message. For the tag, I am typing my tag. You can type anything you like. The tag we are typing here will be used in the logcat to filter log messages. Then the message, I am typing main activity. On create, we need to import this log class. I am going to add another log message here. Let's copy this one and paste it here. This time we will show the value of message variable. Then add another log message. This time let's log after displaying message on the text view. Let's run the app on emulator and open the logcat. You can see logcat showing a lot of system messages while app is starting. Now let's select info here and type the tag we used for our log messages. You can see we have only one log message yet. We only have this one because we wrote other log messages inside the onClick listener of the submit button. So now let's type a name and click on the submit button. You can see here we got other two log messages. Welcome Alex. This is the message. Then, after displaying the message on the text view, this log message. Okay, so that is how we use log messages in Android applications. We will use that knowledge we just gained for our next lesson. Our next lesson is going to be Android Activity Lifecycle. This is very important. When we are opening an Android application, system creates an instance of the launch activity in the memory. We learned about launch activity earlier when we were discussing about Android manifest.xml file. In our current project, launch activity is the main activity. This main activity. So, whenever we run this application or we install and open this application in a phone, the Android system will create an instance of this main_activity.kt class in the memory. That can be considered as the birth of the main activity instance. Technically, we call that launch of the main activity instance. And that new activity instance will have to spend time in different lifecycle stages before it finally become dead, or more technically, shut down from the memory. Not just the launch activity, all the activities and fragments of Android have life cycles. During this lesson, we are going to talk about activity lifecycle. Fragment lifecycle is almost similar to activity lifecycle. We will discuss about fragment lifecycle later when we are using fragments. So, this is the Android activity lifecycle diagram from the official documentation developer.android.com. The Android system is doing these lifecycle changes to the activity instance, considering the users and environment's requirements. As an example, if the user opens another app while using our app, let's say user wants to take a call, then Android system has to move current activity of our app to pause state and move the application to the background. After the user done with the phone call, system will take our app to foreground and transit the activity from pause state back to the resume state. To recognize state transit, we can use a set of overridden lifecycle callback functions provided by the activity class. These callback functions allow the activity to know that the system is creating, stopping, or resuming an activity, or destroying the process in which the activity resides. We can use those functions to write codes to perform a specific task required to a given change of state. That is very important for the smooth performance of our apps, and that will make our apps more user-friendly. As an example, let's say in one activity of our app, we are displaying a video file to the user. Then think what will happen if a user click on a menu item and open another activity. We should write codes to pause the video before open the new activity. We can use onPause callback function to do that. So here we have a simplified illustration of the activity lifecycle. When we launch an activity, firstly, it comes to create state. At that time, Android system will invoke activity instances onCreate callback function. In the onCreate function, we perform basic application startup logic that should happen only once for the entire life of the activity. This is a must-have function. That's why when we create a new activity class, Android Studio creates this function for us. If we consider the app we created, this is the onCreate overridden function of the main activity. and this is the onCreate overridden function of the second activity. Overriding onCreate function is compulsory. You must have an onCreate function in an activity. Actually, that is the only compulsory lifecycle function. All other lifecycle functions are optional. We don't have to override them unless we need to use them. Actually, when we create an activity, we extend appCompatActivity class. If we check the class hierarchy of it, appCompatActivity class extends FragmentActivity. FragmentActivity extends ComponentActivity. ComponentActivity extends the original activity class, which has original lifecycle callback functions. All the activities we create automatically extends these classes. So, when the system creates an instance of one of our activity in the memory, system also creates instances of these parent classes. So, if we haven't overridden an optional lifecycle function like onlyStart or onResume, system will only invoke activity class's original function. After the onCreate method finishes execution, the activity enters to the started state, and the system calls the onlyStart and onResume in a quick succession. The onlyStart function of the activity class prepares the activity to enter the foreground and become interactive. This is where the app initializes the code that creates the user interface. Then, during the resumed state, app comes to the foreground. This is the state in which the activity interacts with the user. Now we can call activity is running. When that happens, onResumed function will be called. Activity stays in the resumed state until something happens to take focus away from it. Okay, what are the events that can happen to take the focus away from a running activity? User navigate into another activity, user receiving a phone call, device screens turning off, or screen rotation. When an event like that happens, activity will transit to post state, and onPost function will be invoked. If the activity returns to the resumed state from the post state, the system once again calls onResume method. So, if our app required something to initialize every time activity resumed, we should override the onResumed function and add that code part there. This is a very common practice. In professional level projects, we may write codes inside onResumed overridden function for tasks like reconnecting with the server, to load media files, or to initialize the camera. The system calls the onPost function and take the activity to post state as soon as the user is leaving our activity. App is moving from foreground to the background. We should use the onPost overridden function to pause or adjust operations that should not continue while the activity is in the post state. After the post state, if the app is not moving to the resumed state, system may transit activity to the stop state. When that happens, activity instance will be still there in the memory, but user interface will be destroyed. If the user navigates back to an activity in a stop state, system will have to invoke onRestart and onlyStart functions to create the user interface again. Finally, we have destroy state. This onDestroy function is called when the system destroying the activity. This can happen when we programmatically invoke the finish function to intentionally destroy the activity. This can also happen when the user makes a configuration change, such as rotates the screen or change the language. When that happens, system will temporarily destroy the activity and recreate it again invoking onCreate function call. So that's just a quick theoretical overview on Android Activity Lifecycle. Now let's go back to our code project and do a little research work. Here we are going to override all the lifecycle in main activity and the second activity with local statements. You don't have to do this always, right? Now I am doing this because we are going to do a research. After that, we will be able to observe how lifecycle transitions happen for these two activities. We already have the onCreate overridden function. So let's start with onlyStart. Right click, select generate, select override, then select onlyStart from the list. Let's copy the log statement. Change this to onlyStart. I am going to remove these log statements. Then let's override the onResume. Right click, generate, override, then select onResume. Let's copy and paste the log statement. Change the log message for onResume. Now I am going to very quickly do the same for onPause, onStop, onDestroy and onRestart functions. Select onPause, onPause, onStop, change this to onStop. Then we need onDestroy. Finally, onRestart. Change this to onRestart. Next, we need to do the same for the second activity. Let's just copy all newly added lifecycle functions. Switch to second activity and paste them. Then change this name to second activity. I am going to also add a log message for the second activity's onCreate function. Next, let's open the logcat. We have already selected the log type as info, and we have already typed the tag. In your logcat, you might have all the log results. If so, you can delete them using this button. Now, let's run the app. We are going to observe how main activity and second activity move to or transit to lifecycle states. We can see the log messages. main activity on create, main activity on start, main activity on resume. So main activity has passed 3 transition states of the lifecycle. Now let's type a name and click on the submit button. State does not change. Main activity is still in the resume state. Next, I am going to click on the view offers button. You can see main activity has changed to pause state. Then the second activity has been created on create, on start, on resume. Eventually, main activity has changed to stopped state. Now, let's click on the back button and navigate back to the main activity. You can see this time second activity has changed to post state. Since main activity was stopped earlier, main activity has to restart again. On restart, on start, on resume, then the second activity has moved to stopped and destroyed states. System has destroyed the second activity. Next, I am going to show you what happened when we rotate the screen. You can see main activity on pause, on stop, on destroy, on create, on start, on resume. So system has destroyed the activity and recreated it again. Let's rotate this back to the vertical position. Observe the log results. You can see that's what happened in rotations and configuration changes. Android system always destroys the activity and recreates the activity. So that's the life cycle of an activity. You don't have to remember everything, just have a brief idea about the life cycle. You will see more advanced project examples in coming lessons of this course. Now, let's go back to Kotlin language fundamentals. This time, you will be learning about object-oriented programming in Kotlin. You will learn about classes, how to create instances or objects of those classes, constructors, constructor parameters, parent and child classes, overriding functions, and interfaces. And for these lessons, we will use Android Studio instead of Kotlin Playground. Now, during this lesson, I am going to discuss some of the object-oriented concepts in Kotlin, which are essential for Android development. Actually, during previous lessons, when we were building our first Android Studio project and when we were studying Android Activity Lifecycle, you have already used some of them. This time, instead of using Kotlin Playground online tool, I will be using Android Studio. So, I am going to very quickly create a new project. Select empty activity. Name this as OOP demo. Now, let's start from classes. This main activity.kt is a class. If we open the previous project again, this main activity.kt and second activity.kt are classes. In Kotlin, a class starts with the class keyword. For the demonstration, I will create a new Kotlin class. New Kotlin class. Let's name this as car. So, this is the car.kt file. Inside that, we have car class. Class keyword followed by the class name and the class body surrounded by curly braces. Now, I am very quickly creating a function inside this class using fun keyword. Inside the function, I am adding a log message. Import the log, then switch to main activity. Now, this is how we create a new instance of that car class. We will do that inside onCreate function. This onCreate function is the starting point, just like the main function you used in Kotlin Playground online tool. Well, car, you can give any name you like, equals car. End with parenthesis. You can use well or var for this definition. You already learned if you use well, you cannot reassign another object to this. If you use var, you can reassign. This is the name I gave for the car object. You can give any name you like. This is actually a reference variable. We refer to the newly created car object in memory using this reference variable. After that, name of the class with parenthesis. Notice that we are not using new keyword in Kotlin to create new objects, not like Java. In Java, we always used new keyword. Now, using the car reference variable, we can invoke its start function. Car.start. Now, if you run the app, you will be able to see this log message created by the start function of the car class. Let's run the app. We need to set the log cat. Type the tag. You can see the log message. Now here we have created an object of car class, or one can say an instance of car class. We use both of those words to mean the same thing, create in the memory of the phone. So some people use the word object, other people use the word instance, but they both mean the same thing. Remember that. That will avoid many confusions. Next, I am going to show you how to define a constructor in Kotlin. Classes like this one has a default implicit constructor. Since we are not using any constructor parameters, we don't have to worry about the constructor. It's there by default. Let's create a new class named driver. This time, I'm going to add a constructor parameter. So, we have to define the constructor like this by adding parentheses to the end of the class name. Then, add the parameter inside the parentheses. Let's add name. Object type is string. Now, this part is the primary constructor of this driver class. Not like Java. In Java, we had constructor defined explicitly inside the class body. Kotlin has reduced that extra amount of code lines by allowing us to define the primary constructor embedded with the class definition like this. Now, let's define a field variable inside this class. var driver name. Let's add an empty string as the initial value. Now, to assign constructor parameter value to the driver name, we can use an init block. Init driver name equals name. Let's define a function which uses this field variable. Fun show details. Look, I am using the same tag. Name of the driver is $driver name. Now let's switch to main activity.kt and write some codes to use the driver class. Create an object of it. Well, driver equals driver. Here we need to provide a value to the parameter. I am typing Tom as the name. Here we don't have to use the same name as the object name. You can give any name you like. For the demonstration, I am renaming it as D. Then invoke the function d.showDetails. Let's run the app and see the log results. Yes, app is working as we intended. Switch back to driver.kt class again. In Kotlin, you will find there are always several ways to complete a single task. Here, instead of initializing with an empty string, we could have initialized this field variable later if we defined it with the lateInit keyword like this. But when we are using lateInit, we need to always provide the object type like this. If you run the app now, you will get the same results. But there are better ways to do this. Instead of using it as a lateInit variable and assign value inside the init block, we could have directly assigned the constructor parameter to the driver name variable. Let me show you how to do that. See, app gives the same results. Now, there is an even concise way to do the same thing. We can define this as a variable inside the constructor and directly use it. This name was just a constructor parameter, but now with the var keyword, it has become a property or a field variable. Now you might be thinking, why we have all those other different methods? They are very useful for different situations. You will see different examples. You will experience all those situations when you are following this course. Now let's switch back to car class again. Here I am adding a new field variable named max speed and assigning an initial value to it. Then I am adding another log with that speed. Switch to main activity. Let's run the app first and see how this works. So these are the new log results. Now from here, since we have an object of car class, we can access its public properties. So let's change the value of max speed variable from the main activity. car.maxSpeed equals 150. Let's run the app again. You can see now the value has changed. Original value inside the car class was 30, but we have accessed it from the main activity and changed it to 150 before invoke the start function. You know why we are doing this lesson, right? I just want to give you a practice and introduce you basic code patterns before we move to more advanced Android development codes during other lessons of this course. Please practice with me and get the maximum benefit of this exercise. Okay, next I am going to comment these codes and write the codes to get the same task done from the driver class. Let's switch to driver.kt. Let's create a car instance here. Then let's see if we can just access the speed variable and assign a value from here. You can see we cannot do that. To do that, we need to use either init block or some other function of the class. The difference is, if we use the init block, every time we create an instance of the class, init block will be executed. That means the code inside the init block is the first to be executed when the class is instantiated. But the code we write in a function will only be executed only if we invoke that function from inside the class or from some other place. So let's use the init block. Switch to main activity. Now all I am doing is creating an object of driver inside the main activity and invoke its function. With the creation of driver object, an object of car class will be created, speed will be reassigned, and start function will be invoked. Let's run the app and see the results. Yes, you can see app has worked as we intended. Now, I am adding another constructor parameter to the driver class. I just want to show you the difference between a property and a simple parameter. Credit. Data type is int. Here, I have defined this credit just as a constructor parameter. If I used var or val keyword like this here, I could have defined this as a property. Functions can directly access a property or a field variable, but that is not the requirement here. I am removing these commented codes now. I am defining a new variable named total credits and give it an initial value of 50. Then inside the init block, we will add credit parameter value to it. This is the basic statement, but we can write it easily using plus and equal operator like this. Now I am going to use total credits variable inside the log statement. Then move back to main activity. Here we need to add a second parameter to the driver object construction code part. Name string credit int. Let's add the credit as 37. Then run the app. You can see we have the expected log results. I am removing these comments now. During this lesson, we didn't use any visibility modifiers. So all the variables we defined are public. That means all other classes can access them. As an example, in this driver class, total credits variable is public. Car variable is also public. So main activity and car class have pre-access to them, and those classes can even make changes to them. This show details function is also public. All other classes can invoke that function too. But if we want, we can easily control the access or visibility using private keyword like this. Especially, we should always make 99% of the time, we should make properties of a class private. That is a software engineering best practice. Otherwise, it will lead to a lot of unexpected errors. Next, I am going to discuss a little bit about the concept of inheritance. Here, we have the car class. Now I am going to create the child class of car class by extending it. I am creating a new Kotlin class. Name it as myCar. Now we have the mycar.kt class. Before make this a child class of car class. In other words, before make the car class the parent class of this class, we need to make it an open class with open keyword. In Kotlin, all classes are final by default. To permit the derived classes to inherit from the base class, we must use the open keyword in front of the base class. Open. Then go back to mycar.kt file. This is how we extend another class. Colon, then the name of the parent class. End with parenthesis. Now, this myCar class is a child class of car class. That means this myCar class inherits all the non-private properties and behaviors of the parent class. Properties means field variables. Behaviors means functions. As an example, let's go to the onCreate function of main activity and create an object of myCar class. I'm commenting this too. Now you can see this object has access to start function and max speed property, even though we never defined them inside the myCar class. That is how inheritance works. myCar class owned them from the parent car class. For the demonstration, let's add a value to max speed and invoke the start function. Run that now. We are getting the intended results. Next, this is the most important part. If we want our child class to have a different behaviors than parent class, we can do that by overriding parent class's functions. As an example, here I am going to override start function of the parent car class inside the myCar child class. As always, we need to make start function open first. Then switch to myCar class. Override is the keyword here. Override fun start I'm going to just add the log message. Now, when we run the app, the new overridden function will execute. Let's run the app and see. You can see, as we expected, this time we have only the log message we added inside the overridden function. This is a very common thing. As an example, if you consider this main activity class, which is generated for us by the Android Studio, this class extends AppCompact activity class and it overrides onCreate function. Next, we will do a quick overview on Kotlin interfaces. And I will very quickly show you how to use them with Android applications. This is a very common code pattern in Android development. An interface can be implemented by a class in order to use its defined functionality. It is a way to provide a description or a contract for classes in object-oriented programming. Interfaces provide a predefined structure for a class, so other classes or libraries can deal with our class properly, because then the other classes know what to send and what to expect in return from our classes. If you study a professional level large Android application, you will see more than 60% of codes are reused codes. That's a very good recommended practice. Developers do that to save time and to avoid errors. We reuse codes from original Android core libraries and other third-party libraries. When we are using codes created by others, we need to sometimes implement interfaces provided by them. Let me very quickly create an interface to give you an idea on how to work with interfaces. File, New, Kotlin class. I am naming this as Speed Controller. This time, select interface instead of class. So, this is our new interface. You can see it starts with the interface keyword instead of class. Interfaces in Kotlin can contain declarations of abstract methods as well as method implementations. Abstract means those methods or those functions don't have a method body. In Kotlin, we refer the word function and method for the same thing. There's a slight difference between them. A method is also a function. That's why we use fun keyword in Kotlin to define a method. So, for the demonstration, I am declaring two abstract methods. In Kotlin, interfaces can also contain method declarations. I am coding a method declaration now. Fun, get brand ID, return type. Let's return a brand ID. Next, switch back to mycar.kt. Now, I am going to implement the interface here. Since we have already extended car class, here we need to use a comma. The name of the interface is Speed Controller. Notice here we are not using the parentheses. Now you can see Android Studio showing us a red color warning. If you take the mouse pointer near the class keyword, you will see this red color bulb. Class mycar is not abstract and does not implement abstract members. This means if we are going to implement a speed controller interface for this class, we must implement its abstract methods too. Let's click on the bulb sign. Then select implement members. Select both functions and click on OK button. You can see Android Studio has generated them for us. Now, what we just did is a very common, very frequent action you will do when you are developing Android applications. Now, you can see Android Studio has generated them for us. We can write our own codes inside these functions. considering our requirements. I'm not going to do that now. I just wanted to give you an idea before move to real codes during other lessons of this course. Also, if you want, you can use the non-abstract function of the interface. This getBrandID function returns the brand ID as a string value. Let's use it here. $, here we need to use curly brackets. Since we are invoking a function inside this string, we are not just using a variable, we are invoking a function, so we need to use curly brackets. Get brand ID. If you run that now, you will see the new log result. See, there is one last thing I need to explain. In these lessons, you will see that I am using both the words method and function. What is the difference between a method and a function? In object-oriented programming, a function is a piece of code that is called by name. It can be passed data to operate on and can optionally return data. A method is a piece of code that is called by name that is associated with an object. In most cases, we can consider a method is also a function. In Kotlin programming language, we use the word function most of the time instead of the word method. But remember, a method is also a function. Both of those words refer to the same thing most of the time. Remember this. In general, methods are functions that belong to a class, but not all functions are methods. So, that is the end of day 2 of our course. Day 2 is the most boring day of the course with a lot of language fundamentals lessons. But they are compulsory. You must have that knowledge. It's better. It will be helpful to your brain to memorize if you can watch and study the day 2 section again. I have also added hand-picked references for you in the description down below. Please use those pre-written tutorials to increase your Kotlin language knowledge. From the day 3 onwards, we will build a lot of Android applications while learning many practical areas of Android development. So, thank you so much for listening. Have a nice day. See you soon with the day 3 content. Hello everyone, welcome back. We will start the day 3 of our course by learning about shared preferences, which is a very important data storage mechanism in Android for a small amount of data. After that, using that knowledge and using all the Android development skills you gained during the day 1 and day 2, we will create this BMI Calculator app. You will also learn how to use audio and video files. We will create 2 applications to learn how to use audio and video files in Android applications. So, today is going to be a very interesting day. I am very excited to share this knowledge with you. Let's start. So, during this lesson, we are going to learn about Shared Preferences API. In Android applications, to save a single value or a small collection of values as key value pairs, we use Shared Preferences API. The Android operating system stores shared preferences of each application as separate files inside the data folder of the phone. This is a permanent way of data storage like a database. So, the data stored in the application using shared preferences remain available even if the app is closed until it has been deleted or cleared. We will learn more about this with code examples. Let's go ahead and create a new Android Studio project. Select empty activity. I am naming this as SP Demo, Shared Preferences Demo. Now, let's assume a practical scenario. You might have experienced this before. Imagine you downloaded a new app and then you started signing up, providing your details. But somehow you had to stop there and opened a new app. Then you forgot about the previous app. But after 2 weeks, you open that first app again and click on the sign up button. Surprisingly, you see all the details you added still there. We do that magic using shared preferences. Open ActivityMain.xml file. Let's very quickly create a demo use interface. Delete the text view. Drag and edit text. Set constraints. Let's give an ID to this as et name. Change the text size to 24. Remove the text on the edit text. Next, let's drag another edit text for the age. This time, I am selecting this number edit text. Only difference between a normal edit text and a number edit text is it has this input type as number. We can only input numbers for this one. So Android system will only display number keyboard for this text input field. In a normal edit text, input type is this text person name. This type allows text, numbers and other symbols. Let's switch to design mode again. Give an ID to this as ETH. Set the text size as 24. We will also add a button. Give an ID to this as BTN next. Set constraints. Change the text on button as next. Change the text size to 24. We are not going to implement anything related to this button during this lesson, but I just added it to complete the design. Now, I want to show you something. Select all the components at once. Use Ctrl key in Windows or use Command key in Mac. Now right click. You can see we have a lot of adjustment options here. I am aligning them as center vertically. Please do your own experiments with this. And you can see here, Android Studio showing some red color error. Let's click on that. No speakable text present. This item may not have a label readable by screen readers. You know, modern Android phones has a talkback screen reader which speaks text and image content on your screen. For them to recognize our view components, we need to use the label for attribute. But for this simple demo app, we should not waste our time on it. Let's just ignore it. Let's do the same for other edit text. Let's run the app now. Okay, design looks good. Now, I'm going to type a name and age and then stop the app. Run the app again. You can see the name and age we typed are not available anymore. They are gone. What we are going to learn in this lesson is save those data using shared preferences and use them to display those values to the user when the user starts the app again. Switch to main activity. Let's start by defining variables for the to edit text. The reason I defined them here instead of defining them inside the onCreate is that we need to access them from other functions of the class. If we defined this inside the onCreate, we would only be able to use them inside the onCreate function. And also, when we are using lateinit keyword to define variables like this, we must always mention the object type. Like this edit text is the object type. Next, initialize them inside the onCreate using findViewById. Since we have defined the object type above, we don't have to provide the object type again. Next, we will define two reference variables for the shared preferences and shared preference editor. Private lateinit var. I am naming this as SF. Object type is shared preferences. Then private lateinit var. Name is editor. Object type is shared preferences.editor. We need this editor instance to add and edit values for shared preferences. Then initialize the shared preferences instance here. SF equals get shared preferences mysf. This mysf would be the name of the file we'll create inside the phone's data folder to store shared preferences of this app. Context: if we choose mode private, access to this file will be limited to our application. If we choose mode append, this will append with the already existing preferences. Let's choose mode private. Then sf.edit. Next, we are going to write codes to use the shared preferences. Could you recall this Android activity lifecycle we learned during a previous lesson? We are going to use this onPause function to save the user inputs to shared preferences before the system pause and end the activity. And we will use this onResume function to load those saved values. So let's override the onPause function. Next, we will write codes to get the user input values. Well, name equals name text.text. We need to use toString here. Well, age equals age text dot text dot toString. Since age is an int value, we need to use toInt here. Next, we will use editor to save these values to the shared preferences. We do that as name value pairs. We need to provide a reference name for each value. Editor.apply. Put string. Let's name this key as SF name. Then the value, name, this name. Next, put int key SFH. Value is age. This age value. Next, commit. This step is very important. If you forget to commit, values will not be saved. Next, to display the saved data, we will override the onResume function. Then get the name, sf.getString, we are using this shared preferences instance here. Then we need to provide the key we used to save the value, which is sf name. Then for the default value, I am providing null. Next, well, age equals sf.getInt. This is the key, sfh. Then here, for the default value, we have to provide an int. Therefore, I am providing 0. Next, we can write codes to set the displaying values for edit text. Since text property requires a string value, we need to use toString here. There is one little problem. When we run the app for the first time, since the sfh does not have a value, age field will show a 0. This will not look nice, but we can easily fix that using an if statement. If age not equals to 0, alright, now it's good time to run that and see our codes in action. Add a name and age. Then let's stop the app. Then restart the app again. Yes, well done. As we expected, we can see the saved values with shared preferences. Let's clear the app again. This time, we will restart the app using the icon. Yes, app is working as we intended. So that's how we use shared preferences. Now, you know how to work with shared preferences. Please practice the lesson again. As usual, I have uploaded all the code samples we used to GitHub, and I have added the download links to the description below. I have also added some references there. Please use them to improve your knowledge. Now, using all the Android development skills you gained so far, it's time to create BMI Calculator app. Now, we are going to create a very useful app named BMI Calculator. You'll be able to learn a lot of new things about designing user interfaces as well as how to use mathematical calculations and conditional statements during this lesson. BMI stands for Body Mass Index, which allows you to get an idea about the current weight level of your body. Well, according to Wikipedia, body mass index is a value derived from the mass and height of a person. The BMI is defined as the body mass divided by the square of the body height and is expressed in units of kilograms per square meters, resulting from mass in kilograms and height in meters. Considering the BMI value, user can decide whether he or she is underweight, healthy, overweight, or obese. We can use the index values in this chart for that. So, let's start by very quickly creating a new app. Select empty activity. I am naming this as BMI Calculator. For this app, I am going to use a darker theme. So, first of all, I am going to add some colors inside the colors.xml file. Open res folder, then values, colors.xml. Here, I am going to add 3 new colors. Let's copy from here to save time. Layout background. I'm selecting this color. Then card background. You'll learn what that means very soon. Let's select this one. Next, I'm selecting this color. Name of this color would be text hint. I would like to change the color. Let's select this one. Okay, if these colors are not matching well, we will come back and change them. Now, let's switch to activity.main.xml file. Let's remove the text view. And then I am going to add the background color to the layout. Background. select color, then select layout background we just added. Let's run the app. Now, for this design, I'm thinking about removing this action bar. Open the themes folder. We have two themes XML files here for lighter and darker themes. Open this XML file. Now here, change this to no action bar. Let's do the same for other XML theme file. Change this to no action bar. Let's run the app again. Yes, you can see now, action bar has been removed. Next, we will add a CRUD view to this layout. CRUD views allow us to create rounded corner layout with some elevation. Also, we can display CRUD views on top of each other. Select containers, then drag a CRUD view to the layout. Let's set a height to make it visible. Also, add a width. Set constraints. We can adjust the size like this. We will use this CRUD view to get the user's weight. So let's give an ID to it as CV weight. Select the CRUD view, CV weight. Next, set the CRUD corner radius as 20 dp. Also, we will give an elevation to this CRUD view. Set the elevation as 15 dp. Also, set the max elevation to 15 dp. Finally, set the background color. This is the one we just added. Let's increase the width a little bit more. Then run the app to see how this looks. This title bar color does not match our design. Usually, title bar getting the color from primary variant color. So, let's change it and see. Open themes.xml files. I am changing this to layout background. Also, change the night theme. Let's run the app again. Now, title bar looks okay. Before add more components to the CRUD view, we need to place a constraint layout on it. That will allow us to place other components easily. Drag a constraint layout to the CRUD view. Then we will add a text view. This time we will set constraints with the card views constraint layout. Let's click on this plus button to zoom the design view. Set constraints. Set the ID as TV weight. Set the text on it as weight. Next, increase the text size to 24 sp and make text style bold. Then set the text color. Let's choose the one we newly added for the text hint. Seems like this color doesn't look good. So let's go back to colors.xml file and change it to a more gray one. This time text color looks okay. Next, drag a number text field. We will use this input field to get the weight value in kilograms. Set constraints. Adjust the size. Give an ID to this as ET weight. Set the text color as white. Then add 0 as hint. Change the text size to 60 sp. And change the text style to bold. We need to also add the hint color. Select text hint. Then here, increase the height of the edit text until this 0 becomes fully visible. Now, drag another text view to show kg. Set constraints. Give an ID to this. Remove the default text on it. And add kg instead. Change the text size to 24. Make the text bold. Change the text color to text hint. Just drag this more towards the input field. Now I am going to create a similar card view for height data. Drag a card view. Give an ID to this. Just add the same height and width as the previous card view. Set constraints. Next, set the card corner radius as 20 dp. Also, set the elevation and max elevation as 15 dp. Next, set the card background color. Now, to save time, I am going to copy this entire constraint layout with its components to our new card view. Copy. Paste below. Now we have a problem. Components of both layouts has same IDs and values. We can easily change them using the XML code of the design. Switch to XML mode. Let's change this ID to TV height. This text should also change to height. Then change this to ET height. And change this one to TV CM. Text on it should also change to CM. Next, we will add a button to the layout. Let's give an ID to it as BTN Calculator. Set the text on it as calculate. Set the text size to 34 sp. Make the text bold. I am going to also change the button color. We can do that using background tint property. Select this color. Let's run the app and see how this looks. Seems like we need to change the button color. Let's open colors.xml file. Button background. I'm selecting this color. Then set the newly added color to background tint of the button. I'm going to also increase the length of the button. Now, we need to improve the look and feel of this button a little bit more. I'm going to change the button size. Let's give a corner radius to the button. And an elevation. You can see now the button looks much better. Okay, after our user entered weight and height values and clicked on the calculate button, we need to show the result BMI value, and we need to also show a result statement in words and more information for the user to compare the result. So let's add another card view for that. I'm going to give the same width, 324 dp, and a little bit extra height. Let's add 170 dp. Set constraints. Let's give an ID to this as CV result. Next, set the background color as card background. Set card corner radius to 20 dp and set the elevation to 15 dp. Then select all three card views and the button using Control button or Command button. Right click, center horizontally. Very good, they have centered horizontally. For other two card views, we used constraint layout. Since we had three different view components organized in a non-linear way, it was needed to use a horizontal layout and use constraints. But in this new card view, components will be placed in a vertical line. So there is no need to use a constraint layout. So this time, I am going to drag a linear layout. You can see there are two types of linear layouts, vertical and horizontal. Since we are expecting to place our items vertically, let's drag the vertical linear layout. Next, we will drag and drop a text view into this linear layout to display BMI value. Since this is linear layout, no need to set constraints. Give an ID to this as TV index. Refactor. Change the text size to 60 sp. make the text bold. Then text color. Let's make it white. For the demonstration, I am adding an index value here. We will remove them soon and write codes to set values programmatically. Then set the text alignment as center. Width should be match parent and height should be prep content. Alright, now let's drag another text view to the linear layout. Drop it below to index text view. We will use this one to show the result statement. Let's give an ID to this as TV result. Then I am typing a demo statement to this one. You are healthy. Then change the text size to 40 sp. And change the text style as bold. Align the text to center. Next, change the text color. This time, I am selecting green. Soon, we will write codes to change the color of TV result text view programmatically according to the result. Next, we will drag another text view to display more information. Give an ID to this as TV info. Change the text size to 20 sp. Align text to center. Set the text color as text hint. For the text, let's inform the user about healthy BMI range. Brackets. Normal range is 18.5 to 24.9. I found that from a Google search. Now, let's run the app and see how our UI design looks. Good, UI design seems okay. We added these text values only for the demonstration. So let's go back and remove those text values now. Alright, now it's time to code. Let's switch back to main activity. Hello everyone, I'm going to use 3 minutes of your valuable time to inform you about my highly rated Advanced Android Development Bootcamp at Udemy. This very large course covers all the advanced Android development topics such as Jetpack Compose, dependency injection with Dagger and Hilt, networking with Retrofit, Kotlin Coroutintes, unit testing, MEVM clean architecture, single activity multiple fragments model, Android Jetpack architecture components such as ViewModel, LiveData, Room, data binding, work manager, paging, and navigation with very easy to understand project examples. After covering the fundamentals, you will be building larger, professional level, more complex, complete projects covering all the fundamentals you learned. From this course, you will be able to master MEVM clean architecture and many other professional level Android development best practices, which I learned by experience working as a software developer since 2008. By the time I am recording this, my course has over 4.7 average rating out of 5. Over 8,000 paid students have already enrolled to the course and over 1,600 students have rated the course. Please use the link below and check those reviews given by students who completed the course. I have added a highly discounted or 85% price reduced link for you in the description below. It is at the top of the description just after the download link of the free ebook. Price will be something around $10. It's less than the price of a t-shirt and it will save months of your valuable time and pain of self-studying. This course worth 10 times more than the price you pay. Don't get me wrong, after following this beginner course with the foundation we create here, you will definitely be able to do your own self-studies, do your own researches, and learn all those advanced Android development topics by yourself using YouTube videos and blog articles. But take a lot of time and there is a pain in self-studying. Contents are not connected to each other, many outdated tutorials there. But instead, by following my course, you will be able to get all the advanced Android development knowledge you need in a well-organized and easy to understand manner with up-to-date course content. And we also have a very active Q&A forum there, from which you will be able to get all the support you need. And this course comes with the 30-day money-back guarantee. So you will have no risk at all. If you are unsatisfied in any way, you will get your money back. Please don't believe my words. Please use the link, go there and check the reviews given by students who already followed the course. So I invite you to use the opportunity and join with me at Udemy. I promise it will be a great learning experience worth 10 times the money you pay. Alright, let's go back to lessons now. Alright, let's start by initializing View components. Inside the onCreate, I am going to initialize this edit text with id etWeight, this edit text with id etHeight, and this button with id btn calculate. Well, weight text equals find view by id edit text r.id.etWeight. Well, height text equals find view by id edit text r.id.etHeight. We need these two text fields to get the user inputs. Then, well, calc button equals find view by id button r.id.btn calculate. We need this button to trigger the operation. Let's implement the onClick listener. Calc button.set onClick listener. Firstly, let's get weight and height input values in string format. Well, weight equals weight text dot toString. Well, height equals height text dot toString. Next, this is the most important part. Let's write the code to calculate the body mass index. Well, BMI equals mass in kilograms divided by square of the height in meters. Since we are expecting a decimal answer, I am converting these strings to float format. Weight dot to float divided by, let's add brackets and another set of brackets, height dot to float. This gives height in centimeters because in our user interface we added centimeters to make it easier for the user. So divide it by 100 to convert centimeters to meters. Then to get the squared value, multiply by same. So this statement will give the BMI. Now this BMI might be a float value with 6 or 7 decimal places. We don't need that. We are going to display a BMI index with only 2 decimal places. So this is how we limit that result to 2 decimal places. Let's name this as BMI 2 digits. Equals string.format Here we need to add a special string. You can find all these things just reading official Android and Kotlin documentations. %mark.2f. Then the value we need to format. .toFloat. Then to do the displaying result code part, let's create a new function adding this value as a parameter. Private fun display result. Then the parameter BMI type is float. Then call to the new function from the onCreate, pass in the 2-digit BMI. Now we are going to write codes to display the results on this card view using these view components. That means using these text views with IDs TV index, TV result and TV info. So first of all, we need to initialize them. In other words, construct objects of them in the memory of the phone using findViewById. Well, result index equals findViewById text view. We need to import this one, r.id.tv index. Then, well, result description equals findViewById text view r.id.tv TV result. Finally, well info equals find view by ID, text view, r.id.tv info. Then let's display the BMI value. Result index.text equals BMI.toString. And the info.text equals normal range is 18.5 to 24.9. I found that information from this Wikipedia page. Before continuing with more coding, let's run this app and see if this part is working properly. Let's add the weight and the height. Click on the calculate button. Okay, code we added so far seems working as we intended. Next, we are going to display a message describing the result with the color on this text view. Let's start by defining two variables for the description and for the color. var result text equals and an empty string. var color equals. In Android, color resources have int values. So here for the default value, we need to add 0. Now, before I write the next code part, let's define 4 color resources for underweight, normal, overweight, and obese weight levels. Open res folder if it is not opened yet. Then open colors.xml file of it. Let's copy these 4 and paste them below. Now let's change this one as underweight. Select a color for it. Then normal. Let's select much greener color this time. Then change this as overweight. Let's add an underscore to this one too. Then give a suitable color to overweight. Next, obese. Let's give a reddish color to this one. Now, I think we should make these colors a little bit more lighter. Okay, now switch back to main activity. Here, I am going to use a Kotlin when block. You can get the same result by implementing a set of if and else blocks. But here I am using when block because when block needs much less codes comparing with if else. In Kotlin when blocks, if a matching case is found, then only the code in the respective case block is executed, and execution continues with the next statement after the when block. So no break statements are needed at the end of each case block. And here I am going to use BMI index ranges given in this Wikipedia page. Okay, when BMI less than 18.50, result text. And color should be then BMI in 18.50 to 24.99. Result text should be normal. But let's type healthy because that is the healthy weight range. Using healthy seems more meaningful for this statement. Then color equals r.color.normal. Next, BMI in 25.00 to 29.99. Result text and color should be overweight. Finally, BMI greater than 29.99. Result text and color should be obese. Now, we are going to write codes to change the color of the text view. Result description dot set text color. Result description is the name we give to the edit text instance with the ID TV result. Context compact dot get color. Context is this. Color. Next, set the display in text of the text view. Result description dot text equals result text. There is one last thing remaining to do. If we run this app now, it will work perfectly for many cases. But it will cause errors if the user mistakenly keep empty input fields. So, we need to write a function to validate user inputs before do other calculations. Let's write a function to get these weight and height string values and return true if they are not empty. Private fun validate input. Here we need to add weight and height string values as parameters. To avoid null point exception inside this function, we must use Kotlin's safe call operator with them. Weight string safe call operator, height string safe call operator, return type of the function should be Boolean. That means true or false. Now, inside this function, we are going to use another when block. This when block should produce a Boolean result. Return when weight dot is null or empty. Toast.makeTest. This weight is empty. Toast.lengthLong. .show. Here we will return false. So type false. We can copy that code part. Change weight to height. Height dot is null or empty. Then here also height is empty. Then finally, else true. Now we can use this function to validate data before calculate BMI and display result. If call to newly created function passing weight and height values as arguments, now it is the good time to run the app and see how our code in action. Let's click on the calculate button without adding any value. And this time with only one input. Good, our validation codes are working perfectly. And only with one input, validations are working. Then add the weight and the height and click on calculate button. Change different values and check. Here in this input field, we cannot see the upper edge of the letters. We can easily fix that. So let's reduce the text size of this edit text. Run the app again and check. Text input fields. Okay, this time text input fields has enough space for fonts. So, during the previous lesson, you learned a lot of new things about user interface design in Android. You also learned about how to do mathematical calculations in Android. Now we are going to learn how to use audio and video files in Android applications. Now I am going to show you how to use media files in Android applications. To learn that, we will create a simple demo app named Clap App, which will provide an applause on demand. So let's start by creating a new Android project. File, New project. Select empty activity. Click on Next. Here I am naming the app as Clap App. Keep the language as Kotlin. Set the minimum SDK as API 21. Click on Finish. Now let's do a little Google search and find a royalty-free audio file for our app. Search royalty-free sound effects. There are so many sites, so many audio files. You can choose any site and any audio file you like. There are many free clapping audio files available. Let's check this one. Search clap. Seems like this one is good and it's free. I'm going to download this one. So here we have an audio file. I am editing the name to a shorter one, so it will be easier for us to use. By the time you are watching this video, this audio file might not be available. Don't worry, just download a free audio file from a site. All we need is a small audio clip for the lesson. Okay, let's go back to Android Studio project. Now I am creating a new subdirectory inside the res directory for the audio file. Select res, right click, new directory. Let's name this as raw. Then drag and drop the audio file to it. Refactor. Alright. In order to play that audio file, we will use the Android Media Player API. This is the API we use to handle audio and video files in Android. This API provides a lot of functions and properties for us to use. You know, we cannot practically cover all those advanced stuff during a course like this. That's why I have given the URL above. Please read these documentations during your free times after the course. So let's start by creating an object reference variable for the media player. Private lateInit var. LateInit means we are going to initialize this later. Media player. Object type is media player with capital M. This is the name of the variable. You can give any name you like. And this is the object type of the variable. Next, let's initialize the media player inside the onCreate function. Media player equals media player.create. Context is this. Then provide the path of the file r.raw.uploading. Now we need an event to trigger this media player action. Let's use a button for that. So go to activity main.xml file, switch to design mode. I am removing this text view. Then drag and drop a button. Set constraints. Let's change the ID as BTN clap. Add clap as the text on the button. Change the text size to 34 and make them bold. I'm going to also give a different background color to the button using background tint attribute. Let's select this one. Alright. Now let's go back to the main activity and implement these buttons on click listener. Well, button equals find view by ID button r.id.btn clap. Import the button class. Then button.set on click listener. Here we can write media player.start. So that's all. Let's run the app and see how this works. Click on the clap button. Yes, we all can hear the uploading sound. So that is how we use Android Media Player API. Actually, this is a very good app idea. You might have already seen there are apps in Play Store. Some of them just give one noise on demand like this and has millions of downloads. People use those apps to create funny moments and surprises with friends. As a homework, develop this app to give multiple sounds on demand. That is very straightforward. All you need to do is download several audio files, download free files, drag and drop them to the raw folder we created, create media player instances for each of them, add some more buttons to the activity main.xml file, implement those buttons on click listeners to start their media player instances. So do that as a homework. I'm not going to show the answer here to save the time, but you can do it. So now we are going to improve this clap app in many different ways. By doing so, you will be able to learn a lot of new, very useful Android development skills today. We will add an image, a seek bar to display the progress of the media file, and 3 controller buttons to play, pause, and stop the media file. First of all, let's find an image. Clap image PNG. I am choosing this one. Now, this does not have to be a clap image. You should choose an image related to the audio file you used for the app. Since I have used a clapping sound audio, I am downloading this image. Here, we are creating this app for education, only for practice. But when we are creating an app for commercial purposes, we cannot download and use images like this. We need to get licenses from the original owners. So, this is the image file I downloaded. Now, I am dragging it to the drawable folder. Drawable folder is where we generally put graphic files in an Android app. Refactor. This name seems too long. Let's just rename it to clap.png. Shorter names are always easier to use. Right-click, refactor, rename, refactor again. Alright, open the ActivityMain.xml file if it is not already opened. Switch to design mode. Then drag an image view to the screen design. Here we need to select the drawable file. Click OK. Let's set constraints. We can also resize the image like this. Since I don't have a plan to write codes to use this image view from the activity, there is no need to add an ID to this image view. And also, let's remove this button. We will add a play button to get the same task done. Of course, main activity code should show some errors. Let's comment those code lines for now. Next, drag and drop a seek bar. We will use this seek bar to show the progress of the playing media file. Set the constraints. Let's give an ID to this one. SB clapping. You can give any ID you like, or you can just keep the ID as seek bar if you want. Refactor. And let's set the width as 0 dp match constraint. So it will take the entire width of the layout. Then we need to add two text views to the top left and top right corners of the seek bar to show played time and div time. Drag a text view, then set constraints. Keep this here. Then I am going to give an ID to this. TV played. Refactor. I am removing the default text on the text view. Let's keep default text size. Then drag another text view to show the div time. Time remaining to play. Set constraints. Keep this here at the right side corner. Then give an ID to this one. TV div. Refactor. Then the default text on the text view. Let's keep default text size. Next we will add 3 buttons for play, pause and stop. These buttons are going to be the controller buttons of the media file. But before add the buttons, we need to create vector images for them. Select app. You can select either app or drawable here. It doesn't make any difference. Vector graphic files we create will always save in the drawable folder. Right click, new, vector asset. You can see here we have 2 types of assets. image asset and vector asset. What is the difference between them? We usually create image assets for icons. When we do that, Android Studio helps us to create icons at different densities to display in different screen sizes. So when we create image assets, we will have several files of different sizes. But now we are not going to create icons. We need images for our buttons. So we choose vector assets. When we create a vector asset, Android Studio adds a vector graphic to the project as an XML file that describes the image. So we will have only one XML file for all different sizes and resolutions. Actually, maintaining one XML file is much easier than updating multiple raster graphics at various resolutions. Click on this clip art. Let's search for a play button image. I am selecting this one. Play arrow. Let's change this name to a simpler one. If you want, you can change the color from here. I am keeping the same color. Next. Finish. Now, if you check the drawable folder, you will see newly added vector graphic file. This is the one. These are the XML codes that creates the vector graphic. Now, let's create another vector graphic for pause button. Search pause. Edit the name. Then another one for stop button. Stop. Let's select this one. Alright. Now let's drag and drop these three buttons to the layout. This time I'm going to use float in action buttons. As it is a circular button and it floats above the UI, it will look much better for this design than a normal button. Buttons. This is float in action button. Drag it to the layout. Then select the drawable resource. I see play. Then click OK. Now set constraints. Then add another button for the pause. Select IC pause. Set constraints. Next, drag another button for the stop. IC stop. and we need to add IDs to these buttons. Select this one. Let's change the ID as Fab Play. Select the Pause button. Change the ID as Fab Pause. Then this should be Fab Stop. These are not rules. You can give any meaningful ID you like. Next, I would like to add a margin to the parent constraint layout, so it will look better. It will keep a gap between the border of the screen and view components. Select Constraint Layout, Margin, let's say 10 dp. Alright, you can see the new margin. Now, before we start Kotlin coding, let's run the app and see how this looks. Good. App is not working yet, but the design is great. Now let's switch to main.activity.kt file. Let's start by initializing and creating the on-click listener of 3 floating action buttons. You know what to do. Consider this as a coding challenge. Pause the lesson now and write the codes by yourself. Start coding. All you need to do is initialize in 3 floating action buttons and create their click listeners. Alright, I hope you all did the exercise successfully. I will very quickly complete that code part now. Well, play button equals find view by ID, floating action button, r.id.fabplay. Play button dot set on click listener. Then let's do it for the pause button. Well, pause button equals find view by ID, floating action button, r.id.fabpause, pause button dot set on click listener. Let's just copy this one for the stop button. Stop button. Fab stop. Stop button. Here we have defined the media player instance as a lateInit variable and initialized it inside the onCreate function just after the setContentView. But now, since we have a stop button, every time the user stopped the player, we need to reinitialize it. To do that, we need to write codes to check if it is null in this on-click listener of the play button. Therefore, I am going to remove lateInit for this and assign a null value to it. Why I am doing this? Because we are going to use this variable in an if statement and check if it is null. In Kotlin, we can assign null to variables. But in order to do that, we need to make this a null type, or one would say nullable type, by adding this question mark. In Kotlin language, this question mark sign is called the safe call operator. We use it to handle null references. This operator executes any action only when the reference has a non-null value. Otherwise, it returns a null value. If the value is null, no execution will happen and just return the null value. That means this safe call operator combines a null check along with the method call in a single expression. So there will be no null point exceptions. If you have used Java, you know null point exception is a very common problem. But fortunately, creators of the Kotlin language has avoided that null point exception using this safe call operator. Now, let's start writing codes inside the on-click listener of the play button. Let's do a null check for the media player instance. If media player equals null, then we need to initialize, in other words, construct a media player instance, an object of media player class. Sometimes you use the word instance, sometimes you use the word object. Those two words has the same meaning. Let's just cut this code part and paste here. Now, what this code part does is, it checks if the media player is null. Null means there is no media player object in the memory. You know, memory means RAM. If so, we will create a new object and assign it to the reference variable created above. After that, we need to start the media player. Media player.start. You can see Android Studio providing a red color warning here. Since we have used the safe call operator above when we were declaring the variable, we need to do the same here. Let's add the safe call operator. Alright, now Android Studio does not show any errors. We can remove this code part now. Next, I am going to code the pause button. Media player safe call dot pause. Then the stop button. Media player safe call dot stop. Here, after invoking the stop function, we need to do more things. According to documentation, we need to reset and release the media player. Also, we will set media player object reference variable to null to avoid unnecessary memory consumption. Media player safe call operator dot reset. Then media player safe call operator dot release. Finally, media player equals null. Now, before implement seek bar, let's just run the app and see how this works. Play. Pause. Play again. Let's stop this time. Play again. You can hear, when we stop and play again, audio track starts from the beginning. Now we are going to implement the seek bar. Let's start by defining an object reference variable for it. Private date init var seekbar seekbar. Then initialize it. Seekbar equals find view by id r.id sb clapping. SB clapping is the ID we have given for the seekbar in the XML layout file. Why we didn't add the object type seekbar here? Because in the declaration above, we have already mentioned the object type, so there is no need to mention it again. In software engineering, we should always try to limit the size of a function. We should create separate functions as much as possible for different tasks. That is the recommended best practice by coding experts because it improves the readability and maintainability of the code. So, I am going to create a separate function for seekbar related operations. We create functions inside the class, inside the main curly braces of the main activity class. Private fun. I am naming this as initialize seekbar. Private is the visibility modifier. That means this function is only visible to components in this class. Only components inside this class can access to the function. There are 4 visibility modifiers in Kotlin: private, protected, internal, and public. Protected means all components inside the class and its subclasses can access. And internal means all the components inside the module can access. Public is the default one. If we do not code the modifier, then that means public. So all the components of the project have the access. And this fun is the Kotlin keyword we always use to define a function. Then initialize seekbar is the function name. Since that name has 3 words, we have joined them using camel notation. Now, we are going to implement the onSeekbar change listener of the seekbar. Seekbar.setOnSeekbar change listener. Then here, object seekbar.onSeekbar change listener. You can see Android Studio shows a red bulb indicating some compulsory code part is missing. Actually, Android Studio going to generate those codes for us, saving our time. Click on the red bulb, implement members. These are the functions belong to the onSeekbar change listener interface. Let's select all 3 functions and click OK. Okay, when you are developing Android applications, you don't have to remember all these names and do these things blindly. All the official documentations are available. All you need to do is search Google and read the documentation. Let's search onSeekbar change listener. Let's go to developer.android.com documentation. Here are 3 functions. One progress changed, notification that the progress level has changed. One is start tracking touch, notification that the user has started a touch gesture. One is stop tracking touch, notification that the user has finished a touch gesture. For this project, we only need this one progress changed. It has three parameters: seekbar, int progress, and boolean from user. I would like to change the parameter names of this generated function. Parameter types are the same, only the names seems less meaningful. This should be seekbar. Seekbar parameter represents the seekbar object whose progress has changed. This is progress. Progress is an int value which represents the current progress level. This will be in the range min to max, minimum to maximum. The default values for min is 0 and max is 100. And from user boolean value becomes true if the progress change was initialized by the user. Let's also remove these to-do statements. So all we need to do is this: if from user media player save call.seek to progress. Here we just attached the media player to the seekbar. But that is not enough. To operate the seekbar with the media player simultaneously, we need to use a separate thread. One of the very basic ways of doing that is using the runnable interface. So let's define a runnable here. Private latent var runnable. Runnable is an interface that is to be implemented by a class whose instances are intended to be executed by a separate thread. Then here, inside the initialize seekbar function, we need to initialize it. Now, inside this runnable block, we can write codes to display the media player's details using the seekbar. But before doing that, we need to set the media player's duration as the maximum duration of the seekbar. Seekbar.max equals media player.duration. You can see Android Studio showing an error in red color. Here, when we were defining the media player instance, we used the save call operator. We did that to handle null references, to avoid null point exception. Since we have defined the media player with save call operator, when we are using it, we need to do null checks. This is how we do that. In Kotlin, we call this not null assertion operator. What do we call that? Not null assertion operator. Okay. Next, inside the runnable block, we will write codes to link the media player's current position to the seekbar's progress. Seekbar.progress equals media player not null assertion operator dot current position. Now we need to create and use an instance of handler. We need a handler object to handle the thread we created using the runnable interface. So let's define a handler. Private latent var handler handler. Then handler equals handler looper.getMainLooper. Then let's go back to initialize seekbar function. Then here we need to invoke the post delete function of the handler. This will add the thread to the queue and set it to be run after the specified amount of delay. This function has two parameters, runnable and delay. Let's add the delay as 1000 milliseconds. So thread will run after 1 second delay. We need to do the same function call here. Handler.postDelete runnable 1000. We need to invoke this initialize seekbar function from the on-click listener of the play button. Initialize seekbar. When we initialize the media player, we should also initialize its seekbar. That's why I placed the function call here. After that, inside the stop button's set on click listener function, we need to write codes to remove the callback. Finally, we need to set the progress of the seekbar to 0. Seekbar.progress equals 0. Alright, now it's good time to run that and see how this works. Click on the play button. You can see seekbar is working. Then pause, play again. Stop, play again. Yes, seekbar is working as we intended. Then we have one last thing remaining to do. Let's write codes to show the play time and due time on these text views. Move to initialize seekbar function again. Now, in order to display values on text views, we need to initialize them first. I'm going to do that here. Well, TV played equals find view by ID, text view, then the ID r.id TV played. Next, well, TV view equals find view by ID, text view, r.id.tvDue. Now, inside the runnable block, we can get the play time very easily using the current position property of the media player. Well, play time equals media player not null assertion operator dot current position. This gives the time in milliseconds. So we need to divide it by 1000 to convert it to seconds. Now we can set the value to TV played text view. TV played dot text equals, since we are using a variable, we need to use it with the $sign, $play time, sec for seconds. You learned earlier. This is how we use a variable inside a string with the $sign. To find the due time, we need to firstly get the duration of the media file. Well, duration equals media player not null assertion operator dot duration. Convert this to seconds. Now we can easily find the due time Well, due time equals duration minus play time. Then display that on the text view. Alright, now it is good time to run that and see these new improvements in action. Click on the play button. Yes, you can see play time and due time working well as we expected. So this is how we use media files in Android applications. Since this is the beginner course, we are not covering everything in details. But here I am building the foundation. So now you can do your own research, right? Do Google search, check Stack Overflow, and you can learn everything about media player, right? Practice by yourself. Do your own research. That's how you become expert in Android development. During the previous lesson, we learned how to play audio files in Android applications using media player. Now, during this lesson, I'm going to show you how to use ViewView to play video files. Let's create a new Android Studio project. Select Empty Activity. I'm naming this as ViewView Demo. ViewView class is a part of Android UI widgets. It is a subclass of Surface View and it implements media player control interface. Now let's switch to ActivityMain.xml file. Let's delete this text view. Then drag and drop a ViewView to the layout. Select widgets. Then drag the ViewView. Set constraints using Infer Constraints button. Here you can see Android Studio has given an ID as ViewView. Let's just keep it unchanged. Then switch back to main activity again. Next, same as the previous lesson, I am going to create a new folder inside the res folder named Raw. Select res. You know res means resources, which is indicated by capital R in Android. New directory. Raw. I have this MP4 video file. For this lesson, you may use your own MP4 file. I will copy and paste the MP4 file to the newly created raw folder. Click on OK. Android ViewView already supports many video formats such as MP4, H.263, VP8, VP9. Google will add more formats to this list in future. Let's start coding by getting an instance of ViewView. Well, ViewView equals find view by ID. Data type is ViewView. Next, we will initiate the media controller. Well, media controller equals media controller. This media controller starting with simple m is the name of the object. Name of the object reference variable. A media controller starts with the capital M is the original class name. Here we need to pass the context. Then set the ViewView as the anchor view of the media controller. Media controller.set anchor view. Pass the ViewView instance we just created. Next, we have the most important code part, setting the video path. Here we are setting it as URI instance. Well, URI, import this one, equals pass. We need to import the correct one. android.net.uri.pass. android.resource colon / plus package name / then the file r.raw.barracuda. For your code, this should be r.raw. Name of your video file. Android Studio shows some error. Alright. Then set the media controller of the video view. We used this media controller instance we created above. Next, set the video URI. Then request the focus. Finally, start the video view. Now, it is good time to run the app and see our video view in action. Video file is playing as we expected. Controllers are also working well. But as you can see, there is a problem in width. Let's open the activity-main.xml file. What have happened here is, as you can remember, to save time, we used infer constraints button. Infer constraints button always adds constraints automatically in the most efficient way. It adds minimum constraints required for the view. But that was not seems effective for the video view in this case. Let's manually add other two constraints and fix the size issues. Alright, let's run the app again and see. Okay, good. This time, it's much better. Controllers are also working as we intended. So, that's how we use video views in Android. Congratulations! Now you have successfully completed 3 days of our 7-day Android development bootcamp. During the day, you created this BMI Calculator app while learning how to create user interfaces, how to do user interface designing, and how to implement mathematical operations in Android. Then you learned how to use audio files in Android applications using Media Player and created this clap app. After that, you learned how to view video files using Video View in Android applications. During the day 4, you will learn about ViewModel and LiveData, RecyclerView, and Kotlin Coroutintes. Thank you so much for listening. See you soon with day 4. Hello everyone, welcome back. Now, you are in the 4th day of our course. Today you are going to learn about ViewModel and LiveData, RecyclerView, and Kotlin Coroutintes. To learn them, we will build smaller demo applications. Sometimes I will ask you to open the starter project and continue. As usual, I have added download links to those starter and final code samples in the description below, so you all can download them and open them with your Android Studio. The purpose of today's 3 separate topics is to give you the required foundation knowledge for tomorrow's lesson. Tomorrow, we will build a complete larger project with room database using some applications of ViewModel, LiveData, RecyclerView, and Coroutintes. If I directly teach that practical lesson, it will be very difficult to you to understand it. That's why I decided to teach these fundamentals today. So let's start day 4 of our Android Development for Beginners 7-day bootcamp. Now, during this lesson, I am going to teach you about ViewModel and LiveData. These are very important. Almost all the modern Android applications use them. If you face to an Android developer job interview, they will definitely ask questions about these topics. During later sections of this course, we will build complete larger projects using ViewModel and LiveData. For now, I just want you to understand the fundamentals properly. To do that, I tried to create this simplest possible code example I can think of to demonstrate how they work. So, let's start with the code exercise. As a beginner level Android developer, practice is the thing you need most. So, create a new Android Studio project with an empty activity. Use the existing default text view. Drag it towards top of the screen. Give an ID to it as TV count. Change the text size to 60 sp. Make text bold. Remove the text on it. And add a button to the center of the screen. Set constraints. Give an ID to it as btn count. Change the text size to 34 sp. Change the text as count. And make the text bold. Then, inside the activity.kt file, I want you to think and write some codes to display the click count on the text view. At the beginning, count should be 0. If the user click on the button, count should be 1. If the user click on count button, again, count should be increased to 2. Count should increase 1 by 1 for every new button click. You can do a Google search to find codes. Okay, pause the lesson now and do the exercise. Alright, I hope you all did the exercise successfully. For those who couldn't complete the exercise, I will very quickly create the project now. File, new project, select empty activity. Next, I am naming this as ViewModel demo. Finish. Then switch to activity.main.xml file. TV count, remove the text, I am setting the text size as 60 sp. And text style as bold. Then drag a button to the center of the screen. Set constraints. ID as btn count. Then the text size to 34 sp. Now I am going to change the text on the button as count. And make the text bold. Let's run that once and see how it looks. Alright, now switch back to main activity.kt. First of all, I will write codes to get the two view components. Android Studio wants us to import this one. Next, I am defining a variable for the click count. Starting count is 0. Then I am implementing the on-click listener of the button. Increase the value of the count by 1 using increment operator. Then set new value to the text property of the text view. This count is an int value. Therefore, we need to use toString function to convert it to string format before set it to the text property of the text view. Now, let's also write codes here to set the initial value of the count to the text view. Next, I am going to very quickly run that and see how this works. You can see starting count is 0. Click on the count button several times. Yes, it is working as expected so far. Now I'm going to rotate the app. In emulator, we need to click on this icon to rotate the app's screen, but in a real mobile phone, it happens automatically. Count was 7 before the rotation, now it is 0 again. Let's click on the count button. You can see value increases from 1, not from 7. Let's rotate the app again. Same thing happens. Now, the question is, why does this happen? When we rotate our device and the screen changes its orientation, Android system usually destroys our application's existing activities and fragments and recreates them. Why does Android do this? Because in that way, our application can reload resources based on the new configuration. Besides screen rotations, this happens in several other occasions. If the user changes the current keyboard, this happens. If the user changes the language settings, this happens. If the user enables multi-window mode in the phone, this happens. Can you recall during a previous lesson we learned about Android activity lifecycle? What happens is activity moves to the destroy state. That means current activity object will destroy from the memory or RAM of the app, and system will create a new activity object in the memory. That means onCreate function will be called again. So that means text view will be assigned with the initial 0 value again. The app we used in this tutorial is a very simple one. But this is a major problem when it comes to larger professional level applications. For example, think you have to get data about 2000 products from a remote REST API. Every time a configuration change happens, app will have to call to the API and download the data again and again. As a result of that, a lot of data and system resources will be wasted unnecessarily. Not only that, user will have to wait until the completion of the download again and again. Subsequently, the app will provide a very bad user experience. As a solution for our problem, the Android Jetpack ViewModel architecture component library has introduced by Google. As its name says, ViewModel is a model for a view. View means activity or fragment. It has designed to store and manage the UI related data. We usually create one view model for an activity or fragment, but sometimes 2 or more fragments can share one view model. As we just saw in this example, objects of activities and fragments destroy time to time due to many reasons. But ViewModel instance does not destroy like that. Once created, ViewModel object stays in the memory until the app finishes its execution. A ViewModel's onCreate function is called only when the app is put into the background and the app process is killed in order to free up the system's memory. Click on this link to find Gradle dependencies. Traditionally, before use ViewModel and LiveData, we needed to add their dependencies to the app level build.gradle file and sync. So Gradle can download and configure all the libraries. Now, it is not required for latest Android SDK versions. But I am creating this tutorial for the entire audience. Some of you might using older versions, so I am going to add dependencies anyway. Let's copy these dependencies. Go to Android Studio and open the app level build.gradle file. Paste the dependencies here. we don't need this compose dependency for now. Sync the Gradle. Next, we will create a ViewModel by extending the ViewModel class. Create a new Kotlin class. I'm naming this as main activity ViewModel. This class should extend the original ViewModel class. Import this one. Now we can define the count variable here. Next, I am creating a function to increase the value of the count variable by 1. I am using the increment operator here. Now let's switch to main activity. Here at the top of the class, I am defining a reference variable for the ViewModel object. Now you already learned ViewModel object is little bit different than other objects. So we cannot construct an instance of ViewModel directly. We get objects of ViewModel using Android's ViewModel provider utility class. This is how we do it. ViewModel equals ViewModel provider. Here we need to provide the Lifecycle owner as an argument. This ViewModel object is going to associate with the main activity. So in this case, Lifecycle owner is the main activity. Since we are already coding inside the main activity, we can just add this for the Lifecycle owner. Then get main activity ViewModel : class.java. Now here we can use ViewModel's count variables value. I am commenting this one. You can delete it if you want. ViewModel.count.toString. Then here inside the onClick listener, we need to update the count first, invoking ViewModel's updateCount function. Then set the new value for the text view. Let's run the app and see how this works. Initial count is 0, then click on the button. Count is increasing. Now rotate the app. Yes, you can see ViewModel has worked. This time we still have the value before the rotation. Let's click on count button again. You can see count is increasing from the last count before the rotation. So that's how ViewModel works. Look how awesome this is. Even though main activity object destroys and recreates in the memory as a result of screen rotation, main activity ViewModel object remains in the memory holding the data of the main activity. This is what you should always do when you are building professional level Android applications. Next, we are going to talk about LiveData. LiveData is a lifecycle aware observable data holder class. That's how official documentation defines it. As its name suggests, we use it to get live data, real-time updates from the data sources. Google introduced this library recently. It reduces a lot of error-prone code parts and it automates many works. You will see in other sections of this course, we will use LiveData with database applications and with network applications. Now, what we have here is a simple demo application. I told you before that I wanted to create simplest possible code example to demonstrate how ViewModel and LiveData works. All I want to ask is, please don't underestimate the power of ViewModel and LiveData considering this tiny application. Now, here inside this click listener of the button, after updating the value of the count by invoking the update count function, we have written codes to manually update the text view. That's what this textView.text equals ViewModel.count.toString code part does. Now we are going to write codes to automatically update the text view using LiveData. Switch to main activity ViewModel. I am commenting this count variable for now. Then here I am going to define the count as a mutable LiveData. Mutable LiveData is a type of LiveData which allows us to edit values. Mutable LiveData is LiveData. Mutable LiveData class extends original LiveData class. var count equals mutable LiveData. Object type is int. Now, this new count is not a primitive int variable. It is a mutable LiveData object. So we cannot update its value as we did before. Next, inside the update count function, we need to get the current value and add 1 to it. We need to add the save call operator to avoid null pointer exceptions. Then +1. This will increase the current count value by 1 and assign it to the current count value. Then we need to use an init block to provide the initial value of the count variable. Count.value equals 0. Now let's switch back to the main activity. Let's comment these code parts. Now, all we need to do is just observe the value of the count LiveData. ViewModel.count.observe. Lifecycle owner is this. Observer textView.text. Here, this observer function provides the LiveData value as it. So here we type it.toString. Now here inside the onClick listener, we don't have to write codes again and again to update the text view. When the user clicks on the button, update count function will be invoked and value will be updated in the ViewModel. Since it is a LiveData value and since we are observing it from the activity, this will also automatically update. Let's run the app and see how this works. You can see app is working as we expected. So that is how we use ViewModel and LiveData in our Android applications. This is a very important lesson. Please watch this lesson again. It will be very helpful to you when we are building much larger applications during later sections of this course. So that's all the ViewModel and LiveData knowledge you need for now. I have added handpicked references to the description below. By using them, you will be able to learn more about ViewModel and LiveData. And as usual, all the code samples are available to download in the description. Now, let's learn about RecyclerView. Android developers had been using list views and grid views for displaying a list of data for many years. But Later, Android development community recognized some disadvantages of using them. They were very much memory inefficient, and we had to frequently write complex, error-prone codes for common scenarios. Therefore, Android RecyclerView library was introduced as a more memory-efficient, more advanced version. During other coming sections of this course, we will use RecyclerViews in larger, more advanced project examples. So, before we move to advanced projects, I am going to teach you fundamentals of RecyclerView with a simple, easy to understand code example. Let's start by creating a new Android Studio project. I am selecting empty activity. Let's name this project as RecyclerView Demo. Let's move to activity-main.xml layout file. Switch to design mode. We will not use the text view. Let's delete it. You can see we have a RecyclerView widget here. Let's drag the RecyclerView to our layout. Next, we need to set constraints for the RecyclerView. Usually, we set them manually, but since we have only one view component in the layout, we can simply use this Android Studio's Infer Constraints tool to automatically set constraints. Let's click on that. You can see now constraints have been set automatically. If you check the XML file, you will see newly added properties and values. Next, I am setting the ID of this as my RecyclerView. You can keep this ID or provide any ID you like. Now, let's go back to main activity. Next, we will initialize the RecyclerView using findViewById. Then, as a start, let's add a background color to our RecyclerView. I am selecting yellow. Let's run the app and see how this looks. It's working. Next, we need to set a layout manager for our RecyclerView. There are 3 layout managers available for us to use: Linear Layout Manager, Grid Layout Manager, and Staggered Grid Layout Manager. Most of the time, to have a standard list views, we use Linear Layout Manager. To display items in a grid, we use Grid Layout Manager. Staggered Grid Layout Manager positions list items in a staggered grid. RecyclerView library also facilitates us to create our own custom layout managers. For this one, let's just set Linear Layout Manager, my RecyclerView.layout manager. equals linear layout manager. Here we need to pass the context. After setting the layout manager, we need to set an adapter instance for the RecyclerView. An adapter class should be a subclass of RecyclerView's adapter class. I am creating a new Kotlin class. I am naming this as my RecyclerView adapter. This class should extend RecyclerView's adapter class. Here, as the type of the adapter, we should add a ViewHolder. To do that, now I am going to create another class. I am naming this as my ViewHolder. We should add a view as a constructor parameter. Import the view. Extends RecyclerView.ViewHolder. This takes the view as a parameter. We could have done this in a separate file, but it is much easier to have the ViewHolder class and adapter class in the same file. Now, we can provide the object type here. An adapter class has three main functions: onCreateViewHolder, onBindViewHolder, and getItemCount. Let's click on the red bulb to generate them. Select all three functions. This getItemCount function returns the total number of items in the dataset held by the adapter. For now, let's just return 5. RecyclerView library will create number of spots for list items, considering that returned value. So, in our case, we will see 5 rows in the RecyclerView. Now, I am going to implement the onCreateViewHolder function. This is where we create the list item. To do that, we need a template. We will create the template as XML layout file. New Android resource file. I am naming this as list item. Select the resource type as layout. Switch to text mode. For this layout, I am going to add a margin and a background color. Let's say 30 dp. And for the background color, I am selecting this color. Then I am dragging a text view to the layout. Press on Infer Constraint button to add constraints. I am providing the ID as TV name. change the text size to 30 sp. And make the text style as bold. I am also changing the text color to white. Let's also add a margin for the text view. I am also giving an ID to this main layout. CL list item. Finally, I am changing the layout height of the list item layout as wrap content. You can see here height of the layout changed according to the height of the content in it. Now let's go back to adapter class. I am going to write codes to get the list item in this onCreateViewHolder class. We need to get the layout inflator first. And then using that we will inflate the list item we just created. Well, layout inflator equals layout inflator.from. We are using this parent instance to get the context. Then we will use that layout inflator instance to inflate the XML layout file. Layout inflator.inflate. Then the layout resource file. Parent, and this should be false. Now, from this onCreateViewHolder, RecyclerView library wants us to return a ViewHolder instance. We have defined a myViewHolder instance here. Because this myViewHolder class we created here is a subclass of ViewHolder class. So, myViewHolder is a ViewHolder which has a constructor with the view as a parameter. So, let's return myViewHolder. Pass the list item as an argument. Here, in this myViewHolder class, we need to write codes to get the view components in the list item layout using findViewById. We have only one view component. Well, myTextView equals view.findViewById. TextView r.id.tvname. I am removing this to do comment. Before implement onBindViewHolder, now let's switch back to main activity. Here we will set our myRecyclerView adapter class as the adapter of the RecyclerView. Here, in this adapter class, we have only written codes to create the list item template. We haven't implemented onBindViewHolder function yet. we use onBind ViewHolder to display data on the list item. Since we have returned 5 from this getItemCount function, if we run this app now, we will see a RecyclerView with 5 rows filled with the list item template we created. Now let's run the app and see how this works. So this is how our RecyclerView looks. We have 5 rows displaying the list item template. Let's go back to my RecyclerView adapter code. This holder parameter of the onBind ViewHolder represents the holder instance we returned from the onCreateViewHolder holder.myTextView. This myTextView represents the text view we initialized inside the ViewHolder class. We can assign a text value to it from here. Let's say hello from onBind ViewHolder. Now, if we run this app, instead of default text view, hello from onBind ViewHolder will be displayed on the text views. What is actually happening here is, since we have returned 5 from this getItemCount function, RecyclerView library will call to this onBind ViewHolder function 5 times. This position parameter represents that. To test that, let's add position here. You can see position value for 5 list items 0, 1, 2, 3 and 4. Position values starts from 0. Now I am going to show you a list of strings in this RecyclerView. For that, we need to define a list here. Well, fruits list. I am going to define a list of names of some fruits. List of mango, apple, banana, guava, lemon, pear, orange. Okay, we have a list of 7 fruits. Now here, in this getItemCount function, we should return the size of the list instead of 5. So now RecyclerView will know that there are 7 list items. Then here in this onBind ViewHolder function, we will be able to use the position value to get the relevant fruit for each list item. Then we will assign that fruit name to the text view. Let's run the app and see how this works. Good, our RecyclerView works well as we intended. Defining a list like this inside the adapter is not a good practice. Usually, we send data to the adapter from the view controller. In this case, view controller is the main activity. So let's take this list to the main activity. Then here, we need to add the list as a constructor parameter. I am using the same name here. Since we used the same list name, we don't need to change the list name of other functions. Then from the main activity, we will pass the list as an argument. Here, let's run that again and see it in action. Good. In most of the practical scenarios, we need to send a list of objects to the adapter and display their values in the Recycler view. Now I am going to show you how to do that. But before create a list of objects, we need a data class. Let's create a new data class and name it as fruit. Select data class. You can see this class has data modifier in front of the class name. And also, this class does not have a set of curly braces. In Kotlin, data classes are used to hold data or state. By default, these classes contains standard functionalities. As an example, we don't have to define getter and setter functions in these classes as we used to do in Java entity classes. Those standard functions generate automatically. Kotlin data classes save our time by writing boilerplate code. Okay, for now, just for the demonstration, let's assume a fruit has only two properties. Name of the fruit and the name of the supplier. Now, in the main activity, we need to create a list of fruit objects. We can actually modify this list for that. You learned during object-oriented Kotlin lessons, this is how we create objects of a class with constructor parameters. We need to change the type of the list as fruit. This is not a list of strings anymore. This is a list of fruits. One supplier can have more than one fruits. Now let's go back to my RecyclerView adapter. Here we need to change the type of the list as fruits. Now this is a list of fruit objects. Here this fruit refers to a fruit object. To get its name, we need to write fruit.name. Let's run that and see this in action. Yes, app is working as we intended. So, this is how we use a list of objects with the RecyclerView. This text view does not seem positioned well. Let's very quickly fix that. Switch to the listitem.xml file. Zoom this. Adjust the constraints. Alright, now it's okay. Now, actually we're supposed to send this data from onBind view holder to the my view holder, and this settings values part should be done in the view holder class. That is the recommended object-oriented programming best practice. So let's implement it now. I am going to add a function. Let's say bind. am adding a put object as a parameter. myTextView.text equals put.name and here holder.bind. Put. Let's very quickly check the app. App is working as it worked before. Next, I am going to show you how to add a quick listener to these RecyclerView items. There are many different ways to do it. During this lesson, I am going to show you 2 ways of them. Here, we can simply implement the setOnQuickListener function of this view, view.setOnQuickListener. Let's add a toast message. You learned how to create a toast message before. For the context, we are setting the context of the view. And then the message. This is how we use an object reference inside a string. We need to use curly braces. And then the displaying time of the toast. Finally, invoke show function. Now, let's very quickly run the app and see this in action. Click on some list items. Toast messages are showing as we intended. This method is very easy, but it has limitations. Using this method, we can only use the put object of selected list item inside this adapter class. But that is not enough for real-world use cases. We need to send the object of selected list item to the view controller. In this example, view controller means main activity. When we were using Java to implement the communication between the adapter and the view controller, we created a separate interface. But now, using Kotlin higher order functions and lambda expressions, we can implement the same functionality very easily with much less number of code lines. A higher order function is a function that accepts or returns another function. In Kotlin programming language, functions are treated as first-class citizens. That means we can assign them to variables and pass them to other functions as parameters by using lambda expressions or function references. Okay, this is how I am going to do it. I am going to start from the main activity. Here we will write a function which takes the selected list item as a parameter and shows a toast message. Private fun. Let's name this as list item clicked. Parameter should be a put instance. Let's add a toast message here. Actually, we can copy from adapter. This time we are inside the main activity. So context should change to this at main activity. For the message, this time we will show the supplier's name. Next, we are going to connect or pass this function using a lambda expression to the adapter, because we need to get the selected put list item from the adapter side. So I am going to write a lambda expression here as an construct argument. Let's add curly braces. What we need to get here is a put instance. selected item. Object type is brute. Then this object should be passed to the function we just created. Android Studio shows this in red color because we haven't defined this as a constructor parameter in the adapter class yet. So let's go back to my RecyclerView adapter. What we have done here is we have written the primary constructor of this my RecyclerView adapter class directly into the class definition. So all parameters we define here are automatically available as properties within that class. Let's make this fruits list variable private. That is the best coding practice. Next, we are going to add another parameter here. For the lambda statement, we are supposed to pass from the main activity. Actually, what we are going to define now is a function parameter. I am naming this as click listener. This should take a fruit instance and return nothing. Unit means the function has no return value, just like void in Java. I know these lambda expressions and higher order functions seems very difficult to understand at the beginning. That is normal. Therefore, I will add several very easy to understand references for you. Please read those pre-tutorials and learn more about Kotlin lambda expressions and higher order functions. Alright? Then, from this onBind viewholder, we will pass the function parameter to the myViewholder class. We also need to define same function parameter for this bind function. We can copy it from here. We should remove this. Let's remove this toast message now. Finally, we will add setOnClickListener to the view. Next, pass the fruit object of selected list item to the function. Let's switch to main activity. Android Studio suggests us to add line breaks. Click on that. Then again, Android Studio suggests us to move lambda argument out of parentheses. Click on that also. Alright. Now it's good time to run the app and see this in action. Let's click on some list items. Yes, our new advanced click listener is working as we intended. So that is how we use recycler views. I just want to teach you the fundamentals because very soon we are going to build a complete database application with Room. And in that project, we will be using a recycler view to display those data taken from the database. Next, I am going to teach you about Kotlin Coroutintes. Tomorrow, we will build a complete project using Room database. In that, to execute database operations, we will use Coroutintes. In computer science, there are two types of multitasking methods to manage multiple concurrent processes. In one type, the operating system controls the switch between processes. The other type is called cooperative multitasking, in which processes control their behavior by themselves. Coroutines are software components that creates subroutines for cooperative multitasking. Coroutines were first used in 1958 for the assembly language. Developers of modern programming languages such as Python, JavaScript, and C# have been using coroutines for many years. In Kotlin, a coroutine can be introduced as a sequence of well-managed subtasks. To some extent, a coroutine can be considered as a lightweight thread. You can execute many coroutines in a single thread. A coroutine can also be switched between threads. That means, coroutine can be suspended from one thread and resumed from another thread. As Android developers, with the release of Kotlin 1.3, we now have a fully stable coroutines API. All the painful multithreading tasks done with RSJava, async tasks, or other methods such as executors, handler threads, and intent services can be easily and efficiently done with coroutines. Coroutines API also allows us to write asynchronous codes in a sequential manner. Hence, it avoids unnecessary boilerplate codes, comes with callbacks, and makes our codes more readable and maintainable. Before code our first coroutine, let's very quickly discuss why we need asynchronous programming in Android development during the next lesson. Most of the smartphones has a refresh frequency of at least 60 Hz. For 1 second or for 1000 milliseconds, the app refreshes 60 times. Let's divide 1000 milliseconds by 60. It is 16.666 repeating. So, if our app runs in this phone, it has to draw the screen using main thread approximately every 16 seconds. But we already have better smartphones available in the market with higher refresh rates such as 90 Hz and 120 Hz. If the phone has a refresh level of 90 Hz, let's divide 1000 milliseconds by 90. Our app has only 11 milliseconds to perform tasks in the Android main thread. If the refresh level is 120 Hz, 1000 divided by 120, our app will have only 8 milliseconds. By default, Android main thread has a set of regular responsibilities. It has to always pass XML, inflate view components, and draw them again and again for every refresh. Main thread also has to deal with user interactions such as click events. So, if we add more tasks to the main thread, if its execution time exceeds this super small time gap between two refreshes, app will show performance errors. Screen might freeze. User will see unpredictable behaviors in view components. It will even cause application not responding error. As a result of technological advancements, these refresh rates getting higher and higher every year. Therefore, as Android developers, we should always try to execute long-running tasks asynchronously in a separate thread. To achieve that, newest, most efficient, and most effective technology we have today is Kotlin Coroutintes. So, during the next lesson, we are going to proudly launch our first coroutine. To save your valuable time and to make this lesson less boring, I created a new Android Studio project. I named it as Coroutintes Demo 1. I also did some coding. This starter project is available to download. Please download it from the resources of this course and open it with your Android Studio. Because if you do so, you will be able to code with me. Please download it now and open it with your Android Studio. Okay, now let's very quickly go through the code. Here, in the activity main.xml, I have added two buttons and a text view. ID of this button is btn download user data. ID of this button is btn count. And ID of this text view is tv count. You can study the XML code here. Now, main activity. Here, I have defined a variable to keep track of counts and assigned 0 as the initial value. This is the on-click listener of the count button. Every time the user clicks on this count button, value of the count variable will increase by 1 and the new values will be displayed on the text view. Let me run the app and show you like this. Then, this is the on-click listener of download user data button. When the user click on the button, it will call to the download user data function and a for loop will start iterating for 200,000 times. And I have also added a log statement to see the iteration count and the current execution thread. I added this download user data function to simulate a long running task. This is not a real API call or a database operation. This is just a simulation. In a real app, this might represent downloading user data from a server or working with the database. Let's check this button also. Then set the logcat first to see the results. This is the tag. Select info here because in the log statement we have used I. Now let's run the app and click on the download button. You can see the log results. So this is the code I created. I hope code is 100% clear to you. I did some parts of the code like this to save your time. We have been already doing similar code several times in this course. But still, if you don't understand this code, ask from me. Please ask questions. I'm always a bit supportive. Now, this is what we are going to do. We are going to first click on the download button to start a long running task. And then at the same time, we will click on the count button. So we are going to simulate two processes in the main thread. Let's see what happened. To see the log results clearly, I am clearing previous log records. Now let's run the app and see how this works. I am going to click on download user data button first to start the for loop, which simulates a heavy long running task. And then click on this button. We are supposed to see click count values progressing one by one as 1, 2, 3, 4. But we are not seeing any value. Seems like app just crashed. Oh, screen is being freezed. Coroutine demo 1 isn't responding. Now we can see the number 9. I clicked on the button 9 times. We wrote code to log the current thread in our log message, in our logcat. Let's check that. You can see here the thread name is main. This user interface issue happened as a result of executing a heavy long running task on the main thread. Main thread is also called UI thread or user interface thread. It's mainly there for user interface creations and other user interface related tasks such as getting inputs from the users and displaying data to the users. Whenever we have a heavy task like network operation, reading a larger file, we should do it separately, as a separate process without interfering in the operations of the user interface. In Android, we have several ways to do that, but the easiest and most modern and most advanced way among them is using a coroutine. So, it's time to create our first coroutine. Before that, I have a question for you. Are coroutines and threads same? No, we have main or UI thread. We also have on-demand background worker threads. Any one of those threads can have many coroutines executing in them at the same time. In order to use coroutines, first of all, we need to add coroutines dependencies to the app level build.gradle file. You can find them from this official Kotlin Next Coroutintes GitHub page. We need to add both core and Android dependencies. This core dependency provides main API for the coroutines in Kotlin. And this Android dependency provides support to work with Android-related components. Then click on Sync Now. Switch back to main activity. Now let me show you how to create a coroutine. Let's start with the most basic one, coroutine scope. Coroutine scope is an interface provides the scope of the coroutine. We'll talk more about coroutine scope during the next lesson. Then we need to provide the context. All the coroutines going to start within this scope will run on this context. We need to run this task in a background thread. So let's provide dispatches.io. For now, let's just include this. I will teach you everything about dispatches during the next lesson. .launch. Launch is the coroutine builder. Now this will create a coroutine. Let's move this download user data function call to the coroutine. So now this function will execute inside the new coroutine. That's it. Congratulations. You just created your first coroutine. Look how simple it is. Now let's run the app and see the results. Yes, as you expected, the click count button worked without any delay. So there is no app crash like previously. App was crashed and the screen was freezed, but now app is working as we intended. Both processes working at the same time. So we just created our first coroutine. I know, by now you might have a lot of questions. There are a lot of new words, coroutine scope, dispatches, launch. I will explain all of them and more during other coming lessons. Now, some of you might have experienced this. Locket has stopped at some point before reach to the end of the for loop. This happens as a result of the output speed. This instance of logcat was unable to read log messages as quickly as they were being produced. We can easily avoid this issue by slowing down the result by invoking the delay function of coroutines library. But to do that, we need to mark our function with suspend modifier. If we invoke a function like delay from the coroutine library, or if we invoke another function modified with suspend keyword, we need to mark our current function also with suspend keyword. Let's invoke delay first. I am adding 100 here. This is milliseconds. So that means each iteration will be delayed by 100 milliseconds. 1/10 of a second. Import. As we expected, Android Studio shows the red bulb and tells us to use the suspend keyword. Let's click here and make it happen. If you run the app and check the results, you will be able to see them all. Let's run the app. I'm not going to show it all now to save your time. Next, have you noticed that we have defined this function outside of the class? This is the main activity class. content inside these curly braces belong to the main activity class. We have defined download user data function outside of the class and invoked it. In Kotlin, we can do that, just like static functions in Java. But the problem is, this function will not be able to access class variables belong to the main activity class. For our next lesson, we need that. So, I am going to slowly cut this function and locate it inside the main activity class. Alright, next, we are going to learn about how to change the thread of a coroutine. During this lesson, we are going to move one step forward and show these results on the user interface. We are going to display a result, a message, on a text view. Let's switch to activity-main.xml file. Here we have two buttons and a text view. I am adding another text view to the top. Set constraints. Give an ID to it as TV message. Set font size to 24 sp. And remove the default text on it. Now, here I am adding a reference variable for the text view we just added. I am creating it as a class variable because we are going to access it from the download user data function. Then initialize it inside the onCreate. Since we have already added the data type with the above definition, we don't have to add it again. Next, inside the download user data function, I am going to add codes to set the message. Message text view dot text equals, just copy from here. Okay, now what do you think? Will this work? In this example, our long-running task executes in a background thread. If we write codes to display the message in the text view like this, you know it will not work. Because in Android, we cannot directly call to a view component running in UI thread from a background thread like this. If we run this app now, it will crash, showing a call from wrong thread exception. Let's just run the app. Click on the button. As we expected, app crashed. Only the original thread that created a view hierarchy can touch its views. That means only the UI thread can access the views. But fortunately, Coroutintes has the easiest way to switch the context. Using withContext function, we can switch a coroutine from one thread to another. Let me show you how to do it. withContext, let's move this code part to the withContext function block. We need to provide the context here. As we want to switch to main thread, context should be main, dispatchers.main. So now it is good time to run the app and see it in action. Yes, you can see, app is working as we expected. So this is how we switch coroutines between threads from one thread to another. During the previous lesson, we ended up here, creating our first coroutine. Now, during this lesson, let's learn more about what we actually did. In an app, we can launch many coroutines. There can be even 100 coroutines running at the same time. But by default, coroutines don't help us to keep track of them or keep track of any work that's being done by them. If we do not manage them very carefully, there can be coroutine leaks in the memory. Resources will be unnecessarily wasted, and it will also affect to the performance of the application. But luckily for us, Kotlin programming language creators has already fixed that problem. In Kotlin coroutines, we must start all the coroutines within a scope. Using the properties belong to the scope, we can easily keep track of coroutines, cancel coroutines, and handle errors or exceptions thrown by the coroutines. So, this coroutine scope is the interface we have used to provide the scope to our coroutine. In Kotlin coroutines, we have another scope interface called global scope. Global scope is used to launch top-level coroutines which are operating on the whole application lifetime. In Android development, we very rarely use global scope. Both of these scopes also acts as a reference to the coroutine context. So, this is the context of our coroutine scope. For this context, we have only used a dispatcher as the context. If we want to use an explicit job instance, we can include the name of the job instance plus a dispatcher as the context for the scope. The plus operator can be used to merge multiple coroutine contexts. We will study about jobs very soon during another lesson of this section. Dispatcher describes the kind of thread where the coroutine should be run. In Kotlin Android structured concurrency, it is always recommended to start coroutines using main thread and then switch to background threads. To launch coroutines in the main thread, we use dispatchers.main. We also have IO dispatcher, dispatchers.io, dispatchers.default, and dispatchers.unconfined. So, if we use dispatchers.main, the coroutine will run in the main thread. In Android, we also call it UI thread. There is only one main or UI thread. So, if you create 10 coroutines within a scope with dispatchers.main as the context, all those 10 coroutines will run in the same main thread. We only use main dispatcher for small, lightweight tasks like call to a UI function, call to a suspending function, or to get updates from the LiveData. In structured concurrency, recommended best practice is always starting a coroutine from the main thread and later switching it to a background thread. We will learn all those things very soon during other lessons of this section. If we use dispatchers.io, the coroutine will run in a background thread from a shared pool of on-demand created threads. We use this IO dispatcher to work with local database, communicate with network, and to work with files. Default dispatcher is used for CPU-intensive tasks such as sorting a list of data with 10,000 list items or parsing a huge JSON file with details of 100,000 movies. Dispatcher.unconfined is a dispatcher used with global scope. If we use dispatchers.unconfined, coroutine will run on the current thread, but if it is suspended and resumed, it will run on whichever thread that the suspending function is running on. It is not recommended to use this dispatcher for Android development. Apart from these four dispatchers, Coroutintes API also facilitates us to convert executors to dispatchers, as well as to create our own custom dispatchers. Creators of libraries like Room and Retrofit have been using their own custom dispatchers to execute operations in a separate background thread. Therefore, you will see in coming lessons, when we use Retrofit and Room, we can easily use them from the main dispatcher without writing codes to change the thread. As Android developers, most of the time, we use dispatches.main and dispatches.io. Now, let's go back to our code again. This launches the coroutine builder. Coroutine builders are extension functions of coroutine scopes, which are used to launch a new coroutine. There are 4 main coroutine builders: launch, async, produced, and unblocking. Launch coroutine builder launches a new coroutine without blocking the current thread. This builder returns an instance of job, which can be used as a reference to the coroutine. We can use that returned job instance to keep track of the coroutine and to cancel the coroutine. We use launch builder for coroutines that does not have any result as the return value. This builder returns a job instance but does not return any computational result. We cannot use this coroutine to calculate something and get the final answer as the return value. If we want to get such result as a return value, we should use async coroutine builder. Not only that, the main specialty of async builder is that it allows us to launch coroutines in parallel. Async builder also launches a new coroutine without blocking the current thread. This builder returns an instance of deferred of type of the result. Actually, deferred interface is an extension of job interface. So, we can use it like we use job for things like cancelling a coroutine. If our result is a string value, the type would be string. If our result is an int value, this type would be int, like that. To get the value from deferred object, we need to invoke its await function. In Android development, launch and async builders are the coroutine builders we use most of the time. But we also have produce and run blocking builders. Produce builder is for coroutines which produce a stream of elements. This builder returns an instance of receive channel. In Android development, we use run blocking builder mostly for testing. Not like other coroutines, the coroutine we create using this builder will block the thread until its execution is over, and it returns a result which we can directly use. Well, what is structured concurrency? Structured concurrency is a set of language features and best practices introduced for Kotlin coroutines to avoid coroutine leaks and to manage coroutines productively. So, I'm going to end this lesson now. During this lesson, I just wanted to give you a brief overview of some fundamentals of Kotlin coroutines. See you soon with the next lesson. In Kotlin coroutines, whenever a coroutine is suspended, the current stack frame of the function is copied and saved in the memory. When the function resumes after completing its task, the stack frame is copied back from where it was saved and it starts running again. Kotlin Coroutines API provides us a lot of functions to make our works easier. Almost all of them are suspending functions with context, with timeout on null, join, delay, await, supervised scope, coroutine scope. There are many suspending functions. These are some examples of suspending functions provided by the Kotlin Coroutines API. Not only Coroutines library, other libraries such as Room and Retrofit also provide suspending functions to support us to work with coroutines. If we are ever going to call those first-class suspending functions from our functions, we have to mark our functions with suspend modifier, just like we did in the code example of the previous lesson. At the end of the previous lesson, when we were going to use Kotlin with context function to switch the thread of the coroutine to display the result on a text view, we marked this download user data function with suspend modifier. We had to do it. Actually, Android Studio forced us to do so because inside that function we were calling with context function, which is a suspending function, comes with Kotlin next.coroutines library. If we are going to use a suspending function such as with context, we have to mark our calling function with suspend modifier. And also, if we are going to invoke another suspending function created by us, we have to also mark that calling function with suspend modifier. With suspending modifier, we are actually limiting the use of the function only for coroutines. A suspending function can be called from a coroutine block or from another suspending function only. We cannot invoke a suspending function from a normal function or from other places of the code. Actually, with suspend modifier, we label function as a function with a heavy, long-running task. And remember, a coroutine can invoke both suspending and regular functions, but a suspending function can be invoked by a coroutine only. Well, now we are going to see what's happening under the hood. To see what's happening under the hood, we need to see Kotlin bytecodes. To do that, let's create a simple Kotlin class. I am including a non-suspending normal function here. And now let's include a suspending function. Let's rebuild the project to generate bytecodes. Now we should go to Tools, Kotlin, Bytecode. This is the Kotlin bytecode of our suspend demo class. To make it readable, we need to decompile it. Click on this decompile button. OK. This is the decompiled Java file of our suspend demo class. Suspend_demo.decompiled.java. So, these are the Java interpretations of generated Kotlin bytecodes of two functions we created. Let's have a look again. These are the two functions. First function is a normal function. Second function is a suspendable function. You can see our suspending function has been converted by the compiler to another function without the suspend keyword, but the compiler has added a new parameter of type continuation. So, what is this continuation? As you can see, continuation is a Kotlin interface which has all the structure required to resume and suspend functions. So, this is my brief overview about suspending functions. I think this lesson provides all the basic knowledge you need about suspending functions and also provide a background to do your own advanced research on suspending functions if you want. So, we use suspending functions to avoid thread blockings and hence to provide a smooth, uninterrupted experience to our users. Hello everyone, welcome back. When we are working with Android Jetpack architecture components, when we are following MVVM architecture, we need to always create view models for activities and for fragments. Now, during this lesson, I am going to show you some fundamental code patterns for using coroutines with ViewModel and LiveData. So, here for the demonstration, I just created a new Android Studio project named ViewModel Scope Demo, and I also added required Gradle dependencies to work with ViewModel and LiveData as well as Coroutintes. Now, I am creating a new ViewModel class and naming it as main activity ViewModel. Then we need to extend the ViewModel class. As we learned during our previous lessons, in order to run a coroutine, here in this ViewModel, we need a coroutine scope. First of all, we need to define a coroutine scope. Private val my scope then coroutine scope. Let's assume we want to launch the coroutine in a background thread, so we will use dispatchers.io. Our coroutine will run on IO dispatcher. Then I will create a function. Let's say get user data. And now inside this function, we can launch the coroutine in this way. But this is not complete yet. In Android, every time a ViewModel is cleared from the memory, just before the clearing, ViewModel invokes its onCleared method. OnCleared method is always there by default. But if you want to do something just before the clearing, we can manually override the onCleared method like this. Press Ctrl+O for override methods. Then from androidx.lifecycle.viewModel, select onCleared. Some of the coroutines we launch in a ViewModel has a potential to run even after the ViewModel is cleared from the memory. It might run until our app is terminated. In some scenarios, that would be the intention. But if that's not what we intended, app will end up leaking the memory. To avoid that, we need to cancel the coroutine within this onCleared function. In order to cancel coroutines started in this scope, we need to pass a job instance for the context of coroutine scope. So, I am going to create a job instance now. Private val myJob equals job. Now, we will add this job to the context of our coroutine scope. This will allow us to control all the coroutines launched in this scope. So, to cancel all the coroutines launched in this scope, only thing we need to do is this. Cancelling coroutines manually, like we just did, might be useful in some situations. But think if we have 20 ViewModel classes in our app, doing this manually might be unnecessary wasting of time. So to avoid that, to avoid those unnecessary boilerplate codes, we can use ViewModel scope. This new ViewModel scope is bounded to ViewModel's lifecycle. It has created to automatically handle cancellation when the ViewModel's onClear is called. We can easily use this scope from an extension function available on ViewModel KTX library. So, we need to add ViewModel KTX dependency to the Gradle. Android KTX is a set of Kotlin extensions that are included with Android Jetpack to provide even more concise, idiomatic Kotlin to Jetpack and Android platform APIs. To do so, KTX extensions leverage several Kotlin language features such as lambdas, extension functions, and extension properties. Now, in this ViewModel, we can simply use extension property ViewModel scope instead of this my scope created by us. Now, we don't need this scope or job. And we don't need to override onCleared. Clearing will be done automatically. So now our code becomes very concise and even more easier to work with. So this is how we do it. A ViewModel scope is defined for each ViewModel in our app. Any coroutine launched in this scope will be automatically cancelled if the ViewModel is cleared. This kind of coroutines are useful here when you have work that needs to be done only if the ViewModel is active. Well, this lesson is almost over, but some of you might need some working project example with ViewModel scope to see how ViewModel scope interact with other components. For that, I am going to very quickly implement a very basic project example. So if you don't need this code example, you can just move to next lesson. It will save you time. I'm going to get some user data from the repository to an activity through this ViewModel. Instead of displaying them in a RecyclerView, to save time, let's just lock the values. Alright, let's create a new data class called user. This user is going to have an int ID and a string name. Now, I am creating a new class for the repository. Here, I am going to code a getter method to get a list of user instances. In a similar real-world situation, this can be a call to a REST API and get users from it, or getting a list of users from a local database. But here, for the demonstration, I am just creating a new list of objects and returning them. Let's create a suspending function. Suspend fun get users. This will return a list of users. To mimic a long-running task, I am delaying this task for 8 seconds. Now, we can create a list of users. Well, users colon list user. Equals list of. Here I am going to create 4 user instances. Then we will return the list of users. Now, it's time to switch back to our ViewModel class. I am creating a new repository instance here. Private var SA users repository equals user repository. Inside this function, we have already launched a coroutine using newly learned ViewModel scope property. I am creating a reference variable for the list of users. var result list user, import the user, and question mark to make the object nullable equals null. Now, I am going to get the list of users by invoking the getUsers function of user repository. It's a long-running task, so we should switch the thread of the coroutine using with context to a background thread. Dispatches.io. Now this coroutine will run on the IO dispatcher, so it will run on the background. We are going to send this list to the views as LiveData. For that, let's create a new mutable LiveData instance of list of users. Then we can set this list of users as the value of mutable LiveData users instance. Let's switch to main activity now. First of all, we need to get the ViewModel instance by using ViewModel provider. Private let init var main activity ViewModel. Main activity ViewModel equals ViewModel provider. Lifecycle owner is this main activity. So let's add this. Dot get main activity ViewModel class.java. Okay, now we need to invoke getUserData function of this main activity ViewModel. Then we will observe the user's live data of main activity ViewModel. Main activity ViewModel dot users dot observe. Lifecycle owner is this main activity. Observer. Let's name the list of users we are getting from this live data as my users. Then we can use for each block to iterate through those user objects. You can show this data on RecyclerView or on a text view. But for now, to save time, I am going to just log the names of each user. Now, let's run that and see this in action. Good, app is working as expected. I just wanted to give you a working, simple project example for ViewModel scope. So, that's all for this lesson. Congratulations! You just completed the day 4 of our 7-day bootcamp. You learned a lot of new Android development skills today. Please go through the lessons and code samples again, and please use the references to increase your knowledge. Thank you so much for listening. See you tomorrow. Hello everyone, welcome back. Welcome to the day 5 of our 7-day Android Development for Beginners bootcamp. During the first section of today, you will learn to use Room library for SQLite database operations, and you will build a complete CRUD application using Room. During the second part of the day, you will learn about ViewBinding. So, let's start. Now, during this section, I will show you how to create a local database in an Android app to permanently store and use data. You have already learned how to define and use local variables using val and var keywords. The values we assigned to a variable will only be available while the app is running. If we close the app and restart, those values will not be available. We could also use shared preferences to permanently store a small amount of values like a session ID or a start time. But to permanently save and use large amount of records, we must have a local database embedded to our Android application. SQLite is the relational database management system we use for Android. For many years, we have been directly writing codes to work with SQLite, but later, Android community developed Room Object Relational Mapping Library for SQLite. Room library acts as a layer on top of SQLite. Therefore, Room makes our coding much easier and efficient. During this section, we will be developing this student register app. This app will allow users to save the name and email of students, display them on a list like this using a RecyclerView, update the saved data, and also delete the records when necessary. I'll be teaching you all the fundamentals of Room while developing this app. So let's start by creating a new Android Studio project. File, New project. Let's select Empty Activity. Next, I'm naming this as Student Register. Save location should also have a folder named Student Register. Since we added it to the location, Android Studio will automatically create a new folder for us. Select the language as Kotlin. I'm keeping minimum SDK as 21. For this app, for the libraries we are going to use in this app, SDK 21 would be enough. And we can change it anytime we want if required in future. Click on Finish button. Let's wait a moment until Android Studio finish creating the project for us. First of all, I'm going to add the Gradle dependencies required for this project. Open the app-level view.gradle file. If you study the Android format of the project structure of your project, you would see that there are two Gradle scripts. This one is the project level Gradle file, and this one is the module level, or we can say app level Gradle file. Let's open this one. Let's start by adding Kotlin capped plugin to the top of the Gradle. Then we will add required dependencies for Room. How do we find them? Let's go to Google and do a search. Android Room dependencies. Click on this link from the official Android developer site. Here we have them. As you can see, there are two dependencies, one for the Room library, another one for the annotation processor. When we are working with Room library, we will use a specific set of annotations to provide information or commands to the Room. You will see that very soon. Room needs this annotation processor library to process those information. Let's copy them and paste them on the app level build.gradle file. When we are using Kotlin language, we need to change this to capped. Capped is the name of the annotation processing tool in Kotlin. We are using this Kotlin capped plugin we added here. Since we are going to work with Coroutintes, we will also need Room KTX dependency. Click on this KTX documentation link. Android KTX is a set of Kotlin extensions that are included with Android Jetpack and other Android libraries. KTX extensions provide concise, idiomatic Kotlin to Jetpack, Android platform, and to other Android APIs. And please don't misunderstand this as Kotlin Android extensions or Kotlin synthetic, which is deprecated now. Android KTX is not Kotlin synthetic. Those are two different libraries. This is Room KTX. Copy this one. Paste. Let's also add a comment. That is a coding best practice. This is the same Room version, so let's use this one. Next, we will be adding dependencies required for Kotlin Coroutintes. Do a Google search. Click on this Kotlin Coroutintes GitHub link. We need to add both Core and Android libraries. You can see there is a difference between these two set of statements. In this one, we have defined Room version at the top and used it and we have used double quotes. But in this set, we have just added the version numbers and we have used single quotes. That is not a problem. You can use either single quotes or double quotes for these statements. And you can add the version number or use a common one. We just copied them from the original developer's page. If you want to have double quotes here and have a common value like this room version, you can do that. Okay, next, since we are going to use the ViewModel and LiveData, we will add ViewModel and LiveData dependencies. Do a Google search. Let's copy these and paste here. We don't need this one. So, those are the dependencies we need for this project. Earlier, several years ago, we didn't have the Gradle file. We had to download all the dependencies manually as jar files and add them to the lib folder. And after that, we had to manually do all the complex configurations. But now, lucky for you, all you need to do is paste dependency statements of required libraries on this Gradle file and click on sync like this. Android Studio will automatically download all the libraries and do all the configurations for you. Now, in this project, I added all the required dependencies at the beginning of the project, but that is not a rule, and we cannot always know what are the required dependencies at the beginning of the project. When you are creating your own projects, you might need to time open the Gradle file and add required dependencies. So, let's start by designing the main screen of the app. In Android, activities and fragments are called view controllers. This main.activity.kt is a view controller. This activity_main.xml file is a view. It is the view embedded with main.activity.kt file. View controller activity has connected to the view XML layout file using this setContentView function call. Now, if you want, you can create another XML layout file instead of this activity_main.xml and link that to main activity. So, now let's open the activity_main.xml file. From here, you can switch between modes. This is the design mode. We can only see the screen. This is the split mode. We can see both XML code and the design. And this is the code mode. Let's switch to code mode. I am deleting this text view. And I am going to change this constraint layout to a linear layout. Linear layout is a very simple layout design, which would be enough for this project's UI design requirements. But if you like, you can create the same UI design using the constraints layout. Try that as a homework exercise. Of course, you must always set the orientation of the linear layout. Let's set this as vertical. Now, let's switch back to design mode. We are building a student register app. To allow users to input student's name and email, we need to add 2 text input fields. So, drag and drop and edit text. This is for the student's name. Let's give an ID to this as ET_name. Set the text size as 24 sp. And I am going to add a margin to the linear layout. (15 dp). Then we need to add another edit text for the email. Let's just copy this one and paste below. Change the ID as ET_email. Now, if you run the app, you will see our 2 text input fields like this. To make this more user-friendly, let's add some hints. student's name, student's email. Let's check the XML code. Actually, we should add these string values as string resources. That is the best practice. In that way, we can very easily update them in future. All you need to do is click on this icon, open the strings.xml file and update these values once. Next, I am going to add 2 buttons to this screen. I want to place them horizontally, so I would use another linear layout. Inside this linear layout, let's drag and drop a linear layout. Layouts, linear layout horizontal. You can see orientation has automatically set as horizontal. We need to also change the height as wrap content. Next, we will add 2 buttons to the linear layout. Drag and drop a button. Change the ID as BT and save. Refactor. We need to display save on this button. So add save as the value of text property. Let's change the text size to 20sp and height as wrap content. Here I am adding 0dp as the width and I am going to set the weight as 1. By default, weight has set as 1. If it is not set in your project, please set it as 1. I will explain why I am doing this very soon. Then, for the second button, I am just going to copy the XML code of this button and paste below. Change the ID as BT and clear and change the text as clear. Now, since we have added weight as 1 for the both buttons and set the width as 0, horizontal linear layout will divide the space between the buttons considering the weight. Since they both have same weight, in this case, layout will divide the space evenly. Let's run the app and see how this looks. You can see both buttons have same width, but it seems better we can have a space between the buttons. We can easily achieve that by adding a left margin to the second button. Layout margin left equals 30dp. Let's run the app again and see how this looks. Good. This time we have a nice gap between our 2 buttons. Now we need to add a RecyclerView to display the list of saved students. We should add that to the main vertical linear layout. Containers, RecyclerView, drag and drop that to the outer linear layout. I am going to give this an ID as RV student. Set the width as match parent. Set the height as 0dp. And the weight as 1. So this will take the remaining space of the vertical linear layout. Let's also add top and bottom margins as 10dp. and an elevation of 10 dp. So this is the XML code. Let's run the app. If you run the app, you will see this design. We cannot see the RecyclerView because we haven't added any list items to the RecyclerView yet. That would be enough for the main activity layout design for now. So now we have created the main screen. Before create other parts of the presentation layer, we are going to complete the data layer of the project. In this project, we are going to save, retrieve, update and delete student data. To do that, we are going to create a SQLite database using the Room supporting library. In order to use Room, we need to have 3 code components. Entity classes to represent each database table, DAO interface, and the Room database class. So let's start by creating an entity class. In this simple study project, we are going to have only one database table named student. Our student table will have 3 columns. A column for the ID, name of the student, and the email address of the student. So to create this table, to represent this table, let's create a model class named student. First of all, I am creating a new package named db. Then create a new class, student. Let's mark this as a data class. In Kotlin, a data class is a class that only contains a state. We declare variables as constructor parameters, and Kotlin compiler automatically generates getter and setter functions for those constructor parameters. Let's remove the class body and define properties of student entity as constructor parameters. var id, data type is int. var name, data type is string. var email, string. In order to make this a Room entity class, we need to annotate this with entity annotation. We should also give the table name we want this to have with it. We need to import this one. Table name would be student data table. Now, if we keep this entity class in this way, it will still work. Names of the table columns would be ID, name, and email, as same as the variable names of the data class. But if we want database table to have different names than the variable names, which is considered as the best practice anyway, we need to provide them with column info annotation. Column info, name equals student ID. Let's just copy paste and change the name. Student name, student email. Next, we will also mark this ID as the primary key and set it to auto-generate. So we will not have to provide an ID when we are saving data. Next, we need to create an interface and mark it with DAO annotation. DAO stands for Data Access Object. This standard interface is where we define functions to deal with the database. You could also define DAO or Data Access Object as an abstract class. Create a new interface. Name it as student DAO. Annotate with DAO annotation. Import it. Now we will create a function to insert student data. Suspend fun insert student. Parameter should be an instance of student. To make this a room insert function, to tell room library that this function is going to save an object, we should annotate this function with the insert keyword. We are not going to execute these operations using the main thread. Instead, we will use a separate coroutine. That's why we need to modify this function with suspend keyword. Parameter of the function should be the object type we are going to save. You can give any name you like to this function. Function name does not matter. All insert functions should annotate with insert annotation. There is no need to write a SQL query for insert functions. Return type is optional. Most of the time, we write room insert functions without a return type. But room allows us to get the newly inserted row ID as a long value. For example, if the insert function has a single parameter, return type would be the new row ID of type long. On the other hand, if the parameter is an array or a collection, return type would be an array or a collection of long values. Then, let's create a function to update an existing student record. Parameter should be an instance of a student. We should annotate this function with update annotation. After that, we will create a function to delete an existing student. Again, parameter should be an instance of a student. Annotate this function with delete annotation. Room update functions should annotate with update annotation, and delete functions should annotate with delete annotation. These functions also don't require a SQL statement, and return types are optional, but we can add an int return type. These functions would return an int value indicating the number of rows that were updated or deleted successfully. Finally, we will define a query function to get the list of all saved student instances from the database as LiveData. Fun, get all students. Return type should be LiveData. List. Object type of the list is student. Annotate with query annotation. Unlike other three functions, we need to write a SQL query for this function. Select all from student data table. Student data table is the name we have given to the database table in this entity class. Function names are not important. You can give any name you like, but annotating the function with correct annotation is very important. For instance, we have annotated above insert student function with insert annotation. Therefore, Room will know that the purpose of this function is inserting data. Room library does not understand the function names, but Room recognizes annotations. Similarly, Room will recognize update, delete, and query functions from their annotations. Kotlin Coroutintes is the current best practice to work with different threads in Android development. So, we are going to use them to execute database operations in a separate coroutine. Therefore, we need to define these functions as suspending functions. But it is not required for query functions because Room library uses its own dispatcher to run queries on a background thread. That's why we haven't modified this getAllStudents function with the suspend keyword. For basic insert, update, and delete functions, we don't need to write SQL statements, but we need to write a SQL statement for query functions and for customized update and delete functions. Next, we will create the Room database class. Create a new class, name it as student database. Let's make this class abstract. This class should extend Room database class. Annotate this with database annotation. we should provide some details about the database with this database annotation. The list of entities. We have only one entity in this project. Then the version number of the database. In a real-world project, this version number is very important when we are migrating from one database version to another for future updated versions of the app. Let's also set the export schema as false. If required, Room can export our database schema information into a JSON file at compile time. Since we don't need that for this simple project, let's just set the export schema as false. Next, we need to define an abstract function which returns an instance of student DAO interface. We need to define abstract functions for each DAO interface or class that is associated with the database. Those functions should not have any arguments, and they should return an instance of associated DAO, associated data access object. We have only one DAO in this project, so let's define a function for it. Abstract fun student DAO. Return type is student DAO. Next, we need to write codes to create an instance of the database. To do that, we need the application context. So, we will need to define a function adding context as an argument. And it is always a recommended best practice to have a single instance of the database class throughout a single execution of the application. Because a database instance is a very expensive, that means very much resource consuming object. We will never or very rarely need access to multiple instances of a database within a single process. So let's create a singleton database instance here. In Kotlin programming language, companion objects are singletons, just like static in Java. Companion object. Then define the instance. Here I am using capital letters to represent a constant singleton. Make this null safe. We need to annotate this object reference variable with volatile annotation. This marks the JVM backing field of the property as volatile. That means writes to the fields will be immediately visible to other threads. Next, we will create the function adding context as a parameter. Return type should be student database. Then, before write other codes, we need to add a synchronized block here. Synchronized block will execute the given function block while holding the monitor of the given object block. Synchronized block is this. This is a thread safety and locking technique we use in a mission critical operation like creating a database. But as a beginner level developer, at this point of your career, you don't need to worry about this stuff much. You can just copy paste these codes. This database class we are creating here is a very common, very regular code sample. You can just copy this code and reuse that for your other Android projects, just changing the names. Next, we will define a local variable for the instance and assign the original instance to that. If instance is equal to null, this is to check if the database has not created yet. Then instance equals, we will use Room's database builder. Get the application context from the function parameter. Then the name of the database class. And the name we would like to give to the database we are creating. then build. Finally, return the instance. So that is it. That is our database class, which provides a singleton database instance. Now we have completed the data layer of our project. So let's go ahead and complete the presentation layer. In this project, we have only one view, which is the main activity. To provide data to that and to receive data from that, following the best practices, we need to create a ViewModel. So create a new Kotlin class. Let's name this as Student ViewModel. To qualify this as an Android Jetpack ViewModel, this class should extend the original ViewModel class. And we should provide the DAO interface as a constructor parameter. Private, well, DAO, data type is student DAO. Now, if we consider our DAO interface, we have written 4 room database functions there. We need to connect with them all from this ViewModel class. Let's start from this getAllStudents function. As you can see, this getAllStudents function is different from other functions. Of course, one significant difference is the SQL statement, but I'm talking about suspend modifier. We had to define all other functions as suspending functions since we need to use coroutines for them in the ViewModel. Because we cannot execute database operations directly in the UI thread. If we do so, it will cause unexpected errors. That's why we usually run them in a coroutine. But for query functions like this one, we don't need to explicitly use coroutines because Room Library does that part for us in the background and emit the results as LiveData. So let's start from the simplest one. Let's switch to ViewModel class and define a variable to get the list of student data as LiveData. Well, students, we will only assign values to the variable once. So this should be well, not var. Equals DAO.getAllStudents. Now to receive the list of saved student instances, all we need to do is observing this LiveData from the main activity. Next, we will define a function to save student data to the database using DAO's insert student function. Fun insert student. Parameter of the function should be an instance of student, which is the one we may want to save. Then let's use a coroutine ViewModelScope.launch. DAO.insertStudent. Pass the student instance as an argument. Next, we will create 2 more functions for update and delete. Since they have same method signature, we can just copy from this code and edit. Change this to update. Update student. And change this to delete. Delete. Alright, that's our ViewModel class. During a previous lesson, you learned about ViewModel. You learned when our ViewModel has a constructor parameter like this, we need to create a ViewModel factory class for that and provide it to the ViewModel provider. And you learned creating a ViewModel factory is very easy. All the ViewModel factories has the same codes with different class names. To save time, all you need to do is paste a ViewModel factory class from a previous project and change the names. But as an instructor, I'm going to very quickly create a ViewModel factory here. create a new Kotlin class, name it as Student ViewModel Factory. We must add the same parameter to this one. Student ViewModel class has a student DAO instance as a parameter. So let's add the same. And this should extend the ViewModel provider's factory class. Let's see. Implement member. Let's implement create overridden function. If model class dot is assignable from. Here we need to give the ViewModel class name student ViewModel class dot java. Then return the ViewModel instance as t. Else throw illegal argument exception. Let's say unknown ViewModel class. So that's it. That is how we create a ViewModel factory. For your projects, you can just copy this factory class and reuse it by changing the parameters and the ViewModel class name. Now we have completed the ViewModel class. So let's go back to main activity and write codes to implement save student functionality. First of all, we will get these XML widgets using find view by ID. Let's define them here as private lateInit variables. Private lateInit var name edit text. Object type is edit text. I'm duplicating that statement. Change this to email edit text. Then change this to save button. Next, change this to clear button. We need to import the button. Now, inside the onCreate function, we will get those views using find view by ID. Name edit text equals find view by ID r.id.etName. We are using these IDs. Next, we need an instance of student ViewModel. Let's define it here. Now, we are going to get an instance of the ViewModel using ViewModel provider. To do that, firstly, we need to pass an instance of ViewModel factory to the ViewModel provider. But to construct a ViewModel factory, we need a DAO instance. So let's start by creating a data access object. Well, DAO. We are going to get this student DAO instance through the singleton database instance. Student database.get instance. Application. Student DAO. Then we will create the ViewModel factory passing that DAO instance. Finally, initialize the ViewModel instance using the ViewModel provider. this factory get, provide the class name, next we are going to implement click event of these two buttons. First of all, I am going to create two functions for saving data and for clearing the input fields. Private fun save student data. We need to get the entered name and the email from text input fields, create a new student instance using them, and save it to the database by invoking ViewModel's function. So we can do like this. Well, name equals name edit text dot toString. This name edit text dot text provides an editable object, so we need to use toString to convert it to a string. Then the email, now we will create a new student object. As you can remember, we set auto increment as true for the ID of the student table. So we don't have to provide a specific ID here. Room will ignore the ID provided by us and add the ID automatically. Next, invoke the insert student function of the ViewModel passing the student object. This code is 100% correct and it will work perfectly, but there is another more concise way of writing the same code. I just want to teach you that. So let's just comment this code part. ViewModel.insertStudent. I'm constructing the student object here. ID, name, and the email. So this will give the same result with less lines of code. I am deleting this code part now. Next, we will create another function to clear the input. Private fun clear input. Let's just set the text as empty. Then here, inside the onCreate function, we will write codes for quick listeners. Save button dot set onQuickListener. From here, we will call to save student data function we just created. And we need to clear the input fields after saving data. Next, clear button. Alright, now it's time to run the app and see our code in action. Let's save a student, type the name of the student and then email ID. Click on the save button. OK, input fields cleared as we intended. Since we haven't implemented the RecyclerView, we cannot see the student data on the screen yet, but we can open the database using Android Studio's database inspector tool and check the database table. Here is the database inspector. We might need to wait a little moment. Database inspector takes a little bit time to load. You can see here we have the student data table. Click on it. The data we just entered have saved to the database. Since we have set the auto generate as true, Chrome have automatically generated the ID as 1. Let's click on this live update checkbox and add another 2 records to the database. You can see data added to the database. Let's add another one. You can see new records have added to the database with automatically generated IDs. Now we are going to display the list of entered students using a RecyclerView. Let's start by creating an XML file for RecyclerView list item. File, New, Android resource file. Let's name this as list item. Select the resource type as layout. I'm going to add CRUD view as the root element. CRUD view allows us to easily create a better design for the RecyclerView list item. Let's keep the source set as main and the directory name as layout. Click on OK. You can see Android Studio has created the XML file inside the layout folder. For the CRUD view, I am setting the layout height as wrap content. Also, add some margin. CRUD corner radius as 10 dp. And elevation as 10 dp. Let's switch to code mode. You can see XML code has changed as we intended. So now to show the name and the email, I am going to add 2 text views. But before that, to arrange them vertically, we need to add a vertical linear layout. Select Layouts, drag and drop linear layout vertical to CRUD view. Let's keep the height and width as match parent. CRUD view is the parent layout of this linear layout, so it will take CRUD view's width and height. Let's add a 5 dp margin. Next, we will add 2 text views to the linear layout. I am changing the ID of this text view as TV name. Refactor. Keep the layout height as wrap content. Then set the margin start as 10 dp. Let's increase the text size and make the text bold. For the second text view, change the ID as TV email. Refactor. This time, I'm going to give the same margin start as previous. Change the text size to 24 sp. Let's zoom this one. So this is how a RecyclerView list item would look. Next, we will create an adapter class for the RecyclerView. let's create a new Kotlin class and name it as Student RecyclerView Adapter. This class should extend RecyclerView's adapter class. But in order to do that, we need to create a ViewHolder class for the list_item XML layout file we just created and provide it as the type of the RecyclerView's adapter. So, first of all, let's go ahead and create a ViewHolder class. Class StudentViewHolder. This should take the view as a constructor parameter. Import the view, and this should extend RecyclerView's ViewHolder class. Pass the view as an argument. Then we will create a function to bind values to the list_item layout. Fun bind. We should add student instance as a parameter. Import. Then we will get the name and email text views using find view by ID. Next, we will get the name and email values from the student instance and assign them to the name and email text views. Now, let's go back to top of the file and complete the adapter class. Here, we need to provide the ViewHolder class we just created as the type of the adapter. After that, generate the default overridden functions of the adapter class. OnCreateViewHolder, OnBindViewHolder, and list_item count. Let's start from the OnCreateViewHolder function. Firstly, get an instance of layout inflator. Well, layout inflator equals layoutinflator.from. Then we need to provide the context of the parent. Parent.context. We are using this parent instance. Now we have created a layout inflator object. Using that object, we will get the list_item view. In more technical terms, we will inflate the list_item view. Well, list_item equals layoutinflator.inflate. Provide the list_item XML resource file. Then the parent attached to root as false. Here we provided this list item XML resource file we created earlier. Now we just created this student ViewHolder class which takes a view instance, or in other words view object, as a constructor parameter. You know, we use words instance and object to mean the same thing. So here in this onCreate function, we will create an instance of that ViewHolder class, pass in the list item instance we just created, and return student ViewHolder list item. You can see this onBind ViewHolder function has an instance of student ViewHolder as a parameter. This onBind ViewHolder will receive the student ViewHolder instance we created in the onCreate ViewHolder. We don't have to know how that happened. RecyclerView library will do that part for us in the background. The second parameter of the onBind ViewHolder function is this position value. It will provide us the current position of the list. For example, let's say we have a list of 6 student objects. Therefore, this onBind ViewHolder function would call 6 times. Position value would change as 0, 1, 2, 3, 4 and 5 for each call. So, the task of this function is getting the relevant object from the list using the position value and passing that to the ViewHolder. But to do that, we need to have a list of students and set a function for it. Let's define an array list of students. Private val student list equals array list. Object type is student. Then here we will define a setter function for it. Fun setList. This function should have a list of students as a parameter. Clear the student list. And add the passed list to it. Now let's go back to onBind ViewHolder. Holder.bind. We need to get the relevant student object from the list using the position value. We have getItemCount function remaining to complete. This should return the size of the list. So our RecyclerView adapter class is ready. Let's go back to main activity and write codes to display the list of students. I am creating a new function named initRecyclerView. Let's go to the top of the class and define reference variables for the RecyclerView and its adapter. Then here we will initialize it using findViewById. Let's go to initRecyclerView from the onCreate. Here I am going to set the layout manager as linear layout manager. After that, initialize the adapter. Then set it as the adapter of the RecyclerView. Now, constructing RecyclerView part is done. We can add codes to display the list of students on the RecyclerView code part to this same function. But following software engineering best practices, I am creating a separate function for that and call to it from here. Display students list. Now, inside this function, we will write codes to observe the list from the student ViewModel. We are going to observe this one. ViewModel.students.observe. Lifecycle owner is this activity. This it represents the list of student objects provided as LiveData. We will pass that list to the adapter using its setList function. Finally, invoke the notify dataset changed function of the adapter. So now it is good time to run the app with emulator and see our code in action. Very good. App is working as we intended. You can see the 3 students we added to the database earlier. Let's add more students. You can see RecyclerView is showing real-time updates. Let's add some more students. You can see our list is scrolling as well. So, app is working as we expected. We have implemented saving data to the database table and retrieving data from the database table parts of the app. Now, we are going to code updating and deleting functionalities of the app. Now, I am going to add a click listener to the RecyclerView. Let's open the student RecyclerView adapter class. Inside this bind function, I am going to implement the setOnClickListener of the list item. Here, the list item is represented by the view. So, view.setOnClickListener. Now, this will trigger when we click on a list item. We need to define a function as a parameter of this bind function. Click listener. This is the name of the function. Then the lambda expression. Input type should be student because we are going to send a student instance to the main activity. Since we are not expecting any return value, return type should be unit. Now, we need to implement the body of the function inside the main activity. To do that, we need to add this function definition as a constructor parameter of this adapter class. Copy the function. Let's paste it here. Private val Now let's switch back to main activity. Create a new function for the click event. For now, I am adding a toast message. Context is this. Let's show the name of the selected student. Set the time. Show. Now go to init RecyclerView function. You can see this red color warning. Android Studio showing this because we added a constructor parameter to the student RecyclerView adapter. Now we can add curly brackets here. We are supposed to receive a student instance. Let's name it as selected item. Then pass it to the list item clicked function. Alright, now let's run the app and see how our click listener works. Click on this list item. You can see the toast message. Let's click on another item. Good. It's working as we intended. Now, our goal is to implement update and delete functionalities. In this ViewModel class, we have already created functions for them. All we need to do is call into those ViewModel functions from the main activity with the student object that needed to be updated or deleted. Let me show you how to do that. I am starting by defining a variable to hold selected student object, private, date init var selected student. Object type is student. Then, inside this list item clicked function, we can write codes to assign the selected student object to it. Let's comment this toast message. We are not going to add new buttons for update and delete. Instead, we will change the text on the save button as update and we will change the text on the clear button as delete. Next, we will define a boolean variable to check if a list item clicked. Let's set false as the default value. Then, here inside this list item clicked function, we will set it to true. Now we can use that boolean value to decide task of the buttons. Next, we will create two functions for updating and deleting data, just like the function we created for saving data. Private fun update student data. Let's invoke the update student function of the ViewModel class, ViewModel.updateStudent. Here, we need to create and pass the updated student object. But the most important thing is, updated object should have the older object's ID. ID is the primary key. Using the primary key only room can update an existing record. Because of that reason, we wrote codes to hold the current selected object in the previous function. So, the ID should be selected student's ID. For the name and email, we need to get the new name and email user typed on the text input fields. So, for that, we can just copy this code part. If the user hasn't changed the name or email, this will save the older one. After updating part is done, we need to take the screen back to default state. So, I am going to copy this code part. Change the selected student to null. Save button text should change back to save. And clear button text should change back to clear. Is list item clicked should change into false. Next, we will create the delete student function. Let's just copy paste from the above code. Change this to delete student. All other code parts remaining same. Now, let's move back to click listeners of the buttons. We are going to use the boolean value. If is list item clicked, else we need to save the data. If list item clicked, that means save button has changed as update button. So call to update student function and clear input. Now we can do the same for the clear buttons on click listener. This time, delete student data. Clear input. Android Studio show an error with these red color marks. Let's check. Null cannot be a value of a non-null type student. Actually, it is not required to assign this to null, because every time user clicks on update or delete button, input field will be cleared and is list item clicked boolean value will set to false. Therefore, update or delete will not happen until user clicks on another list item. If that happens, that new student object will be assigned to the selected student variable. So there is no need to setting this to null here. Let's just remove this code part. Now, there is one last thing remaining to do. We need to display selected student's name and email on the text input fields. Let's go back to list item clicked function. Name edit text dot set text. Selected student dot name. We are setting the name of the selected student object. Email edit text dot set text. Selected student dot email. Alright, now it's time to run the app and see update and delete functionalities in action. Let's run the app using emulator. Select a list item. You can see name and email of the selected item displayed on the input fields, and buttons have changed as update and delete. Let's change the name and email. Click on the update button. You can see the student record has updated. Let's select another student. This time click on the delete button. Student record deleted. So our app is working as we intended. This is how we use Room Library to create database operations in Android applications. Now it is good time to learn about ViewBinding. So far, during all the lessons of this course, we used findViewById to get the views. FindViewById function call finds a view that was identified by the ID attribute from the XML layout resource. That is the most basic, primary way of doing that, and we can use that for all the use cases. I think now, at this point in the course, if you followed the lessons with me, if you truly coded the lessons with me, you should have more than enough experience of using findViewById. Even though findViewById is applicable for all the scenarios, it is not that efficient. We need to always write findViewById function calls and get the views. ViewBinding and data binding are more advanced ways we can efficiently use to avoid findViewById function calls. They both are parts of Android Jetpack, and they both replace findViewById with generated binding objects to simplify code, remove bugs, and avoid all the boilerplate code lines of findViewById. ViewBinding only binds views to the codes. Data binding not only bind views to the codes, but also bind data to the views. And data binding has many other advanced, more effective features we can use for larger, more complex Android applications. Data binding is not for beginners. You may need some experience before learn data binding, but during this lesson, I will teach you all about how to use ViewBinding in your projects to reduce code lines and to improve efficiency. I am going to very quickly create a new Android Studio project to show you how to use ViewBinding. Since we have done similar projects during other lessons of this course, I am going to be very quick here. Create a new project, selecting empty activity, name it as ViewBinding demo. Switch to activity main.xml. I am giving an ID to this text view. Increase the text size and remove the default text on it. Place it near the top corner of the screen. Then I am adding an edit text. Set constraints. Give an ID to it. Increase the text size. Remove the default text and add a hint for it. Next, drag a button. Set constraints. Give an ID to it. Increase the text size. Change the text to submit. Then, let's select all three views and align them center horizontally. Switch to main activity. In order to use those views, we need to get them first using findViewById function calls. as you can see, we have used the IDs we gave to the views here with find by ID, and we have also defined new names for those views. With view binding, we are going to reduce this code part. Let's complete the code first. I'm implementing the click listener of the button. What we intend to do here is showing a customized message to the user with the typed name of the user. Let's very quickly run this app and test how this works. Okay, app is working as we intended. Now, let's move to the actual topic of the lesson. I'm going to show you how to use view binding in this project. First step is enabling view binding for this project. Go to app level build.gradle file inside the Android block. Add build features, curly braces, view binding equals true. Next, we need to rebuild the project. Build, rebuild project. When rebuilding happens, view binding generates a binding object for every layout in our project. Here we have only one XML layout file, activity_main.xml. So, view binding will generate a binding object named activity main binding. This naming convention is very simple. Make first letters of all the words capital, remove underscores, and add the word binding to the end. When we enable view binding and rebuild, view binding generates binding classes for all the XML layouts. But if we don't want that for some of our layouts, if we want a layout file to be ignored while generating binding classes, all we need to do is add the tools view binding ignore equals true attribute to the root view of that layout file, like this. But we need view binding for this layout, so I'm not going to keep it. Let's switch back to main activity again. Let's define a reference variable for the view binding object first. Private let init var binding activity main binding. Then here inside the onCreate function of the activity, we need to write codes to get the view binding object. Binding equals activity main binding dot inflate layout inflator. Next, we need to get the view using the root element of the binding object. And after that, we will rewrite the setContentView function call passing that view. Let's comment all the setContentView. Now, we don't need these findViewById function calls. Using the binding object of the layout, we can directly communicate with its views just using the ID of those views. I am commenting these code lines. ID of the button is btn submit, so this should replace as binding.btn submit. Then the ID of the text input field is etname, so this should be replaced with binding.etName. And the ID of the text view is TV message. So binding.TV message. Then here again binding.etName. Now if you run this app, this will work perfectly. But there is an even more concise way of writing this code. Instead of writing the word binding everywhere, we could just use Kotlin apply scope function. Binding.apply, curly braces covering the code part. Now we don't need to add binding for these codes. Let's remove these commented code parts also. Now I'm going to run the app and see how it works. Yes, very good. App is working as we intended. So this is how we use ViewBinding. There are some simple projects and also some layouts of larger projects. Just using find view by ID would be enough. Trying to use ViewBinding or data binding to them will be an unnecessary waste of time. We can also set ViewBinding ignore as true for those selected layouts. But in general, for the most of the projects, ViewBinding would be a great way to reduce number of code lines and to make the code more readable. Next, I would like to give you a coding challenge to apply the ViewBinding knowledge you just gained. For this exercise, we'll be using this student register app we just created during a previous lesson. I will also add the download link. So if you want, we'll be able to download this as a starter project and start this exercise directly. As you can see, we have used find view by ID to get views in this project inside both main activity and inside viewHolder class. I want you to apply ViewBinding in this project, removing find view by ID function calls. Since we have two XML layout files as activityMain.xml and listItem.xml, there will be two generated ViewBinding classes named as ActivityMainBinding and listItemBinding. How to use ViewBinding inside the adapter class part might be a little bit tricky, but if you think carefully, you will be able to do that without my help. And if you don't like thinking deep, I'm 100% sure if you do a little Google search, you will be able to find the code examples you need. Now, please pause the video and start coding. As usual, in several minutes, I will show you how to do the coding, but please try to do it without my help. Please pause the video now and start coding. I hope you all completed the task successfully. Anyway, now I am going to very quickly show you how to do that. First of all, we need to enable ViewBinding in the app level view.gradle file. We need to do that inside the Android block. Build features, ViewBinding equals true. Then sync the Gradle and rebuild the project. Select build from the top menu and then rebuild project from the drop down menu. This rebuilding part is very important. This is where ViewBinding generates binding classes for our XML layout files. Now I am moving back to main activity. Soon we will be removing these findViewById function calls. Let's start by defining an object reference variable for the ViewBinding object. XML layout file name is activityMain.xml. So generated ViewBinding class name would be activityMainBinding. Then here, let's initialize that binding instance. Binding equals activityMainBinding.inflate. Layout inflator. Then the view. Binding.root. Set content view. Pass the view. But instead of defining view as a separate variable and pass it later, we could have directly passed binding.root to the set content view. Let's just do that. Now we can remove this set content view function call also. We don't need these findViewById function calls and these variable definitions. Let's delete them. Now we can use ViewBinding for these buttons. Binding.apply. We need to add the ending curly brace here. ID of this button is btn save. And the ID of this button is btn clear. Next, I am going to do the same for other functions. Binding.apply. Then use the exact ID given in the view in the XML layout file. Here we have a problem. You can see we are using word this as the context here. This refers to the context of the current activity. But when we are using binding.apply for the entire area, context changes. So we cannot use binding.apply for this part. Instead, we'll use the basic view ID with the word binding. Binding.rvStudent. Let's delete this part. For this code, we can again use binding.apply. So that is how we use ViewBinding in main activity. Now let's switch to RecyclerView adapter class. Here inside student view holder class, instead of view, we will use the binding object. XML layout file name is list item. So the binding class would be list item binding. Private val binding list item binding. Then this should be binding.root. Now we can use binding.apply. TV name, TV email. This should be root. After that, let's move to onCreateViewHolder function. I am removing these codes. Here we need to get the list item binding object. Well, binding equals list item binding.inflate. We cannot just use the layout inflator here because adapter does not have its own context. So it should be layout inflator from parent.context, parent false. Then pass the binding object to student view holder. That's all we need to do in order to use view binding in this project. I hope you all did the same. Now let's run the app. Well, app is working as we intended. So that's how we use view binding. All we need to do is enable view binding in the Gradle, get the binding object, and use views by using their IDs. Hello everyone, welcome to day 6. During the first part of today, you are going to learn about Android services built in StopWatch App. After that, during the second part of the day, you will learn how to communicate with REST APIs, how to get data and send data from remote web servers using Retrofit. During the final part, you will learn about how to create notifications in Android applications. In Android, a service is an application component that can perform long-running operations in the background. It does not provide a user interface. Therefore, it does not attach to an activity or fragment lifecycle. A service can run continuously in the background even if the application is closed or the user switches to another application. In this section, first I will teach you the fundamentals of services using a simple demo app. Let's start by creating a new Android Studio project. Select empty activity. I am naming this as service demo. First of all, I am going to open the activity main.xml file and I am going to add 2 buttons for starting and ending the service. Let's remove this text view and drag a button. Set constraints. I am giving an ID to this as btn start. Change the text as start. Increase the text size to 34 sp. Then drag another button. Set constraints. give an ID as btn stop. Change the text as stop. Increase the text size to 34 sp. Switch to main activity again. Since you have learned ViewBinding now, I'm going to use ViewBinding in the project instead of find view by ID. Let's enable ViewBinding inside the Android block of app level build.gradle file. Build features. ViewBinding equals true. Sync the Gradle. Rebuild the project now. Then here I am defining a ViewBinding instance. Private late init var binding activity main binding. Then here inside the onCreate binding equals activity main binding.inflate layout inflator. For the view layout resource, we can use binding.root now. Then implement the click listeners of two buttons. binding.btnStart.setOnClickListener. Inside this block, we'll write codes to start the background service. binding.btnStop.setOnClickListener. Here we will write codes to stop the started background service. Next, we will create a service class. I am naming this as my background service. This class should extend the parent service class. Import the service class. Next, we need to implement onBind function. Every time we create a service, we must implement onBind function. But for this simple example, we are not going to use it. So I am returning null. You know, in Kotlin language, when there is only one return statement in the function body, we can write the function body using the equal sign without curly braces. Let me show you. Equals only the return value. Like this. Now, I am creating an init block and adding a log message there to indicate that service has been created. I added the tag as my tag. Service has been created. This means service instance, or in other words, service object has been created in the memory. In Kotlin, the code inside the init block is the first to be executed when the class is instantiated, when an object of that class is created. Then, to start that service, we need to invoke its start service function. We will do that inside the start button's click listener of the main activity. Only start command function of the service is called every time a client starts the service, invoking the start service function. So now let's implement overridden only start command function. Just start type in the function name, and Studio will do the rest. Here we should write codes to do the things that are needed each time a client requests something from the service. But now, only for this demo app, let's just add a log message. I'm using the same tag here. Service started. And here we need to change the default return value. You can see there are a lot of options. Sometimes Android system may have to destroy and restart the running service in order to manage its resources among the most prioritized apps. This return value will be used by Android system to decide how the system restarts the service after being destroyed by it. If we choose return start redeliver intent, system will pass the last intent to the service when restarting. If we choose start sticky, system will not pass the last intent when restarting. If we choose start not sticky, system will not restart the service. Let's choose start sticky for this one. Next, we will implement the onDestroy function. This function will be called when the client invokes the app stop service function. I will add a log message here using the same tag. Switch to main activity now. I'm creating an intent first. Well, service intent equals intent. Context is this. Then the name of the service class. Here, invoke start service passing the intent. To stop the running service, invoke stop service passing the intent. Let's also add two log messages using the same tag. Before test this service, there is one very important thing to do. In Android, every time we create a service, we need to add that to the manifest file. Open Android manifest.xml file. Just above the ending application tag, add the service. Now we can run the app and observe the log results. I am preparing the logcat. Click on the start button. You can see service created and started. Let's click on the stop button now and the service stopped. Service is being destroyed after invoking onDestroy function. Next, I am going to show you a good professional practice. You can see we have written the same tag name in several places. Instead of doing that, we could define it in one place and use it for all the log messages. In Kotlin, there is an object type named companion objects. Some developers call them object companions because these objects act as companions to other objects. Just like static in Java, companion objects are singleton objects whose properties and functions are tied to a class but not to the instance of that class. Let's create a companion object. Then I am creating a constant name for the tag using const keyword. I am using the same tag here. Now we can use that constant for the tag in the log messages. Here we are using that inside another class. we need to import the companion object once like this. This is the import statement of the companion object. So that's how we use companion objects. Next, I'm going to show you how to send some extra data from the view to the service and how to receive that sent data from the service. This is how we do that. Service intent.putExtra. Then give a name for the data and the value. You can see this as key and this as value. To receive this data from the other side, we need to use the same name we have given here. Switch to service class now. Well, name equals intent. Use safe call operator to avoid null point exceptions. Get string extra. We need to use the same name here. Now, there is a more professional way of doing this. Actually, that's why I introduced companion objects to you before moving to this part of the lesson. We could have defined this name as a constant inside the companion object. Let's do that now. Const val name equals name. Then replace this with the constant. And inside the main activity, we can use the same constant value again. Let's pass another data. This time, I am naming this constant as marks. Let's say total marks. Then here, service intent.putExtra. This time, I added an integral value. Switch to service class again. This time we will be using getIntExtra. For this function, we need to also add a default value. Let's run the app and observe how this works. Good. Data sending and receiving is happening as we intended. Now, instead of importing these constant values like this, many developers use them with the class name. Let me show you. I'm removing these import statements. Now, we can use these constant values with the class name. myBackgroundService.name, myBackgroundService.marks, myBackgroundService.tag, this is one way of doing that. I always teach you different methods of doing the same thing. In that way, you can choose whatever the best method for you. You can follow any correct method you like. Now, during this lesson, we are going to create this StopWatch app. You will be applying the knowledge of services you gained during the previous lesson. You will also be able to learn about Android timers and broadcast receivers during this lesson. So, let's start by creating a new Android distributor project. Select empty activity. I'm naming this as StopWatch Demo. Switch to activity_main.xml file. This time, we are going to use this default text view. We will be displaying the time on it. Let's give an ID to this as TV time. Then, set the default starting time as the default text. Increase the text size to 80 sp and make text bold. Next, drag a button. Set constraints. Let's change the text on it as start. Increase text size to 24 sp and make the text bold. Give an ID to this as btn start. Refactor. Also, let's set the corner radius as 10 dp and set the elevation as 20 dp. Next, drag another button and place it next to the start button. Set constraints. Give an ID to this as btn reset. Change the text on the button as reset. We are going to give the same attribute values we gave to the start button. Set the text size to 24 sp. Make the text bold. Set the corner radius as 10 dp. And set the elevation as 20 dp. Now, we are going to make a little change to the theme colors. Open colors.xml file inside the values folder. I'm going to add two darker colors here. This one and this one. I'm naming these colors as Gray 1 and 2. Then open both day and night theme files. I'm changing the color primary as Gray 2 and color primary variant as Gray 1. Now you can see the new colors on the activity_main.xml layout. Let's run the app once to see how this looks. Well, our main screen is looking great. Next, I am going to enable ViewBinding in the app level build.gradle file. Inside the Android block, build features, ViewBinding equals true. Sync the Gradle. After syncing is done, we should rebuild the project. This is required to generate binding objects for the XML layouts. Now switch to main activity.kt. Here we will start writing codes to get the binding object. Private let init var binding activity main binding equals activity main binding.inflate layout inflator. Then here binding.root. In this project, we can recognize 3 simple use cases: start, stop, and reset. For now, we will just create 3 functions for them. We'll code the content of them later. Private fun start, private fun stop, private fun reset. We will use this button for both start and stop actions. When the user clicks on it once, text will change to stop and it will turn into the stop button. When the user clicks on the stop button, the text on it will change to start again and it will turn back to the start button. To do that, we will use a Boolean variable named isStarted. Let's set the default value as false. Then we will create another function named start or stop. This function's job is to direct to start or stop functions considering the Boolean value. If isStarted is true, call to stop function, else call to start function. Now, inside the onCreate function, we are going to implement the click listeners of both buttons. binding.btnStart.setOnClickListener. From here, we will call to start or stop function. binding.btnReset.setOnClickListener. Call to reset function. Inside these 2 functions, we can write codes to change the text on the button. binding.btnStart.text equals stop. binding.btnStart.text equals start. We can also write codes to set the value of Boolean isStarted variable. isStarted equals true. isStarted equals false. Let's very quickly run that and see how this button works. This is a very good professional practice. When you are developing apps, always try to test every step as much as possible. Instead of doing that, if you check the entire code at once, if any error occurs, you may have to put extra effort to find the error. It will be very difficult to check the entire code. Now, I'm going to create a service class. I'm naming this as StopWatch Service. This class should extend the original service class which is in Android core libraries. Import it. Every time we create a service class, we need to implement its onBind function. Click on the red bulb, implement members. we are not going to use this function for this project, so we can just return null. We will implement two more overridden functions in the class, onStart command and onDestroy. Just type the function name onStart command, Android Studio generates the function. onDestroy, we will write more codes in these functions later. Next, we will create an instance of timer class. Private val timer. Since we are not going to reassign this instance, I have used val keyword. Actually, here we have defined and instantiated the timer in one statement. Inside the onDestroy function, we can write codes to cancel the timer. Next, we are going to create an inner class named StopWatch Timer Task. This class will take the current time as a constructor parameter, increase it by 1 and return as an updated time. But before do that, we need to define some constant values using a companion object. Since we have discussed these things during the previous lesson, I'm not going to explain it again. Companion object const val current time const val updated time Let's remove this extra R. These constant names will be used to identify keys in intents. Next, we will create the inner class. Private inner class StopWatch Timer Task. We need to add the current time as a constructor parameter. Private var time is a double. This inner class should extend the timer task class. Android Studio shows a red color warning. Let's click on the bulb sign, implement members. Now, inside run function, create a new intent for the updated value. Val intent equals intent updated time. Then we need to increase this time by 1. After that, save the current time to the intent. Intent.putExtra updated time. Finally, we need to invoke sendBroadcast function passing that intent. Inside the main activity, we will create a broadcast receiver to receive this broadcast. But before that, we need to complete the onStart command function. Inside this function, we will receive the last time passed from the main activity and send it to the StopWatch Timer Task inner class to increase. We want to increase the time by 1 second and return. Val time equals intent.getDoubleExtra. Current time, we will use this same constant name in the main activity when we are sending data. Let's add 0.0 as the default value. Then timer.schedule at fixed rate. pass the time to inner classes constructor. Delay is 0 and the period is 1 second. We need to provide it in milliseconds. So 1000 milliseconds. Therefore, the time value will increase second by second. Return start not sticky. Since we have chosen start not sticky, as you have learned during the previous lesson, system will not restart the service automatically. Android Studio showing an error here. We need to remove this save call operator. Now it's okay. Let's switch back to main activity.kt. Then define a service intent. Private date init var service intent. Then here in the onCreate function, service intent equals intent. We need to pass the application context. Then the service class, StopWatch service class.java. Now I am going to update the start function. We need to add the current time to the intent. Service intent.putExtra. Then the constant name, StopWatch service.current time. We need to define the time first. Private var time 0.0. Then pass the time here. Invoke the start service function, pass in the intent. Inside the stop function, invoke stop service, pass in the same intent. Next, we will code the broadcast receiver. Broadcast receivers are Android components which allows us to send or receive events. Private val update time broadcast receiver equals object broadcast receiver. Implement members. Let's change these two names to context and intent. Then intent dot get double extra. StopWatch service dot current time 0.0. Let's remove these default save call operators. Then we will write codes to display the received time on the text view. This time is a double value, so we need to convert it to a string. Next, inside the onCreate function, we will register the receiver. Register receiver, update time, intent filter, StopWatch service.updated time. Then we need to add the service to the manifest file. Without doing that, service will not work. Let's go through the code again. When the user clicks on the start button, start or stop function will be called. From there, start function will be called. It will invoke start service function, pass in the intent with the current time. After that, only start command function of the service class will be triggered. That function will invoke the stopwatch timer task inner class. Inside the inner class, current time will be increased by 1 second. that new increased time will be received by the broadcast receiver and displayed it on the text view. Wait, there is a mistake. We have received the current time, but in the service, we are sending the updated time. Updated time is the name of the intent. So this should change as current time. Alright, let's run the app and see how this works. Click on the start button. Time is increasing second by second as we intended. Click on stop, start again. That's good. Main functionality of the app is working well as we intended. Next, we will create a function to display the time in the format we want. Private, fun, get formatted time. We already have the time in double format, so this function should receive that time double. And it should return the formatted time as a string, so we can directly display it on the text view. In this stopwatch, we are going to display the time in days, hours, and seconds. In order to do that, we need to use remainder operator and division operator. So let's convert double value to an int first. Then, firstly, we are going to find displaying hours. There are 24 hours per day, so the maximum displaying hour number would be 23. Let's use a calculator for this one. We are going to find number of seconds per day. 1 minute has 60 seconds. 1 hour has 60 minutes. And a day has 24 such hours. So, a day has 86,400 seconds. Well, hours equals time int remainder 86,400. This will give remaining seconds. To convert that to hours, divide it by 3,600. To get the displaying minutes, we need to use the remainder operator again for the remaining seconds. Then, to find seconds, since 1 minute has 60 seconds, we need to use remainder operator with 60 again. After that, we will use Android formatter to format this string to the form we want. You can learn more about Android string formatting using this official documentation. Please read it. Return string.format. This time, this is the format I am going to use. You are going to display 2 positions, then hours, minutes, and seconds. Now we can call to this function from the update time just before displaying time on the text view. Let's also complete the reset function. When the user clicks on the reset button, we need to stop the timer. Set the time to 0 and display the starting time as 0. Now it's good time to run the app and see how it works. Click on the Start button. Stop. Start again. This time click on the Reset. Start again. Great, our app is working as we intended. The purpose of this lesson was to teach you fundamentals and give you an idea about practical applications of services, timers, and broadcast receivers in Android. This beginner level lesson did not cover them all, but I'm sure with the foundation knowledge you just gained, you will be able to do your own Google searches and learn and develop advanced applications of services by yourself. Hello everyone, welcome back. Apps need web servers to get data, to upload data, for authentication, to store images and other files. There are so many use cases. Web servers or web services usually has a REST API for the communication. The REST API provides different URLs to get data. Then from the app, we need to make an HTTP request to an URL. The HTTP request will also contain headers and other data for path and query parameters. After receiving our request, API send back a response object to our app. Response object has a response code, information about success or failure of the request. If success, it will also contain the data we requested. Most of the APIs provide this data in JSON format. Then the app need to pass those JSON formatted data to Java or Kotlin, and after that, app will store them or display them to the user. At the beginning, Android developers had to work with core Android framework libraries to implement network communications. It was a very difficult task. Then we had OKHTTP library. Later, we got this Retrofit library, which has actually created on top of OKHTTP as a wrapper to it to make our network communication task much easier and efficient. Latest versions of the Retrofit library supports Kotlin Coroutintes. Therefore, now we can avoid callbacks and we will be able to get the same work done using a very less amount of code lines. There are 3 steps of using Retrofit in your Android project. To convert JSON data to Kotlin, we need to create corresponding data classes. Then we need to create a service interface to define functions with URL endpoints. And we need to create a Retrofit instance class. So, it's time to start coding. Welcome back. Let's start by creating a new Android Studio project. I am naming this as Retrofit Demo. First of all, we need to add required dependencies. Let's open app-level build.gradle file. We can find dependencies for Retrofit from this official Retrofit site. Let's copy this one. From this Retrofit GitHub page, we can find the latest Retrofit version. It is 2.8.1. Alright, now we need to add the dependency for JSON converter. We can copy it from here. This usually has the same version as Retrofit dependency. This JSON library supports Retrofit to convert JSON data to Java or Kotlin formats. These are the converters we have. As an example, if your REST API send data using XML format, you should use this simple XML converter instead of JSON. Then let's add dependencies for Kotlin Coroutintes. Kotlin Coroutintes makes multi-threading and asynchronous programming super easier. We can find Coroutintes dependencies from this page. Current version is 1.3.5. We need to add two dependencies. This is the core dependency. And we also need to add Coroutintes Android dependency. Now, let's add dependencies for ViewModel and LiveData. We can find them from this page. At the beginning of the lesson, I will not use MEVM architecture, but later I will show you how to implement MEVM with Retrofit. For that, we will need these dependencies. We also need to add this annotation processor dependency. To use annotation processor, we should add Kotlin capped plugin here. Finally, we need to add this OKHTTP3 logging interceptor dependency. We can find it from this page. We use this to get logs for HTTP request and response data. So these are the dependencies we need. Now we can sync the Gradle. Now let's open this Android manifest.xml file. Here we need to add permissions to use internet. I'm going to also add permissions to access network state and Wi-Fi state. So that's all for the project setup. During the next lesson, let's create Kotlin data classes for corresponding JSON objects. JSON placeholder.typecode.com is one of the most popular free REST APIs we use for educational purposes. This site provides these resources for testing. And this supports all HTTP methods. This has also provided URLs with path and query parameters. For this lesson, I am going to use this albums resource. This API provides data of 100 albums in JSON format An album has an ID, user ID, and a title. In JSON, we use box brackets for arrays. We use curly brackets for objects. So here we have a JSON array of JSON objects, an array of album objects. Now we are going to fetch this data from the JSON placeholder REST API to our app. But in order to use them in our app, we need to convert them. To do that, we need to have corresponding data classes to these JSON data in our app. We can manually create them. For this example, for these simple JSON objects, we can easily do it. But in a real-world application with complex JSON objects, trying to code data classes manually will be a very inefficient, error-prone task. So, to generate corresponding data classes from JSON accurately and efficiently, we should use this JSON to Kotlin class Android Studio plugin. Go to File, Settings, then select Plugins from the left side menu. If you haven't installed this, you can just install it now. It's a 100% free plugin. Once you install the plugin, this is how we generate data classes. Copy the JSON code. Then here, select Kotlin data class file from JSON. Paste the JSON. Give a name for the main class. And click on Generate. You can see, now we have two new data classes, albums and albums item. Albums class provides an array list of album item objects. Albums item class has three properties: ID, title, and user ID. These fields are annotated with the serialized name annotation. The value of this annotation is the name to be used when serializing and deserializing these objects. These are the field names API will see when we are uploading the data using these objects. These are the field names API will use when sending data to us. If we want, we can give different names for the field names than the serialized names. So, this is how we create data classes for corresponding JSON objects. During the next lesson, let's create a service interface with URL endpoints. During the previous lesson, we created data classes considering JSON objects of the REST API. Now, during this lesson, let's create an interface with functions and URL endpoints. I am creating a new interface. Now, let's define an abstract function to get these albums data. Suspend fun get albums. This function will return a retrofit response object of type albums. Why did I include suspend modifier? Because we are willing to use Kotlin Coroutintes with Retrofit in this project. If we do not willing to use Kotlin Coroutintes, we don't need to add suspend modifier. Then I typed getAlbums as the function name. For the function name, you can give any meaningful name you like. When we are using path and query parameters, we need to define them here. We will talk about examples with path and query parameters later. Then the return type. How do we decide the return type? Retrofit always gives the result as a retrofit response object of a type. We decide the type by looking at the JSON. This is a JSON array of JSON objects. Android Studio generated a class named albums to represent the JSON array and a class named albums item to represent a JSON object inside the array. So, the type of the response should be albums, the name of the data class which represents the entire JSON object. For this simple example, we are going to send a HTTP GET request, which is the simplest form of HTTP request types. We will talk about other types during later lessons of this section. Since we are going to use a GET request, let's annotate this with GET annotation. Then here we need to include the URL endpoint. Okay. So this is the complete URL which leads to the JSON data we are willing to fetch. https JSON placeholder.typicode.com/albums. But this JSON placeholder.typicode.com part is the base URL of the API, which is common to all destinations of the API. We will add the base URL when we are creating the Retrofit instance class. For this function, we will only add the URL endpoint. So let's add it. This is our service interface. We will add more functions to this during later sections of this lesson. During the next lesson, we will create a Retrofit instance class. Hello everyone, welcome back. To send a network request to a REST API with Retrofit, we need a Retrofit instance. We can create a Retrofit instance using the builder function of the Retrofit class. I am going to create a new Kotlin class. Let's name this as Retrofit instance. Then add a companion object inside this class. Why do we add a companion object here? In Kotlin, companion object initializes when the class is loaded for the first time. So, if we write codes to create a Retrofit instance inside this companion object, we will be able to easily get it using the class name. Let's define a variable for the base URL. Well, base URL here, base URL is the basic URL for the API we are going to use. In our case, it is https JSON placeholder.typicode.com. Now, let's create a function inside this companion object which returns a Retrofit instance. Fun get Retrofit instance. Return type is Retrofit. Return retrofit.builder. Then add the base URL. Next, add the converter factory. We will use JSON converter factory to convert JSON to Kotlin. JSON converter factory.create. Inside this JSON builder.create. Finally, build. So, this is our Retrofit instance class. During the next lesson, I will show you how to get data from the API using this Retrofit instance. Hello everyone, welcome back. We have created corresponding data classes for JSON objects. We have defined a HTTP GET function in the service interface, and we just created a Retrofit instance class. Using them, I am going to write codes in the main activity to fetch these albums data from the JSON placeholder REST API to our app. First of all, we need to get an instance of the service interface. We will use the Retrofit instance class we created for that. Well, ret service retrofit instance dot get retrofit instance dot create. We need to pass the name of the interface here. Now, using a coroutine LiveData builder, we will get the retrofit response as a LiveData. We are going to get this returned value by invoking this function. Return type is a retrofit response object of albums. Well, response LiveData. Object type is LiveData of response of type albums. We need to import these objects. Kotlin Coroutintes LiveData builder is super easy. All we need to do is this. Then let's get the response object using the interface. Well, response equals retService.getAlbums. After that, we need to emit this, so it will return from the LiveData builder block as a LiveData. Now, let's write codes to observe that LiveData. Response LiveData.observe. Lifecycle owner is this. Observer. We have been writing codes to get these JSON data from the REST API. So, this it here represents a retrofit response object of type albums. From that, we will be able to get an object of albums class, which hopefully contains an array list of albums item objects, which is converted from JSON to Kotlin by this JSON converter factory. Now, let's write codes to get the list of albums item objects. Well, albums list equals it.body. This will be the response body. Let's make this a safe call. I am invoking list iterator function. What this list iterator does is, it returns a list iterator over the elements in this list in a proper sequence. So, we will be able to iterate and get elements one by one. Now, I am going to code a while loop to get the album objects. If albums list not equals to null, while albums list dot has next, Well, albums item equals albums list.next. For now, let's write codes to log the title of the album. Now, let's run the app and see how this works. Let's set the logcat to see the results. You can see app has fetched all albums data as we intended. These are the titles of the albums. Now, let's try to display this data on the screen. Let's open the activity main.xml file. I'm going to display those albums data on a text view. Since it is a large amount of data, we will need to scroll the text view. So, I'm going to drag a scroll view to this layout. Click on the Infer Constraints button to automatically set constraints. I'm going to cut this text view code and paste it inside the scroll view. Let's delete this line. Then I am giving an ID to the text view. Okay, we are ready. Let's switch back to the main activity. Let me show you how to show this data on the text view. This is how we show a variable inside a string in Kotlin. Add the new line character here. Now I am copying this for other two values. This should be album title. And change this to ID. And this one for use ID. Let's add more new line characters to the end. Then we will display this on the text view. If we do like this, we will only see the data of one album. New item will replace the previous item. But that's not what we want. We want them to join to the end. So let's use append function here. Now it's time to run the app and see this in action. Good, app is working as we intended. So that's how we can get data from REST API using Retrofit. As usual, this code sample is available to download. If you come up with any error, you can download the code sample and compare your code with mine. If you come up with any question, any not clear area, please ask from me. I'm always happy to support you. During the next lesson, we will learn about query parameters. Thank you so much for listening. See you soon with the next lesson. Hello everyone, welcome back. There are situations we need to get sorted data. Let's say we want to display all the albums belong to the third user. For that, we will use a HTTP GET request with a query parameter. Let me show you how a HTTP GET request with query parameter works in a web page. This is how a URL of a GET request with a query parameter looks like. We add a question mark after URL endpoint and add the parameters. These are the JSON data of albums belong to the third user. Now let's go back to album service interface and declare a function there to get a list of sorted by user ID albums. I'm going to just copy paste this one. This URL endpoint does not change. Let's change the name as sorted albums. To add a query parameter, we use the query annotation. Then we need to provide the name of the field as the value, which is this user ID. Then let's define the parameter here, as we usually do for any Kotlin function parameter. User ID, data type is int. Now let's switch back to main activity. To call to our new function, all we need to do is this. Let service.getSortedAlbums. I will pass the user ID as 3. Now let's run the app again and see how our new function works. Good. You can see now we only have the albums with the user ID as 3. So that's how we use query parameters with Retrofit. During the next lesson, I will show you how to use path parameters with Retrofit. Hello everyone, welcome back. During this lesson, let's talk about Retrofit path parameters. We define path parameters as named replacements in the URL. Let me explain this with a web URL example. This JSON placeholder REST API allows us to get a single album object by providing the album ID as a path parameter. Let's add 3. So this is the album object with the ID 3. These path parameters depends on the API implementation. Since JSON placeholder API creators have implemented the facility to get a single album object using the ID as a path parameter, we were able to get the JSON objects like this. Now let's go back to the album service interface. Let's assume that we want to request a single album using the album ID. Suspend fun get album. To indicate a path parameter, we use the path annotation. For the value, we need to give this variable name given in the relevant data class. Then define the parameter. Album ID, type is int. As you can see here, this URL with path parameter gives an album item object. Therefore, the return type should be a retrofit response object of type album item. Then let's define the URL endpoint with the get annotation. Here we need to add this ID value inside the curly brackets. Now let's switch back to main.activity.kt. Here in the onCreate function, I am going to write codes to get a album item object using the newly created function. For now, our goal is to just learn how Retrofit path parameters works. So let's just use a toast message to display the result. We need to create a separate LiveData builder for this one. Well, path response. This should be a LiveData of retrofit response objects of type albums item. LiveData. Well, response. RedService.getAlbum. I am sending 3 as the album ID. Then emit. Next, let's write codes to observe this LiveData. Path response dot observe this observer. Let's get this title. Now, this body of the response provides album object. So we can get the title from it. Let's add a toast message to display the title. Now, it's time to run the app and see this in action. Okay, we can see the toast message. So this is how retrofit path parameters work. Hello everyone, welcome back. First of all, I'm going to make this main activity code more readable. Let's make this ret service as an instance variable so all the functions can use it. Now, I'm declaring a function for this getRequest with query parameters. Let's cut this code part and paste it inside the new function. Now, I'm declaring a function for getRequest with part parameters code part. Let's cut this code part and paste it inside the function. Then we can call to these functions from the onCreate like this. Let's comment this one. Now, during this lesson, we are going to learn about HTTP logging interceptor. To use this, we need to add the HTTP logging interceptor library to the Gradle. We have already added it to the Gradle during the project setup at the very beginning of this section. Now, let's open the Retrofit instance class. We are going to write codes to use logging interceptor here. As you have learned earlier, Retrofit library has created on top of the OKHTTP library. Retrofit uses classes of the OKHTTP to perform network operations. This HTTP logging interceptor is a feature belongs to the OKHTTP library, which shows logs of network operations that happened in our application. This is very useful to the developers to understand what is going on, and when our code is not working, this will really help us to find the problem. Okay, let's create an instance of interceptor here. Well, interceptor equals HTTP logging interceptor dot apply. You can see here, Android Studio has imported this HTTP logging interceptor package. Now, let's set the level. This body level logs request and response lines and their respective headers and bodies of the network operation. There are other levels. If you choose basic, it will log request and response lines only. If you choose header, it will log request and response lines and their respective headers. Now let's create an OK HTTP client instance. Well, client equals OK HTTP client.builder. Apply. Then add the interceptor. Next, build. Actually, we should have written these codes inside the companion object. Let's just cut them and paste them inside the companion object. Finally, add HTTP client to the Retrofit instance. Now, if we run the app, this OK HTTP logging interceptor will log the network operations details as Android Studio logcat messages. Let's run the app and see how this works. Open the logcat. These are the logs generated by OK HTTP logging interceptor. Let's use the search. So, these are the logs of the network operations we just completed. This is the GET request from the app with the complete URL. This URL has created combining the base URL and the URL endpoint. After that, we have the response received from the server. This 200 is the response code. 200 is the standard response for a successful HTTP request. You can learn about these HTTP response codes from this Wikipedia page. Codes between 100 to 200 are for informational responses. Codes between 200 to 300 are success responses, like the one we just received. Codes between 300 to 400 are indicating a redirection. Codes between 400 to 500 are informing an error from the client side. 500 to 600 are indicating a server-side error. Let's go back to our log. After the response code, we have other details like content type, cookies, and cache control. Then we have this JSON data, which are converted to Kotlin using JSON converter factory and displayed on a text view. So that's how we use HTTP logging interceptor to log details about the network operation. We are going to learn about how to configure timeouts during the next lesson. A long time ago, when I was working as an Android developer for the first time, we had to work in an app development project for a products delivering company. Sales representatives would use the app to get orders from the different shop owners from all areas of the country. This app was communicating with the REST API created using ASP.NET to provide real-time stock updates. This app had to frequently download data of more than 1,600 products and display those details using a RecyclerView. We tested the app well inside the company and then we launched the app for beta testing. When we were testing inside the company with high-speed internet, all the data loaded without any issue. But in some rural areas of the country, as a result of slower internet connection, app didn't download all the data. Sometimes app didn't download any data. Then, after doing some research, we were able to fix the problem by increasing the connection timeout and read timeout of the Retrofit instance. So, during this lesson, I'm going to show you how to configure timeout settings of a Retrofit instance. We will add them inside this OK HTTP client builder block. We don't need to manually add timeouts if it is not required. If we don't specify, Retrofit will use default timeout values, which is 10 seconds for each timeout. Connect timeout. I am adding 30 seconds. Here we need to provide the unit of the value we just typed. Connect timeout is the time period in which our app should establish a connection with the server. Since we just set it as 30 seconds, our app's HTTP client, which is the Retrofit instance, will try to connect to the server for 30 seconds. After 30 seconds, it will stop trying. By default, this is just 10 seconds. So I think for the most of the cases, 30 seconds will be more than enough. Then read timeout. Let's just add 20 seconds. Read timeout has defined as maximum time gap between arrivals of two data packets when waiting for the server's response. Next, write timeout. This is the maximum time gap between two data packets when sending them to the server. Let's just add 25 seconds. Here for this demo project, I just added random values for them. But in a real app, you should add these values considering facts such as internet speed, performance of the server, and performance level of the devices you are willing to install the app. But for most of the cases, default timeout values would be enough. We have already added the client to the Retrofit instance. So this is how we configure timeout settings using an OK HTTP client. I hope it will be very useful for your app development projects. Hello everyone. Notifications comes under behavior components of Android Jetpack. A notification is a message that our app displays outside of its user interface. We use notifications for reminders, to communicate with the user, or to provide timely information. Users can open the app or sometimes take an app-related action directly from the notification by tapping on it. When our app issues a notification, it first appears as an icon in the status bar. Users can swipe down on the status bar to open the notification drawer where they can view more details and take actions with the notification. A notification remains visible in the notification drawer until dismissed by the app or the user. Beginning with Android 5.0, notifications can also briefly appear in a floating window. We call them heads-up notifications. We use them to provide the information that users should know immediately. And it appears only if the device is unlocked. Beginning with Android 5.0, notifications can appear on the lock screen. We can programmatically set the level of detail visible in notifications if required. Notifications were there from the very beginning, but now with new Jetpack APIs, we have ability to create more interactive, more advanced notifications. Now, let's start by creating a very basic notification. Then, step by step, I will teach you about more advanced features. Let's create a new Android Studio project. I am naming this as Notification Demo. This is very important. Here, we need to set the minimum SDK to API 26 or Android 8 because most of the notification features needs at least API 26. Open the ActivityMain.xml file, switch to Design Mode, and delete the default text view widget. Now let's drag and drop a button object from the panel onto the center of the layout canvas. Let's very quickly add constraints. We will write codes to trigger a notification for the click event of this button. Let's switch to main.activity.kt. In this onCreate function, I am going to implement the onClick listener of the button. ID is button. So button.setOnClickListener. Let's create a new function below. Private fun display notification. Now call to our new function from the click listener. And here I am writing codes to get the notification manager instance. Before write codes to send a notification, we have to first write codes to create a notification channel. Here, let's define a channel ID for the notification channel. I am using this name here. Then let's define a notification manager instance, which is required to create a notification channel as well as a notification instance. We define this as a var because we are going to get this using the system service, so there is a chance for it to be reassigned. Let's write codes to get the notification manager instance here. Notification manager equals get system service context.notification service as notification manager. A notification channel has an ID, a channel name, and a channel description. We create a notification channel by creating a notification channel instance and then passing that instance to the create notification channel of the notification manager class. Let's create a new function, private fun create notification channel. This function should have 3 parameters: ID, name, and channel description. SDK version should be Android Oreo or above. Let's write a validation for that. We add this validation to avoid unnecessary app crashes for lower versions. A notification channel has an importance level. You can see there are different importance levels. This parameter determines how to interrupt the user for any notification that belongs to this channel. Let's set this as high, then create a channel instance. Then set the description. We can even set the description in this more Kotlin way. Finally, let's register the notification channel with the system using the notification manager instance we created earlier. Now, from the onCreate function, let's call to that function by passing an ID, name, and a description. Actually, we need to create the notification channel before posting any notifications. By adding this function call to onCreate, we will be able to execute this code as soon as our app starts. Now, I'm going to implement the display notification function. A notification in its most basic form displays an icon, a title, and a description. Let's define a notification ID here. You can use any int value you want. Well, notification. We will use notification compat to create the notification object. Notification compat dot builder. We need to pass the context and channel ID here. Let's add the title for the notification. Then the content of the notification. Next, I am adding a small icon. For now, let's just add an icon given by the Android Studio. Let's set the auto cancel as true, so the notification will be automatically cancelled when the user clicks on the panel. Then the priority, I am setting the priority as high. Then build. Finally, notification manager dot notify. Pass the notification ID and newly created notification instance as arguments. Now it's time to run the app and see this in action. Let's click on the button. This is our notification. You can see icon has appeared in the status bar. Now let's swipe down on the status bar to open the notification. So that's how we create a simple, basic notification. Congratulations! Now you have successfully completed the 6th day of our 7-day bootcamp. We covered a lot of advanced Android development topics today. So if you feel a little bit difficult to understand, please watch the lesson again and again several times and do the coding. You will be able to get familiar with those advanced technologies. As usual, I have added links of all the code samples required as starter projects and final projects in the description down below. Please download them and use them for your studies. I have also added references related to these topics into the day 6 part of the description. Please use them to improve your knowledge and skills. So that's all for day 6. Thank you so much for listening. See you soon with day 7. Hello everyone. Welcome to the final day of our Android Development for Beginners 7-day bootcamp. During last 6 days, you have learned about basic building blocks of an Android application, Kotlin language fundamentals, activity lifecycle, Android user interface design, how to work with media files, ViewModel and LiveData, RecyclerView, Kotlin Coroutintes, how to create local databases with Room, ViewBinding, Android services, how to communicate with the web server using Retrofit, and notifications. Today is all about fragments. Single activity multiple fragments model is a highly recommended best practice by Google for Android applications development. And also, if we are using design patterns such as navigation drawer or tab layouts, you need to use fragments, and you need to learn about how to implement navigation components for those fragments. Today, I will start the day by providing an introduction about fragments. After that, I will teach you how to use Jetpack Navigation Components library to create navigation graphs and manage navigation between fragments. In Android, we have a sub-activity component called fragment. A fragment represents a reusable portion of the app's user interface. It has many similarities to an activity. Just like an activity, a fragment defines and manages its own layout, has its own lifecycle, and can handle its own input events. But fragments cannot live on their own. They must be hosted by an activity or another fragment. There can be more than one fragments in an activity. Actually, fragments represent multiple screens inside an activity. During a previous lesson, we learned about Android activity lifecycle. Fragments also has a lifecycle. Fragment lifecycle has additional callback functions than activity lifecycle, such as onCreateView, onViewCreated, onViewState restored, onSaved instance state, and onDestroyView. Since fragment is a view component, these additional steps are related to creating and destroying the view. We can create Android applications without using any fragments. There are many great Android applications created using only activities. But to provide a much better user experience, we need to always use fragments. Let me explain with a more practical example. I am creating a new Android Studio project. File, new project. Here, in this new projects window, we always selected empty activity because I didn't want to add unnecessary complexity to your beginner level tutorials. But since we are studying fragments now, let's select this bottom navigation activity. I am naming this project as Fragments Demo. Finish. So, this is the new project we created. You can see there are 4 XML layouts, 1 activity, and 3 fragments. Let's check the Kotlin files. Here is the main activity, and inside this UI package we have 3 sub-packages: dashboard, home, notifications. Let's expand them. You can see each of them has a fragment and its corresponding view model. Dashboard fragment, dashboard view model. And this is the XML layout file, fragment_dashboard.xml. We have similar file sets for all 3 fragments. You can see Android Studio has already written setup code parts for ViewBinding. And these codes are there for setting the bottom navigation view. This is the code part where we connect the 3 fragments to the bottom navigation view. Let's run the app. This is the bottom navigation view, home fragment, dashboard fragment, and notification fragment. Now let's open the dashboard fragment and fragment_dashboard.xml file. Here is the default text view. I'm going to drag a button to the XML layout file. set constraints, and give an ID. So this is the layout file of the dashboard fragment. What I want to tell you is that we can design fragment layouts and do the coding in the same way we did for the activities. Now switch to dashboard-fragment.kt. Let's implement the click listener of the button. In Fragments, we need to write codes inside the onCreateView function instead of onCreate function we used in activities. binding.btntest. Set on click listener. I am going to add a toast message. Since fragments live on an activity, we need to use the property name activity for the context. That refers to the context of the current activity of the fragment. Let's run the app and check how our button click listener works. I just wanted to give you an idea about fragments and how fragments work. This is not the time to go deep about applications of bottom navigation view. I will do a separate tutorial for you on bottom navigation view later. During the next lesson, I am going to teach you how to manage navigations between fragments using navigation architecture components. Inside this res directory, you can see there is a directory named navigation. Inside that, you can see the navigation graph XML file of this app. By default, Android Studio has loaded all the fragments into the graph, but this graph is not completed. It is up to developer to complete the graph considering the navigation requirements of the project. When you are using activity templates like this one we used to create this project, Android Studio provides a lot of boilerplate codes. You saw Android Studio has added codes for data binding, navigation, and for the bottom navigation view. Please do your own research on these different templates. Please create new projects using other activity templates and study those codes. I will also add useful hand-picked references about different applications of those templates to the description of this section. Now, during the next section of this course, I am going to teach you everything about how to manage navigation between fragments using navigation architecture components. Hello everyone, welcome back. When we were creating the view components of our Android apps, which means mainly activities and fragments, providing proper navigation between screens was a time-taking, complex task. Recently introduced Android Jetpack Navigation Architecture Component library makes our development task much easier by providing many built-in tools to handle everything needed for in-app navigation. The new trend in Android development is single activity, multiple fragments model. When we were using navigation architecture component, we usually create a single empty activity, which acts as a basement. All other screens of the app will be created using fragments. Actually, this is the recommended best practice for creating the view components of Android apps. What navigation library does is, it generates a lot of supporting classes behind the scene. Considering our commands, these generated classes makes our works simpler and easier. There are three main parts of a navigation component: navigation graph, nav-host fragment, and nav controller. Navigation graph is an XML resource file that contains all navigation-related information. This allows us to manage navigation-related tasks from a single location. Nav-host fragment is an empty container we keep on the activity to hold the navigation graph. Nav controller is a class generated by the navigation library to manage the navigation between destinations we added to the navigation graph. During the first part of this section, we will learn all the steps of using navigation architecture component one by one with very simple code examples. Later, for the coding challenge, we will build this navigation component example, combining all the things we learned during the section. Let's start by creating a new Android Studio project. I am naming this as NavDemo. Now, let's add dependencies for navigation. To use navigation library, we must have added Google and Maven repositories to our project. It is usually there by default in the top-level Gradle file. We can find navigation components dependencies from this link. I'm going to copy-paste them to the app-level build.gradle file. When we are using navigation architecture components to pass data between fragments, we need to use safe args. So we need to add safe args to our project. To do that, let's copy-paste this class path in our top-level build.gradle file. We also need to add this safe args plugin to the app-level Gradle file. This is all we need to work with navigation. Let's sync the Gradle now. But I am also going to use ViewBinding for this project. Therefore, I am enabling ViewBinding inside the Android block of the app-level Gradle file. ViewBinding curly braces enabled equals true. Sync the Gradle again. We need to rebuild the project now. You must rebuild the project after enabling ViewBinding or data binding. Otherwise, binding objects will not be created. We can use navigation without using ViewBinding, but when it comes to larger real-world projects, we need to always use navigation with ViewBinding or data binding. That is the best practice. Since you have already studied ViewBinding during previous sections of this course, I decided to use ViewBinding in these examples. So you will learn another practical application of ViewBinding with these lessons. After rebuilding is completely done, let's very quickly write codes to construct a binding object in the main activity. Private let init var binding activity main binding. Binding equals activity main binding dot inflate layout inflator set content view binding.root. So that's all for project setup required for the navigation architecture components. During the next lesson, we will create a navigation graph. Hello everyone, welcome back. This is a navigation graph. Here, my Android Studio displaying the navigation graph in its navigation editor. It shows all the screens of the app and how the user can reach to them. We call them destinations. This is the home screen. From there we can reach to two destinations, name fragment and terms fragment. From the name fragment, user can reach to email fragment. From there, user can reach to welcome fragment. From the welcome fragment, user can reach to terms fragment again. If we switch to the text view, we will see here we have XML codes of all the fragments in one place. So this navigation graphs allows us to manage all the navigation related actions of the app in the same place. Now let's go back to project we created during the previous lesson. If you check this res folder, you will see there are 4 resource folders. When we create a navigation graph, Android Studio will create a new folder as navigation and add that XML resource file in it. To create the navigation graph, let's select App, right click, New Android resource file. I'm typing the file name as nav_graph. Then we must select the resource type as navigation. Click OK. So this is our navigation graph. If you check the res folder, you will see now there is a new navigation folder and we have navgraph.xml file located in it. We haven't added any destinations yet. Also, there is no navhost fragment. If we switch to text view or XML view, we will be able to see the navigation graph which has created using the navigation tags. So this is how we create a navigation graph. During the next lesson, I will show you how to create a navigation host fragment. Hello everyone, welcome back. To host the navigation graph, we need a host fragment. Navigation graph connect to the other parts of the app through the host fragment. If we switch to design view of the navigation graph, we will see this no nav host fragment found notification. To add the navigation host fragment, let's go to activity_main.xml file. Then switch to design mode. We don't need this text view. I am removing it. If you select containers from the palette, you will see this navhost fragment container. Let's drag it to the activity main. Here, Android Studio has automatically recognized the navigation graph we created during the previous lesson. Let's click OK. I am clicking on Infer Constraints button to set constraints automatically. That's all we need to do to have a navigation host fragment. Let's switch to XML mode. This is the XML code just generated for the newly added fragment container view. This is just another fragment view with some advanced properties. The name is androidx.navigation.fragment.navhostFragment. Value of the default navhost property has set as true. And finally, the path of the navigation graph XML resource file we created during the previous lesson has set as the value of the navgraph property. Let's go back to navigation graph. You can see now it shows the activity_main.xml file we just used to add the navhost fragment as the host. So that's how we create a navhost fragment. During the next lesson, let's learn how to create destinations. Hello everyone, I'm going to use 3 minutes of your valuable time to inform you about my highly rated Advanced Android Development Bootcamp at Udemy. This very large course covers all the advanced Android development topics such as Jetpack Compose, dependency injection with Dagger and Hilt, networking with Retrofit, Kotlin Coroutintes, unit testing, MEVM clean architecture, single activity multiple fragments model, Android Jetpack architecture components such as ViewModel, LiveData, Room, data binding, work manager, paging, and navigation with very easy to understand project examples. After covering the fundamentals, you will be building larger, professional level, more complex, complete projects covering all the fundamentals you learned. From this course, you will be able to master MEVM clean architecture and many other professional level Android development best practices, which I learned by experience working as a software developer since 2008. By the time I am recording this, my course has over 4.7 average rating out of 5. Over 8,000 paid students have already enrolled to the course and over 1,600 students have rated the course. Please use the link below and check those reviews given by students who completed the course. I have added a highly discounted or 85% price reduced link for you in the description below. It is at the top of the description just after the download link of the free ebook. Price will be something around $10. It's less than the price of a t-shirt and it will save months of your valuable time and pain of self-studying. This course worth 10 times more than the price you pay. Don't get me wrong, after following this beginner course with the foundation we create here, you will definitely be able to do your own self-studies, do your own researches, and learn all those advanced Android development topics by yourself using YouTube videos and blog articles. But take a lot of time, and there is a pain in self-studying. Contents are not connected to each other, many outdated tutorials there. But instead, by following my course, you will be able to get all the advanced Android development knowledge you need in a well-organized and easy to understand manner with up-to-date course content. And we also have a very active Q&A forum there, from which you will be able to get all the support you need. And this course comes with the 30-day money-back guarantee, so you will have no risk at all. If you are unsatisfied in any way, you will get your money back. Please don't believe my words. Please use the link, go there and check the reviews given by students who already followed the course. So, I invite you to use the opportunity and join with me at Udemy. I promise it will be a great learning experience worth 10 times the money you pay. Alright, let's go back to lessons now. Hello everyone, welcome back. Different fragments in the navigation graph are called navigation destinations. Let's click here to add a navigation destination. Then click on Create New Destination. You can see there are a lot of fragment options we can choose from. For now, let's just select blank fragment. I am naming this fragment as Home Fragment. XML name also changed to Fragment Home. This is the newly created homefragment.kt file, and this is its corresponding XML layout file. Here is the navigation graph. We have our home fragment. This home symbol indicates start destination. Since we have only one fragment, this home fragment has marked as the start destination. If you switch to XML mode, you will see in this navigation tag, value of the start destination property has set as home fragment. We can open the XML file of the home fragment by double-clicking on its destination diagram. I am deleting this text view. Since constraint layout is much easier to work with, I am going to convert this frame layout into a constraint layout. Remove this generated ID. Now I'm going to very quickly add an edit text and a button to this layout. Drag and edit text. Set constraints. Give an ID to it as ET name. Let's set the text size as 30 sp and remove the default text on it. Then let's drag a button. Give an ID to it as btn submit. Refactor. Set constraints. Change the text as submit and set the text size as 30 sp. Now, since this is the start destination, if we run the app, this screen will be displayed. Let's run the app and have a look. Start destination displayed as we expected. Now let's open the home fragment.kt file and add codes to use ViewBinding there. We don't need these codes for this project. Let's remove them first. Private latent binding. Fragment home binding. If your code is not showing fragment home binding or showing any error, you may need to rebuild the project. Then here, inside the onCreate view, binding equals fragment home binding dot inflate. Since we are using ViewBinding in a fragment, inflator container false. Then return binding.root. Now let's go back to navigation graph. I'm going to add another destination. Let's click on this new destination icon. Create new destination. Select blank fragment again. I am naming this fragment as second fragment. Click on finish. Now we have two destinations. Let's click on this to open the XML file. Change the frame layout as constraint layout. I'm removing the ID also. You can give a new ID if you want. Now we need to set the height and width of this text view as wrap content. Let's give an ID to this text view as TV name. I'm removing the text on it and change the text size to 30 sp. Now let's open the second fragment.kt file. Let's remove these extra code parts first. Here I am going to construct a ViewBinding object as we just did for the home fragment. Private latent binding. Object type is fragment second binding. Then here in the onCreate view, binding equals fragment second binding dot inflate. Inflator container false. Finally, return binding.root. So During this lesson, you learned about how to create navigation destinations, and also we completed ViewBinding related code parts for those fragments. During the next lesson, you will learn about actions and nav controller. Hello everyone, welcome back. Before add any action, let's switch to text mode of this navigation graph and have a look. When we were checking this before, we only had navigation text. Now we have two fragments in it, and also the value of the start destination property has set to home fragment. Let's switch back to design mode. Now, if we run this app, user will see the home fragment. I want to write a click event for this submit button to open the second fragment. If we add an action from home fragment to second fragment, we will be able to do it very easily. If you hover the mouse pointer over the vertical center of the right hand edge of the home fragment, a circle will appear like this. Now click within the circle and drag the resulting line to the second fragment and release it. That's it. We just created an action. Android Studio has already given it an ID as action home fragment to second fragment. If you want, you can rename it. For now, I'm going to keep this ID unchanged. Now, if you switch to the text mode, you will see this new action added to the home fragment's XML code. Its ID is action home fragment to second fragment, and its destination is second fragment. Let's go to the home fragment.kt now. Here, I am going to implement the onClick listener event of the button. Binding.button.set onClick listener. Then we will use nav controller object to navigate to the second fragment. We will use this action ID for that. To get the nav controller, we need to use the view. Here, view is represented by it. It.find nav controller .navigate. We need to pass the action ID to navigate function as an argument. r.id.action home fragment to second fragment. If you cannot see this ID in your list, you should rebuild the project and try again. Let's run that and see it in action. Click on the submit button. It navigates to the second fragment. If we click on the phone's back button, it will navigate back to the home fragment. So, this is how we use actions to navigate between destinations. During the next lesson, let's talk about how to pass data between destinations. Hello everyone, welcome back. During the previous lesson, we learned about how to navigate between destinations using nav controller. Now, during this lesson, you will learn about how to pass data from one destination to another. Here, in the home fragment, we have already added an edit text to get the user input, and also we have added the submit button. In the second fragment, we have already added a text view. So, let's write codes to display the user input on the text view of the second fragment. This is how we do it. We are going to get the user input as a bundle. Well, bundle equals bundle of. We are going to get the value of this edit text with the ID. Let's assign a name for the value of the edit text as use input to binding.editText .text.toString. Then we should pass that bundle as the second argument of this navigate function. Now let's switch back to the second fragment. We added the bundle as an argument. Here we will write codes to get it from the arguments. Well, input equals require arguments dot get string key should be this use input we added in the home fragment. Then I am going to write codes to display this use input value on the text view. Binding.textView.text equals input. So it's time to run the app and see it in action. Let's insert a name and click on submit. Good, app is working as we intended. Before end the lesson, to avoid null inputs, I am going to add a little validation to this edit text. This is a good coding practice. This knowledge will be very useful to you in many situations. If textutils is empty, binding.editText.text.toString. This use input should not be empty. Else, let's display a toast message. Okay, this will do. Let's run the app to test the validation. Okay, it shows the toast message for empty input. App is working as we expected. So this is how we pass data between destinations. We get the data as a bundle with the key and pass the bundle as an argument to the navigate function. Then in the other destination, we receive those data using require arguments.getString function call using the key we used in the first fragment. So I am going to end this lesson now. During the next lesson, I will show you how to add animations to these navigations. Let's open the navigation graph and select the action home fragment to second fragment. In this attributes window, you can see there are spaces for 4 animations: enter, exit, pop enter, and pop exit. When we navigate from one destination to another or from one screen to another, new screen will appear with the enter animation and the older window will disappear with the exit animation. When the user clicks on the back symbol of the phone, when the screen navigates backwards, current screen will disappear with the pop exit animation and the previous window will appear with the pop enter animation. At the moment, our app doesn't show any special animation. Screens just appear and disappear. Therefore, let's add some animations to our app screens. In Android, animations are written in XML. In animation resource files. First, we need to add animation resource files to our project. If you search Google for Android animation resource codes, you will find a lot of XML samples. Here, I found a good set of resources from this Stack Overflow link. This also has push down in, push down out, push up in, push up out, slide in left, slide in right, slide out left, and slide out right. This one has even more XML code samples, such as rotation, scale from corner, scale towards corner. There are so many animation resource files available on the internet. You could use them for your own experiments. For now, I am going to create 4 animation resource files for slide in left, slide in right, slide out left, and slide out right. Select the app, new Android resource file. I am copy pasting file names and XML codes from the web. Paste the name. Resource type should be animation. Copy the XML now. Paste here, replacing the default code. Now I am doing the same steps for the slide in right. Then slide out left. Finally, slide out right. Now let's add animations to our project. I am selecting enter animation as slide in left and exit animation as slide out right. For the back button, let's select pop enter animation as slide in right and pop exit animation as slide out left. Alright, now let's run the app and see how these animations work. Let's check the pop animations. Seems like animations are a little bit slower. So let's open the animation resource files and reduce the time. You can see these durations are set as 5 seconds. I am going to change them to 1 second. Now let's run the app again. Good. This time animation speed is much better. So this is how we add animations to our navigation destinations. Now that you have learned a lot of things about Android Jetpack navigation architecture component, you learned about navigation graph, navigation host fragment, destinations, actions, transforming data, and animations. This is the simple app I want you to create utilizing every new thing you learned during this section. In the home destination, you will have 2 buttons for sign up and for viewing terms. If the user clicks on the terms button, user will be navigated to terms fragment with the push down animation. After that, if the user clicks on the back button, user will be navigated back to the home fragment with the push up animation. If the user clicks on the sign up button, enter your name screen will be displayed with the slide in animation. Here you will add and edit text with validations to get the user input name. After inserting the name, user will click on the next button. Then again, another screen should display with the slide in animation. Here you should add and edit text to get the email with validations. User will click on the submit button after entering the email. Then the user will be navigated to welcome screen. You may write codes to display the name and email address entered by the user on the welcome screen. You may add animations for all the back navigations, and user will also be able to navigate from the welcome screen to the terms screen. The good thing is, to make things much easier for you, I have already created all the layouts and animation resource files for you. I have also added all Gradle dependencies. Not only that, I have enabled ViewBinding and I have written codes to construct the ViewBinding objects in each view controller. This is how the navigation graph should look. This partially completed project is available to download as the starter project. Please download it now. Can you complete the project by completing navigation related parts? Let's give it a try. As always, I will provide the entire answer with code samples during the next lesson. Therefore, you will be able to compare your code with mine. So, please pause the lesson now and start coding. You can do this without my help. Go for it. Hello everyone, welcome back. I hope you all have successfully completed the coding challenge. Congratulations. I am going to do it now so you can compare your completed code with mine. Here I have opened the starter project of the coding challenge. Since I have already added all the Gradle dependencies and layouts to the starter project, let's start by creating a navigation graph. Select the app folder, right-click, new Android resource file. Let's name this as navgraph. And most importantly, select the resource type as navigation. So, this is the navgraph we just created. Then, for our next step, let's go to activity-main.xml file and add a navhost fragment to it. Activity main. From the palette, select container. Here we have the navhost fragment container. Let's drag it to our activity_main.xml file. Here, Android Studio has recognized the navgraph. In larger projects, there can be more than one navigation graph. If that happens, we can choose the relevant navigation graph from here. So, let's press OK. Click the Infer Constraints icon to set constraints automatically. Now, let's switch back to navgraph. Next, we need to add destinations. Click on the Click to Add Destination tag. You can see this list shows all potential destinations. Since our starter project already has all the required fragments designed, we can just choose them from this list. Let's choose the home fragment. If your nav graph shows a preview unavailable error message, don't worry. In older Android Studio versions, that happens when we are using already created fragments instead of creating fragments using navigation editor. We can fix that very easily. All you need to do is switch to text mode of the navigation editor and manually add this tools namespace. And later, using that, add this layout property of the fragment. Let's switch back to design mode and add all other fragments to this navigation graph. Email fragment, welcome fragment, terms fragment, and name fragment. You need to design your navigation graph like this. We need to take the home fragment to the left corner, then the name fragment. Email fragment comes after the name fragment. Some of you might need to use these zoom in and zoom out buttons. Now, I am going to add actions. If the user press sign up button, user should lead to name fragment. From the name fragment, user should navigate to email fragment and finally to the welcome fragment. If you hover the mouse pointer over the vertical center of the right hand edge of the home fragment, a circle will appear like this. Then click within the circle and drag the resulting line to the name fragment and release. Let's do the same for other actions. User should be able to navigate to terms fragment by pressing the terms button of the home fragment. So let's add an action for that. Also, the user should be able to navigate to the terms fragment by pressing the view terms button of the welcome fragment. We need to add a navigation for that also. So this is our navigation graph. Then I am going to add animations for these sections. Let's select action home fragment to name fragment. For the enter animation, I am setting slide in left. For the exit animation, I am selecting slide in right. For the pop enter animation, let's add slide out right. For the pop exit animation, slide out left. Now I am going to repeat same for the action name fragment to email fragment. Slide in left. Slide in right. Slide out right. Slide out left. Then let's go for the action email fragment to welcome fragment. Slide in left. Slide in right. Slide out right. Slide out left. There are no rules here. There is no special order. You can choose whatever appropriate animation you like. It's up to you to decide. For the actions related to terms fragment, I am going to add a different animation. This is action welcome fragment to terms fragment. Let's add push animations. Push down in. Push down out. Push up in. push up out. Finally, for the action home fragment to terms fragment, push down in, push down out, push up in, push up out. Let's switch to the text mode of the nav graph. We can see here these newly added actions. Now let's go back to home fragment. Here I am going to implement click listeners of the buttons. Let's start with sign up button, binding.btn sign up, set on click listener. We need to navigate to the name fragment with this button click. We are going to get a nav controller instance using the view and invoke its navigate function, passing the action name it.findNavController.navigate r.id.action home fragment to name fragment. Now let's do the same for the terms button. Binding.btn terms.set on click listener. it.findNavController.navigate r.id.action home fragment to terms fragment. Before writing other codes, let's run the app and have a look. Press the sign up button. This is the name fragment, and sliding animations are working as we expected. Let's click on the terms button. This is the terms fragment, and push animations are also working well. Now let's open the name fragment. Here we need to write codes to get the user input from the edit text and navigate to the email fragment. This is the next button. So let's write the on-click listener, binding.btn name.set on-click listener. Username cannot be empty, so let's add the validation for that. If textutils.is empty, need to get the text value of the ET name. This value cannot be empty. Let's show a toast message in the else block. Now I am going to get the user input to a bundle. Bundle equals to binding.etname.text.toString. Now let's write codes to navigate to the email fragment. Here we need to insert bundle as an argument. That's all we need to do for the name fragment. Let's now open the email fragment. Here, first of all, I'm going to write codes to get the username from the arguments. This is the key we provided. We need to use it here. Then we will implement the quick listener of this submit button. Let's add a validation for the email edit text. Again, we are going to use textutils.isEmpty with not operator. Let's add a toast message for this else block. Let's say email field is empty. Then we can even add the validation to check if the entered email is in the correct format. This is how we do it. If patterns.email address .matcher binding.etemail.text matches. Else, let's add a toast message here. Then here I am creating a bundle to keep both the name received from the previous fragment and the email address inserted by the user in this fragment. Well, bundle equals bundle of. I am providing the key as username to input name. Then let's provide the key as user email to binding.etemail.text.toString. This way of passing data from one destination to another is not that efficient. Actually, it is not the recommended best practice for larger sets of data. We should only pass a small amount of essential data like an ID or a preference number. We should always try to get other data using a ViewModel. When we are creating larger complete project examples, we will always follow that best practice. Then here we will get the nav controller instance from the view and invoke the navigate function, passing action ID and this bundle as arguments. it.findNavController.navigate r.id.action email fragment to welcome fragment bundle. So this is the code we need for the email fragment. Then let's open the welcome fragment. Here I am going to write codes to receive the user input name and email from the arguments. Well, name equals require arguments dot get string. This is the key. Well, email equals require arguments dot get string. Let's copy the key from the email fragment. Next, I am going to write codes to display this name and email values on these text views. Since we have 3 view binding parts, it is more efficient to use binding.apply here. tv welcome name dot text equals name. Seems like there is a mistake. Let's check the fragment welcome.xml file. This text view should change as tv welcome email. Let's do it now. tv welcome email dot text equals email. Finally, I'm going to implement the click listener of this view terms button. Here, let's write codes to navigate from welcome fragment to the terms fragment. Alright, so this is the good time to run the app and see our works in action. Let's click on the sign up button. Okay, I'm pressing back. Let's click on the terms button. Okay. I am entering a name here. Then let's enter an email address. Press on submit. Welcome screen appeared as we intended. View terms button works as well. Let's also test the validations. This is the validation for empty field. This is the validation for email format. Validations are also working well. Our app is working as we expected. So that is my solution code example for the coding challenge. Alright, congratulations. You have successfully completed Android Development for Beginners 7-day bootcamp. Now you have all the foundation knowledge you need to start building Android applications. And I believe you all downloaded my Android interview questions pre-ebook using the link I have provided in the description. If you haven't downloaded that, please download it now. It's 100% free. If you have studied that ebook and if you have followed this entire course, now you have enough knowledge and skills to apply for Junior Software Engineer Android or Junior Android Developer jobs. Also, you can start developing Android applications as a freelancer and make money from clients. And if you have a creative app idea, now it's good time to start building your own $1 million application. And I invite you to use the discounted link given below and join my Advanced Android Development Bootcamp at Udemy. In that course, you will be able to master all the advanced Android development topics and professional best practices with very easy to understand tutorials and complete project examples in a very short period of time. My Udemy course will save your valuable time and spare the pain of self-studying. If you don't have money to join my Udemy course, it's not a problem. I have provided many free references in the description of the course. Please use them and do your own self-studies. I am 100% sure with the foundation knowledge you gained from this course, you will be able to do your own self-studies and become an expert in Android development. Thank you so much for following my course. Thank you so much for listening to my tutorials. I really appreciate your commitment to learn Android development, to learn and grow new skills. I wish you all the best. I wish you all the success. Thank you so much.